cell.dwg. On the screen in front of you, you can see AutoCAD Mechanical 2023. And in the drawing area, there's a robot handling cell.dwg file. AutoCAD is the world's most well-known computer-aided design or CAD application. It also comes with 7 specialized toolsets. One of these is the AutoCAD Mechanical toolset, often known as AutoCAD Mechanical. It provides a highly usable interface for mechanical designers to develop their designs and ideas, using a mechanical browser to itemize components and assemblies. Here's the mechanical browser over on the left-hand side. It also comes with an extensive library of standardized mechanical blocks for easy design reuse. You'll find these on the Content tab here, like so. Not only does the AutoCAD Mechanical toolset allow you to visualize your mechanical designs, but it also allows you to communicate them by plotting your mechanical drawings in both hard copy and electronic formats, such as PDF. At first glance, the AutoCAD Mechanical toolset looks like a complex undertaking, which can be daunting for the first-time user. Using your existing AutoCAD skills, gained from other AutoCAD courses in the library, this course will get you using the processes needed to use AutoCAD Mechanical effectively. As you work through the course, you will get used to the methodologies in the AutoCAD Mechanical toolset and build up your muscle memory so that these skills become second nature. You'll also learn some neat tips and tricks from me on how to use AutoCAD Mechanical smarter, not harder. So join me, Sean Bryant, and let's get into the essentials of the AutoCAD Mechanical toolset. Here's what you should know before you take this AutoCAD Mechanical toolset course. You should know your basics of AutoCAD, and to do that, you should have taken the Learning AutoCAD course in the library. Ideally as well, you should have taken the AutoCAD Essential Training course for any version of AutoCAD in the library too. This will have then built up your basic AutoCAD knowledge, because you do need a good working knowledge of AutoCAD commands and methodologies before you take this AutoCAD Mechanical toolset course. We're going to be moving into intermediate and advanced AutoCAD Mechanical toolset methodologies. So knowing all of that base level AutoCAD knowledge will be to your advantage. A good working knowledge of mechanical drafting is preferred. So if you're working in a mechanical industry or for a mechanical company, this is the ideal course for you. It's ideal for all intermediate and advanced AutoCAD users. We don't recommend it for beginners. If you're a beginner to AutoCAD, go and do the Learning AutoCAD course and the AutoCAD Essential Training course first, and then come back to this AutoCAD Mechanical toolset course. The exercise files for this AutoCAD Mechanical toolset course are provided in a zip file with the course. All exercise files are stored in the LinkedIn Learning library, and you can download that zip file from the library to a known location, perhaps on your hard drive, on a server drive, or a cloud drive. I will let you know what you need for each chapter and video as we work through the course. So for example, if there's a specific folder or drawing that you need to locate for that particular chapter or video, I'll let you know. Any drawings will be in an AutoCAD DWG file format. That's the native file format for AutoCAD and all its associated toolsets. In this particular course, all of the files are saved in an AutoCAD Mechanical 2023 DWG file format. It is specific to the AutoCAD Mechanical toolset, and it is specific to this particular version of AutoCAD Mechanical, which is 2023. Each chapter uses its own AutoCAD Mechanical DWG files. So when you download the exercise files, the zip folder will have subfolders broken down by chapters so that you know which files go where. Ideally, you should download the exercise files before starting the course. Locate them somewhere where you know you're going to be able to find them, and ideally open up each exercise file as you go, as you work through each video in the course itself. If you've used previous versions of AutoCAD, you may find that the AutoCAD Mechanical 2023 interface is a little bit different. It has been changed quite dramatically over the last few versions of AutoCAD. And what you'll find is with each annual release of the AutoCAD Mechanical toolset, Autodesk have enhanced various features, functions, etc. One of the things you will notice if you've used older versions of AutoCAD is the interface has changed dramatically. It's gone for this darker grey colour known as the dark interface. So you've got the dark background in the drawing area and you've got the dark background here up on the ribbon as well. You may also not be used to the new ribbon interface as well. So up here we've got the quick access toolbar and underneath that we've got the ribbon interface here. And you can see we've got various tabs available in the AutoCAD Mechanical toolset that differ from the original AutoCAD, the regular AutoCAD. So you'll notice if I go to the Home tab on the ribbon, there's things like construction lines, details, and so on. You've got annotation, it's different functionality in the annotation. For example, there you've got bill of materials. If I go to something like the Content tab, this is something you would not get in your regular AutoCAD. So you've got all the libraries here. You've got the content libraries, the fasteners, the holes, shafts, parts, motors, etc. All of this functionality is built into the AutoCAD Mechanical toolset. And it's built on that good old-fashioned AutoCAD engine that we know and love. But there's a lot more functionality here. This is why we've got the AutoCAD Mechanical Toolset course, so that you can learn on top of your regular AutoCAD skills and become more industry specific using the AutoCAD Mechanical Toolset. You'll notice the icons are a lot more functional now in the new interface as well. So you'll notice if you go and look at something like the fasteners panel here, the screw templates and screw connections, they're all very obvious what the icons do. It's the same with the holes here. You can see a through hole, a blind hole, etc. So all the icons are very representative of the commands or blocks or libraries that they're taking you to. If I jump back to the Home tab again here on the ribbon, you'll see that you've still got the regular AutoCAD functionality as well though. So you've got things like the Draw panel, the Modify panel, the Layers panel. They're all in there, but they're all working with this new enhanced AutoCAD Mechanical toolset interface. So let's get going now and have a look at AutoCAD Mechanical and get into it as we work through the course and utilize this new AutoCAD Mechanical 2023 interface. I did mention previously in the introduction about prerequisite courses that you really should take in the library before you consider this AutoCAD Mechanical Toolset course. So here's a list of the AutoCAD prerequisite courses that are recommended before you start this course. We're using a new AutoCAD course structure. So we've got the Learning AutoCAD 2023 course. That gives you a basic methodology knowledge of AutoCAD. So you know roughly how things work, where the regular icons are that you would use on a day-to-day basis. We also have the AutoCAD 2023 Essential Training course in the library too. That dives deeper into the regular base AutoCAD 2023 application. It's a really good course to take before this AutoCAD Mechanical Toolset course. It teaches you all of the methodologies and naming philosophies in AutoCAD. There are other AutoCAD courses that can be recommended as well. There is a previous version of this particular course. It's called AutoCAD Mechanical Essential Training, and it refers to the older versions of the AutoCAD Mechanical toolset. So if you're not using the latest version, AutoCAD Mechanical 2023, there are some previous versions of the course in the library at the moment. Be aware that courses do get superseded though, and sometimes get archived from the library. So it's always worth making sure in your LinkedIn subscription that you've playlisted those particular courses. You've actually put a link there and you start taking that course. That way you'll always be able to go back to the course and utilize the course later. We've also got the AutoCAD electrical toolset for the 2023 version. If you're working in mechanical, you quite often work in electrical as well. So there is an electrical toolset course that might be of benefit to you. And coming up, there is an AutoCAD 3D modeling for mechanical design course. It's to be released soon. It will be worked on shortly, and that will be coming out in future months and future releases. But as you can see, there's a number of prerequisite courses that I recommend as the author of this particular course that you really ought to get your teeth into. And they are predominantly Learning AutoCAD 2023 and AutoCAD 2023 Essential Training. If you've taken those two courses in the library, this AutoCAD Mechanical Toolset course is the ideal next step up if you're working with mechanical tools in AutoCAD. We're starting a new chapter now, and I'm going to take you through the AutoCAD Mechanical Toolset interface in a little bit more detail. So, as I said in the introductory videos, we are using AutoCAD Mechanical 2023, the latest version. So be aware that the interface is for that specific version of the AutoCAD Mechanical Toolset. Now, I'm just going to take you through the interface and give you a general overview. And then in the next few videos, we're going to go through and look at things in a little bit more detail. So the overview is very much similar to your regular AutoCAD. Up here, you've got your application menu. So if I click on the AMEC icon there, there's the application menu. Click on the AMEC icon again, the application menu disappears. Looking across here at the top, you've got your quick access toolbar, you'll notice, with the regular sort of icons like new, open, save, save as. You've also got open from web and mobile and save to web and mobile if you're using the AutoCAD web and AutoCAD mobile apps. Now, the interface itself is remarkably similar but different to regular AutoCAD. So at the top here, you've got the title bar, you've got your info bar here, where you can use help and search for display results there. You're also logged into your Autodesk account there, just as you are in every other Autodesk product. You've also got your help screens over here, like so. So they're all in the same place. That's the user experience that Autodesk want you to have. The user interface is similar to everything else. When we jump down to the ribbon, though, we've got the tabs here. We've got the Home tab, the Insert tab, Annotate tab, and so on. And as you click along these tabs, you'll see there's a lot of content here that does not exist in your regular AutoCAD. This is why we want you to do those regular AutoCAD courses first, so that you're up to speed with AutoCAD in general, generically, and then you can start looking at all of the different AutoCAD mechanical nuances in this particular toolset. You can see there's a lot in there. There's output, there's add-ins, there's all different things you can collaborate, just like you can in regular AutoCAD. But for example, the content tab, that's a really important one. That's all content coming from specific content libraries for the AutoCAD mechanical toolset. Moving down into the drawing area is very much the same. You've got your view controls up here. So there's my 2D wireframe and my visual styles. There's all my different views there, my standard AutoCAD views. Now, if I just hit escape to lose that menu, we've got the robot handling cell in place at the moment. That's one of the sample drawings that comes with the AutoCAD mechanical toolset. I've just got a drawing open because it's easier for me to show you all of these tools. We've got the view cube over here if we're working in 3D. You'll notice the navigation bar isn't on. Now, to be honest, do you need that? I don't tend to use that. I tend to use the mouse to zoom in and out and pan and so on. And then if I want to zoom extents, it is just a simple case of clicking on the wheel like so. But if I do want the nav bar, I can type NAV like that. And can you see there's all different tools there. There's navigation wheels and so on. And as I come down, there's the nav bar display there. Now, if I want the nav bar on, I just set that value to 1, and there's the nav bar if you need it. So it's nav bar display if you want to use the navigation bar in your AutoCAD mechanical toolset. Now, over here, we have the mechanical browser. Don't close this. It's really important because as you build up the assemblies and the components in your mechanical DWG files, you'll notice that you can start adding things to the drawing itself. So you can see there we've got all different bits and pieces that form this robot handling cell. So we've got the main assembly, we've got the robot, we've got the basement, we've got the gripper assembly, all the clamps, the gripper plates, everything. And if I select one of these, like so, can you see it highlights it in the drawing there? There's the gripper plate in blue at the top there. If I go down to something like the gripper shaft and hover over that, that's showing down there in the plan view towards the bottom of the drawing. So each of these elements in the mechanical browser, you'll see, is basically in essence a block, but it's a lot more enhanced. It's not just a regular block. There's a whole lot of different assemblies and bits and pieces that go together in your AutoCAD mechanical drawings. Down at the bottom, you've got your command line, you've got your model tab, your layout tabs, etc. And down here, you've got your regular status bar with things like your object snaps and so on. There's also some specific AutoCAD mechanical toolset tools. You'll notice there we've got mechanical structure on. We've also got structure selection order on. There's all different tools in there. And also there's an Autodesk Inventor link if you want to link to Autodesk Inventor. And that's all multi-platform technology that links Inventor to AutoCAD Mechanical. So you can see there's a lot of differences there in the AutoCAD mechanical toolset interface as compared to your regular AutoCAD. What we'll do as we go through this course, you'll be using a lot of this interface to develop the various drawings that we've got in the exercise files. So in the rest of this chapter, I'm going to take you through the interface a little bit more in a little bit more detail. You don't need any specific drawing open. You can even have a blank drawing open at this point. We're just going through the interface and where things are and what they do. And then as we work through the chapters, we'll start developing some AutoCAD mechanical drawings. Once again, we're in our AutoCAD Mechanical 2023 application, and I'm taking you through the AutoCAD Mechanical Toolset interface. Now, as I said, I've got one of the sample drawings open that comes with AutoCAD Mechanical, and that's the robot handling cell. Now, you can have any drawing open. There's no specific exercise file for this particular chapter. You can even have a blank drawing open at the moment. It really doesn't matter. I'm just taking you through what the interface does and how to utilize it effectively. Now, we're going to take a bit more of a closer look at the ribbon in AutoCAD Mechanical. Now, something that often happens when I'm classroom training is people have a tendency to click on this little white button here. If I click on that, you'll see the ribbon changes the way it looks. If I click on it again, changes again, click on it again, it almost disappears. You can see the tabs, there they are, but that's it, that's all you've got. Click on that white button one more time, and you're back to the regular ribbon. They're all different ways of displaying the ribbon in AutoCAD. Now, that works in AutoCAD Mechanical, works in regular AutoCAD as well. But quite often, you'll get somebody in the classroom who's learning AutoCAD, they'll click on that button, and they'll panic a little, thinking, oh my goodness, what's happened to my ribbon? So just be aware, it's that little white button there with the up arrow on it. It minimizes the ribbon to different sort of setups and views and orientations and so on. So if you keep clicking it, you'll end up back at your regular ribbon setup like so. Now, as I said, the ribbon is different in AutoCAD Mechanical as compared to regular AutoCAD. So you'll notice that even in the Home tab on the ribbon, there are tools that you wouldn't normally have in regular AutoCAD. So we've got things here. We've got the construction panel, which is ray mode construction lines. And if you click there, there's all these different construction lines, for example. You don't get those in regular AutoCAD, do you? So all of these tools are there to allow you to create your mechanical designs. You've also got here your situations. So you can hide, create, edit situations, which are different assemblies of different components in your mechanical drawings. We've got the regular modify panel there, we've got the layers, but you'll also notice even in the layers here, if I click on this down arrow here, I've got different layers that I can utilize that are mechanical specific in the toolset. Things like hatching, section lines, and so on. Text, these are all mechanical. So you'll notice there, if I hover over text, the assigned layer for that is AM_6 by default. If I hover over dimension annotation, that's AM_5. So these are preset layers that work within AutoCAD Mechanical. I'll just hit escape there to lose that menu. Over here, we've got bill of materials. If I click on that flyout, I can put a part reference into a bill of materials, create a parts list, or actually create, edit, or delete a bill of materials in a drawing. And it actually opens up an entire dialog box stroke palette that allows me to create that bill of materials. And again, we'll work on that as we work through the course. And that's just the Home tab on the ribbon. If I jump into things like Insert, you can see that the Insert one looks pretty much the same, apart from the Library tool here. So there's the Library dialog box that allows you to organize your drawing files in libraries. If I go to the Annotate, you'll see there's lots of new dimension tools. We've got multiple dimension, power dimension. There's also some other dimensions here. We've got a range, and you can see there that we've got different ones like chamfer, where it creates dimensions for chamfers straight off the drawing. We've also got symbols, where we've got things like leader notes, welding notes, all that kind of thing. Balloons for bills and materials, got part references. We've even got title blocks and whole charts and fits lists. There's all different things on the ribbon. Again, we will cover some of that as we work through this particular course. Now, the parametric tab, content, is very interesting. As you can see there, we've got content libraries, all different fasteners, holes, shafts, parts, etc. View, remarkably similar to the regular AutoCAD View tab, as is Manage, as is Output. The add-ins, Collaborate, and Express tools are exactly the same as what you get in regular AutoCAD. And then you've got your featured apps in the Autodesk App Store that you can find online. Now, you'll find that they are specific to the application you're using. So these ones that are being previewed here and highlighted are ones that you would normally use in your AutoCAD mechanical toolset. Now, I'm just going to jump back to the Home tab on the ribbon. I just want to show you a cool thing. And they're called sticky panels, and I love them to bits. They are great. If I click and hold on that Layers panel there, see the title bar? Click and hold and drag, and there's my little Layers panel there floating around in the drawing area. Now, I'm running the AutoCAD Mechanical Toolset on one monitor. But normally, when I'm working here in the office, at my house, at home, I've got two big 27-inch monitors that I work with. So what I can do there is I can move this panel around and perhaps have it on a different monitor, just separate to what I'm working on in AutoCAD Mechanical. The other thing as well is obviously the Layers panel is specific to the Home tab. I want to be perhaps in the Content tab, so I can now change layers before I bring that content into my AutoCAD Mechanical Toolset drawing. Now, I'm in the Content tab, but I moved the Layers panel from the Home tab. So if I hover over it, can you see these little weird icons here? There's one that looks like a T-shape. That's Return Panels to Ribbon. Click there, goes back to the ribbon. It doesn't go back to the Content tab though. It remembers that it's got to go back here to the Home tab on the ribbon. So there's some very cool features there in the ribbon for your AutoCAD Mechanical Toolset. We're staying in the robot handling cell.dwg file, but as I said previously, there is no specific exercise file for these videos in this particular chapter. Now, I've got a drawing file open purely so that I can show you all of the functionality of the interface in the AutoCAD Mechanical Toolset. I'm going to zoom in on this side view of the gripper arm, and as you can see, there's various components there in the drawing itself. So you can see there's various components. You've got the gripper arm is just there. There's the little pneumatic lift there that basically causes that little arm to lift up and lower things and lift things, etc. Now, I'm not going to go into too much detail about how the robot handling cell works, but what I want to cover here is the shortcut menu. Now, AutoCAD has a right-click context-sensitive shortcut menu. Now, it's called the shortcut menu for short, for obvious reasons. Otherwise, we'd be saying too many words for something that is really easy to understand. The shortcut menu is a right-click on the mouse. So with nothing selected, no commands running, if I right-click, there's the shortcut menu. Now, you can see there that I can repeat the last command. I've also got recent input in the drawing. I can use the clipboard. I can use the usual hide and isolate tools that are available in regular AutoCAD. Then it all changes. I've got the ability to edit, erase, copy, power dimension, and power recall. These are all tools that are specific to your AutoCAD mechanical toolset. Now, I'm not going to jump into all of them. We do use some of them during this course. I'll let you explore what they do. But the whole idea is that these tools are built into the AutoCAD mechanical toolset. If I hit escape now, that obviously loses the shortcut menu. So what happens now if I select an object? Well, you'll notice here, I've got some objects here. So if I hover over that, that's a standard part. It's a hexagon socket head cap screw to a particular ISO standard. If I click on it, there's the object there highlighted. Now, if I right click, I get a context sensitive shortcut menu. So you'll notice now I've got all the regular ones here, but now I can edit it in the content editor. I can find it in a browser. I've got power recall. I can turn the center lines on or off. Lots of different tools. I've also got things like select similar. So if I click on select similar, it will select all the other ones available. There you go. There's 4 of them in that particular view in the DWG file. So you can see there that the shortcut menu is very, very different to your regular AutoCAD as well. There's a lot more tools on there. And we will be using some of those as we work through this AutoCAD Mechanical Toolset course. As I've already said for this particular chapter, there are no specific exercise files. Just have a drawing, a mechanical drawing, or just a blank drawing open so that you can work with the ribbon and so on. Now, for this particular video, though, I do need to have a mechanical drawing open. I want to show you how this wonderful tool on the left works, the mechanical browser. Now, there is a mechanical browser open by default when you start up the AutoCAD Mechanical Toolset. Now, as I said, I've got the robot handling cell open as a DWG file at the moment, and that's one of the sample drawings that comes with your AutoCAD Mechanical Toolset. If you go to the Start tab here, there's the Start tab when you first open up AutoCAD Mechanical 2023. If you go to Open here and explore the sample drawings, you'll find there's a mechanical folder. Go in there, Mechanical Structure, and there's all the tools there like so. So you can see you've got things like the gripper assembly, robot handling cell. Now the gripper assembly new.dwg is an external reference file that is referenced into the robot handling cell there. So there's various drawings available. I'll just cancel that. That's where I've got this robot handling cell from. I'm going to go back to the drawing now because I want to show you how this mechanical browser works. Now, it may happen, worst case scenario, that you go up here and you click on that little cross like that and it's like, oh my goodness, where has my mechanical browser gone? Not difficult to get back. All you've got to do is go to the View tab on the ribbon, into the Palettes panel, and there's the mechanical browser right there. It's AM Browser is what you could type. But if you just click on that icon there, puts the mechanical browser back on. So don't panic if you lose it. You'll also notice that you can auto hide it there if you want to. So if I click on that one, it'll hide, and then when I hover over it, there it is there. I don't like the auto hide on the browser. I like it open while I'm working. That's my personal preference. Entirely up to you if you want to put auto hide on or not. Now, I've deliberately wound up all of the technology here in the mechanical browser just to the robot handling cell. And you can see there that it's got an A sort of DWG little red icon similar to the AMEC icon there, just letting you know that it's an AutoCAD model or drawing. So if I hit the little plus sign there, there's all of my different situations and parts of my AutoCAD mechanical drawing. I mentioned situations here. There's all my situations there. So I can create and edit situations. I can unsuppress and suppress those situations. I can also add different parts to the mechanical drawing as I go. Now, the lovely thing about this is if I click on something like, let's say, a plastic tray front. So the front view is this sort of top view here. So there's plastic tray front. If I click on that, there's my plastic tray. And as soon as I hover, can you see, go over the mechanical browser with the pointer, and the front is selected, it highlights in the drawing like that. Now, if I go to the top one, that will show in the top view down below. Now, you've got front, open position top for the gripper assembly. So if I go to front, there's the gripper assembly. If I go to top, there it is in the plan view, like so. And all of those different parts and components are all set up in a lovely, structured, tabular format here. So basically, it's like a little sort of, it's almost like File Explorer for Windows, really, but for a mechanical drawing. And if I come down, there's all different screws, joints, and I can expand those out. So if I look for joint 1 in the top view, there you go. It just highlights, it's just there, just in that area there. Hover over it. Can you see it there highlighting in blue? If I zoom in nice and close, it's that one just there. You can just see it there. If I go down a bit, I've got a gripper plate. If I hover over, click that and hover that, zoom out a bit. I did zoom in a little bit too much there. Hover there. There's the top view there. You can see the blue highlight like so. And again, just be careful on your mouse, like I just did there. I just did a great big zoom on my mouse and zoomed right in by mistake. It does happen, so don't worry about that too much. I'll just double click on the wheel now. As usual, standard AutoCAD technology, that zooms to the extent of the visible drawn objects. But that is your mechanical browser, and you'll be using that as you work through these particular drawings. Now, it's really important that these drawings are kept in a sensible place. And what we're going to do in the next few chapters is I'll make sure that you've got the exercise files that you need for each particular chapter. And again, you download those in a zip format from the linked in library page for this particular course. But that's the mechanical browser in the AutoCAD mechanical toolset. You'll get used to that as you start working with the AutoCAD mechanical toolset more and more. As usual, we're in AutoCAD Mechanical 2023, and I want to talk to you now about your drafting settings in your AutoCAD Mechanical toolset. Now, your drafting settings are located in the status bar down at the bottom right-hand corner of your AutoCAD screen. They're down here, like so. There they all are there. Now, one of the things I will say before we get into anything else on the drafting settings, if you click here on these little three lines, that brings up the customization menu. Now, there's loads of stuff in there that you might want to use. Don't switch it all on at once because you will have a very congested status bar down on the bottom right corner. But there are tools that you might want, coordinates being a prime example. There's coordinates there, so you might switch those on. You might switch on your dynamic input. You might also switch on line weights as well, like so. Now I'm just going to switch those three on, and then you click on the little three lines again, and that means that you've customized your status bar, your drafting settings. So as I move the crosshair around now, can you see there's my coordinates there? And as I move around, those coordinates display quite happily down there on the status bar in my drafting settings. I've also switched on dynamic input. Now, dynamic input, the icon is not normally on now in the status bar by default. I always turn it on because then I can right click on it and go into my dynamic input settings. So we've got things like snap and grid, polar tracking, but dynamic input, you can change the settings of your dynamic input. You can change things like your coordinate format, also your dimension input. You can also change the drafting tooltip appearance, the colors, the size, etc. Now there's lots of tools in there. I don't recommend when you first start out making loads of massive changes to the dynamic input, but it's worth a look. Now I'm just going to cancel the drafting settings there for the moment. That means any changes I've made do not apply. So if I look here, there's my line weight. If I switch that on, notice things do have a line weight on certain layers. Switch it off. Notice the layers go back to a default view. Now, the good thing is if you're plotting the drawing at any point and you turn those line weights on, those lines will plot to a slightly thicker thickness than perhaps these ones here. And the line weights are useful for highlighting objects when you are plotting and printing your drawings. Now, drafting settings don't change much from your regular AutoCAD. So, for example, object snaps here, there's your object snaps like so. You'll notice there's some extra bits though. We have arc radial lines, arc tangent lines, and symmetry. They're new tools in the AutoCAD mechanical toolset. All of these object snaps, though, are your regular object snaps in AutoCAD. If I go to object snap settings, that again will open up the drafting settings dialog box, and there's all my snaps there, like so. Object snaps are on. These are the object snaps that I've got running at the moment. My suggestion is to have endpoint, midpoint, and center ticked, as well as intersection and extension. Just use those as your default running object snaps. That's also covered in the AutoCAD Essential Training course for 2023. We've also got the object snap tracking on. Now, if you've done your AutoCAD Essential Training, you'll know all about object snap tracking, where you can basically hover over two particular object snaps and find the intersection between them using your polar tracking. So that's another tool that's very useful. Again, make sure you've covered that in your AutoCAD Essential Training. I'll just cancel the drafting settings dialog for the moment again. Now you'll notice as you come along the status bar, there are some new tools in the AutoCAD mechanical toolset. You've got the mechanical structure is on. You've also got structure selection order from bottom up. You can also switch that to top down. That's all about here, your structure order here in your browser. And also you'll notice here that you can lock the selection. You'll also notice that the reference lock is on, which is your external reference files. That's what I mentioned earlier. And you can also have an Autodesk Inventor link as well, which is part of your drafting settings. But all of these, if you right click on them, if you've got a menu for them, it'll actually come up on the screen. Now you notice all of these are just on or off toggles. If I'm right clicking on those, nothing happens. But if you come into your regular drafting settings here, like polar tracking, if I right click on that, I can specify what tracking settings I want. I can pick them from the list or go into the tracking settings tab, you'll notice in the drafting settings dialog box. So a lot of the drafting settings are very much like your regular AutoCAD, but there are some extra ones over here on the right on the status bar that work specifically in your AutoCAD mechanical toolset. Once again, we're looking at the interface of the AutoCAD mechanical toolset, in this case AutoCAD Mechanical 2023. Now, in most of the recent versions of AutoCAD Mechanical, and AutoCAD for that matter, you've got your quick access toolbar. It's up here on the top left part of your AutoCAD screen. Now, like I said, you've got the application menu there, which does all what I call your regular application type stuff like new, open, save, etc. Notice as well you can publish, print, you've got drawing utilities, etc. One of the cool ones is you can actually send to a 3D print service if you've got a 3D model. So you could get your 3D model printed. That's one of the cool pieces of technology that's come about in recent years, is 3D printing and 3D modeling. I'll just hit escape there to lose the application menu. And what I want to talk about obviously is the quick access toolbar. Now you can always find the quick access toolbar in any Autodesk application. There's the application menu. It always runs along to the right of it. It's these icons here. So we've got things like new, open, save, save as, open from web and mobile, save to web and mobile. We've also got plot or print, if you want to call it that, undo, redo, and one of them that is specific to the AutoCAD Mechanical toolset is this one, where you can flip windows between various drawings that you have open at the time. Now I've only got the one drawing open, so if I click on that, you'll see it gives me a big long file path, but there's my robot handling cell DWG. If I have more than one drawing open, I could obviously toggle between the drawings that I've got open at any given time. Now you can also share your drawings here. If I click there, that's on the quick access toolbar, that will allow me to share a link to this drawing using AutoCAD Web. You'll notice there web.autocad.com. I can send a view only or an edit and save a copy version of this drawing to someone else. That link can then be sent. I copy the link, pop it in an email, send it to them, and they can open it in the AutoCAD Web application. Now, I have got other courses about AutoCAD Web in the library if you do want to check out AutoCAD Web in more detail. I'm just going to close that now, click on the cross there, and that disappears. Now, the quick access toolbar is predominantly the icons that you use regularly on a day-to-day basis. So, for example, there's the layers panel there on the home tab. But I might be working in the content tab, so I haven't got access to my layers straight away. I've got to go back to the home tab and change my layer or my layer settings here in the layers panel. If I go here on what looks like a little sort of eject CD icon, for those of you that are old enough to remember CD players, obviously, if I click there, I can add different regularly used commands to the quick access toolbar. So if I put layer there and just click on the word layer, there's my layers, there's my layer drop down, all available for me in the drawing. I don't have to keep going now to the layer drop down here on the layers panel. Very quick and easy. I can be in the content tab. I can then change my layer accordingly and change the current drafting layer to whatever I want it to be. Let's say AM6, for example. That's probably not the right layer for a fastener, but I can change that layer very quickly and easily. Now, if I go back to that little eject symbol again, I can also go into more commands here, like so. I can also move the quick access toolbar below the ribbon as well. I can show the menu bar if I want to. But if I go more commands, this will open up the CUI, the customized user interface, and there's all the commands available to me in AutoCAD Mechanical. There's quite a few, by the way, when you scroll down that list, but you can add any of those to your quick access toolbar if you need to. I'm not going to. I'm going to click on cancel. And as you can see, the only one I've left up there is the layers, which is incredibly useful because I've got my layer drop down at the top of the screen all the time. Now that layer tool there in the quick access toolbar is also available in your regular AutoCAD as well. You can drop that layer into the quick access toolbar so that you've got constant access to your layers in your DWG files. But that's pretty much the quick access toolbar in a nutshell. The whole idea of it is it's just got that group of icons that you use all the time, things like new, open, save, save as. It just saves you having to go up to something like the application menu here, and then I have to hover over save as and save as a drawing, etc., etc. So the whole idea is that it's just a quick icon click to save or save as, for example. So that's the quick access toolbar in your AutoCAD mechanical toolset. Not much different to the quick access toolbar in your regular AutoCAD, but again, there are tools in there that potentially you could add that might be AutoCAD mechanical specific. We're starting a new chapter now, and we're taking a look at object property and layer management. Now, you'll recognize the drawing that I've got in this particular video, but I've named it ever so slightly differently. It is called robot001.dwg. So you'll notice the name of it there at the top of the screen. You can download this one from the library and open it up in your AutoCAD mechanical toolset to follow along with the videos in this chapter. Now, remember as well, please, that it has an external reference file attached to it. So you need to make sure that you've got robot001.dwg and the reference file in the same folder. If I go to the Insert tab on the ribbon, go to the Reference panel here, and just click on the little arrow here, it shows me there that the gripper assembly is loaded as a reference file. So I'm just going to make this a bit bigger for you. There you go. So you want robot001 and gripper assembly new in the same folder. Then when you open up the robot001 drawing, the gripper assembly new file will be loaded as a reference automatically because it's using what they call a relative external reference file path. So as long as these two files are downloaded from the library and put in the same folder, when you open up the robot001 drawing, the gripper assembly new drawing will be used as a reference file. I'll close the external references palette now, and we'll get on to working with these layers and property management in your AutoCAD mechanical toolset drawings. If I jump back to the Home tab on the ribbon and go to the Layers panel, you'll see there's a little icon here with a little cog on it. It's the Mechanical Layer Manager. Now, layers are managed somewhat differently in your AutoCAD mechanical toolset. For one, when you open up your Layer Manager, it's somewhat old-fashioned. It's a dialog box and not a palette this time. That's because it's using very different technology. I'm just going to expand it, make it a tad bigger for you. And you'll notice here you've got things like on, and you've also got freeze and thaw, and you've got lock. So you'll notice there on and off, freeze and thaw, and lock, just like you have in regular AutoCAD. But you'll notice these layers have a very different icon to a regular layer. There's your regular layers right there with the little blue sheets next to them. And as you come down as well, there's the gripper assembly new external reference layers, the ones in the reference file. So what's going on with these ones with the little cogs next to them? Well, the thing is, the way that layers work in AutoCAD Mechanical is somewhat different because the objects define the layer. Now, the reason for that is, if I click on this flyout here, I can add a layer definition as well as a new layer in my Mechanical Layer Manager. Now, I'm just going to make this little column here a little bit narrow. Well, let's bring that back in. There's the associated objects there. So what's happening is when you create a layer definition, you can say to AutoCAD Mechanical, okay, I'm going to use this particular layer for, let's say, a hidden line or a standard part line, a contour line, or I might need a section line. So if I look at, say, AM10, when I actually create a section line from the ribbon up here, it'll automatically put that section line on the layer AM10. And what you're doing here is you're adding definitions to the layers. So the whole idea is that the layers are controlled by what objects you're creating in AutoCAD Mechanical. So you, like I said, you've got your mechanical layers there, your regular layers are there, and as you come down that list, you've also got, as you can see, your reference layers, which again are just regular layers with the little regular little sheet symbol there saying it's an ACAD layer. If I hover over that, it's a mechanical layer and it's non-replicated. That's that little red marker there. If I hover over one of these, it's just a mechanical layer, as you can see. So those mechanical layers have definitions. Now I'm just going to cancel that for a moment. The reason for this is if I go to the content libraries on the content tab and I bring in any of these like fasteners, holes, shafts, parts, motors, etc., they will all come in on their own layer. And that's the whole idea of AutoCAD Mechanical. You don't want to be messing around going, oh, which layer does that go on and what layer does that go on? It's automated it to save you time. If you do your regular AutoCAD Essentials course, you'll notice every time you draw something, you need to have the current drafting layer set to the layer you want the object to go on. In AutoCAD Mechanical, in the mechanical toolset, you don't need to do that. However, you can still jump into the Home tab there, go to the layer drop-down and select the layer that you want to use. I might want to use AM5. There it is. It's now the current drafting layer. Also, remember, on the Quick Access toolbar, I set up the layers there, so they're there as well. So there's layer AM5 again, and you'll notice it's the current drafting layer up there too, for obvious reasons. But as you can see, if I now jump in here and click on the Mechanical Layer Manager, AM5, if I look at that, will be a diagonal cross, and if I expand that out a little bit, it's for planes and dimensions and things. So you can see there that I can start adding layers as I go, and as I start adding other previously defined layers from the tools in the ribbon, you'll find that these layers get added to, these mechanical layers that you're using. And you can see they use different line types, different line weights, and so on. Some of them plot, some of them don't, and if I come across here, can you see replicate in layer group? And also we've got this one here. We can override the color if we want to as well. So there's all different tools there. So that's overriding the color of any layer that I might put in and so on. So there's lots of different ways and means of setting this up. So if I click here and go to new layer definition, you'll see there's my layer like so, color white, continuous, default, and I can replicate it in the layer group. And if I come across a little bit more on the slider bar, you can see there associated objects. I can add that information to that new layer. Now I don't want to keep that layer, so what I'll do is I'll just slide across here like so. There's layer 1 there. I don't want that anymore, so what I'll do is I'll just right click on it and I can delete the layer. There's the layer definition there, delete layer definition. It works in the same way as delete layer does in regular AutoCAD. But those layer definitions are really important because what they do, obviously, is define objects rather than just a layer. So that's how your Mechanical Layer Manager works in your AutoCAD Mechanical toolset. I'll just click on Cancel now, and we'll start looking at other tools within your AutoCAD Mechanical toolset as we go. We're staying in our robot001.dwg file, and we're going to take a look now at automatic property and layer management. Now, when I say management, the AutoCAD Mechanical toolset manages this for us. Now, I did mention about how the layers are often defined by the objects that are in the AutoCAD Mechanical drawings. Now, we're still in our robot001.dwg file. I'm going to zoom in onto the sort of area here that shows the gripper assembly for the robot arm that we're looking at. Now, this is basically a robot handling cell. So you can see the robot arm is here, and these little gripper bars here pick things up and move things around. So these little arms open up and pick up this object here. Now, this object here, if I click on it, you'll see it's just a line, and you can see it's on layer 0. But if I click on something like this here, like one of these bolts, you'll notice there that it's on the layer AM_0N. So basically that is using that automatic layer management and control. Now that particular screw there, if I hover over it, it will let me know. Can you see it's a hexagon socket head cap screw to ISO 4762, and the size is M6 by 60. So basically that's a 6mm diameter screw and a 60mm length. Now that's great. We know what that is, but it's on its own layer and it's been brought in that way. Now, what I can do is I can go to the Content tab here, like so. And I'm going to go to this little icon here in the Fasteners panel. And that is the screw or bolt from the Content Library icon. So when I click on there, give it a few seconds to load up because there's a lot of these in the library. Trust me, when you start investigating this, you'll wonder how you didn't get by with all these libraries without them in the regular AutoCAD. Now, there's all the different types of screws. So I'm going to go for, say, a hex head type there. If I click there, that'll expand that out. There's all my hex head types. If I expand it again, I've got all different types of heavy hex bolts and so on. They can be flanged and fine thread and regular thread, and on we go. So if I look at something like a heavy hex bolt, UNF, that's a fine thread and that's in inches. And I'm going to go for the front view of that one. That now brings that in to the drawing. And it brings it in like it would a regular AutoCAD block. It's asking for an insertion point. So I'm going to zoom in here. I'm going to use that midpoint snap there as my insertion point. I'll left click and just bring that line vertically downwards so the bolt goes vertically down towards that polar tracking line. If I left click again, now it says to me, well, what type of diameter do you want for your heavy hex bolt? I'm going to go for something a bit big, 1.5 inches there. And I am mixing and matching here a bit with units. This is an imperial bolt that I'm bringing into a metric drawing. I'm not going to worry too much about that because I'm going to delete it again in a minute anyway. So when I click on finish, there's my big bolt there. And you'll see, look, it actually works like a dynamic block. So I'll bring that down a bit and click there. And I've basically made sure that that is added to the drawing. Now you'll notice when you bring in these objects into your AutoCAD mechanical toolset drawings, you can add a situation here. So the situations can hide objects that you don't want people to see. So you might have a situation where, yes, this bolt is shown, but another situation where this bolt is hidden. Now I'm just going to cancel that for the moment or cover situations later on. But there's my great big bolt there, and it is way too big. I've deliberately chosen it so it's huge. But you can see it there. Look, there's the bolt there. Now, if I go back to the Home tab on the ribbon, can you see that selected bolt is on the AM_0N layer as well? And you can also see it on the drop down here on the Quick Access toolbar as well. And that's purely because I'm replicating that drop down there on the Quick Access toolbar. But you can see how quick and easy it is to drop something in from the library, and it comes in on its own layer. You do not have to define the layer, and that's that automatic property stroke layer management that I'm talking about. And it's one of the major automation benefits in your AutoCAD mechanical toolset. So with that bolt selected, I'm going to right click, and on the shortcut menu, I'm just going to go to erase. I don't need that in the drawing anymore, and off it goes, it disappears. And then I'll zoom out slightly so that I can see my robot handling arm again, like we did before. But that covers how that automatic layer stroke property management is handled in your AutoCAD mechanical toolset. It does it all for you so that you're not worrying about what layer these objects go on. We're going to take a look now at controlling the layers and layer display in our AutoCAD mechanical toolset drawings. What I've done is I've zoomed in to the top part of the robot arm in the robot001.dwg file. We're looking here, so I've zoomed in nice and tight on this bit here. I'm going to place it all the way over here to the left, because what I'm going to do is then go to the Home tab on the ribbon, and I'm going to open up here our Mechanical Layer Manager. Now, I'm deliberately doing this and placing things on the screen in certain places because I haven't got much screen real estate to work with. Now, what I want to do is show you how these layers work in your AutoCAD mechanical toolset. Now, obviously, we've got the mechanical layers. They're the ones that have that layer definition, as you can see. They've got the associated objects here, like so. So, for example, if I turned off a specific layer, objects would disappear on the drawing. Now, at the moment, you can see there's AM0 there. Now, what I can do is I can set the current layer very quickly and easily by just double clicking there. Can you see it's got the green tick? So the current layer is now AM0. If I go to AM5 and double click there, the current layer is now AM5. Now, what I'm going to do is show you that the display of the layers in your AutoCAD mechanical toolset is pretty much the same as it would be in your regular AutoCAD. There's layer AM0. Now, AM0 forms part of these screws here that we've got in our robot arm in our drawing. So there's layer AM0. If I click on that sun symbol, that freezes that particular layer. I have to apply that though. If I click on apply, can you see certain objects disappear? Now, if I come down here to layer AMON, if I click on the sun symbol there, see there's the snowflake like so. Again, I click on apply and the objects disappear. So you'll notice various objects in the drawing have disappeared. And to switch them back on again, it's exactly the same workflow. So I click on the snowflake, turns to a sun symbol, click on apply, the objects come back, click on the snowflake, click on apply, the objects come back. If I want to turn the layers on and off, the workflow is very much the same. I click on the little light bulb, it goes blue, click on apply, you'll see the objects turn off in the drawing. Again, AM0N, click on the light bulb, click on apply. They disappear again like they did in the previous drawing. Now, what we're going to do is click on OK, and you'll see those objects disappear like so. When I click on OK, everything that I've turned off disappears. Now, what you've got to remember here is a lot of these objects are controlling the layers that they're on. So if you freeze the layer that the objects are on, those objects are going to disappear, just like they would in regular AutoCAD, but it behaves just that ever so slightly differently with that apply and that OK in the dialog box. So if I click here again, you'll see those layers are still off there. So there's AM0. I'll switch that back on, click on apply, and there's AM0N there. I'll switch that one back on, click on apply, click on OK. Everything comes back and reverts to normal. Now you'll notice that things like line types and colors change when you do this. That's all to do with that hide situation thing that you've seen previously, because what you're looking at right now is a certain situation in your AutoCAD mechanical drawing. So for example, you might want all of these purple screws showing on this hidden detail dashed layer to disappear in a certain situation. So you're looking at a side view of the robot gripper arm, for example. And those situations can be set up separately with different sets of layer controls. Now, we do get into that later, so don't panic about that right now. But what I'm trying to get across is the behavior of the layers and the layer control is remarkably similar to the regular AutoCAD settings. Just remember though, it is a slightly more old-fashioned dialog box, and you do remember to click on that apply button and then click on OK. And then you'll find that things do change slightly sometimes. You'll also notice in the Mechanical Layer Manager that we can check layers. We can also move into layers. That hides the dialog box to enable you to select the objects and move them to the layer that is selected in the list of layers. And you've also got here tools to highlight as well. So notice there I can highlight what is on the layer. I can press escape there or return to continue. So if I press escape, everything goes back to normal, dialog box disappears. So there's lots of little tools there in the Mechanical Layer Manager that are somewhat different to the regular AutoCAD, but they also give you a more enhanced methodology of working with your AutoCAD mechanical layers. We're staying in the robot001.dwg file. And as you can see, I've zoomed to the extents of the drawing in the drawing area. What you'll also notice, if you go to the Home tab on the ribbon, in the Layers panel, our current drafting layer is an AutoCAD mechanical layer _5, AM _5. So that's our current drafting layer. Now, in that Layers panel, there's a little flyout here. If you click on it, you can go and pick what type of object you want to draw, and the AutoCAD Mechanical toolset will set the appropriate layer automatically. So I want to draw a center line, like so. So you'll notice it automatically moves me to the appropriate layer, which is AM _7. If I open up my Mechanical Layer Manager, and I'll just bring it to the center of the screen, there's AM7 there, like so. There's our layer. And you'll notice that the current layer is AM7, tells you at the top there. And if I just look across that layer, can you see it's used for center lines? So that's our layer definition, and it's defining center lines. So if I want to draw a center line using that drop down, it'll use the layer definition and put me on layer AM _7. I'll click on OK. Let's zoom in on the base area of the side view of the robot arm. And let's say that I do want to draw a center line using that AM7 layer. I'm just going to go to the Home tab on the ribbon, into the Draw panel, and click on the Line command. Now, it's asking for the first point. I'm going to use that little midpoint snap just there, left click, and just drag vertically upwards using my polar tracking. Take it through the base there to about there and click. I'll just press Enter to finish. And what I love about this, look, it is on a center line type. You can see it there. There's the center line type. It's cyan, and it's done all that for me. I don't have to think about the layer, the line type, the color. It's all done using those tools in your AutoCAD mechanical toolset. And that's how clever it is. So if I click on that now and right click and go to properties, you'll see it's on layer AM7, and it's using by layer, by layer, by layer. So it's using that AM7 layer, that AM_7 layer, and all the properties of that layer for that line. It's that quick and easy. Now, with that line still selected, I don't actually need it. It was just to show you that it's putting it onto that center line type on the AM_7 layer. So with it selected, I'll just right click and on the shortcut menu, erase it accordingly. And then good CAD etiquette is to double click on the wheel and zoom extents. So the next person that might use this drawing can see everything that's going on in your robot 001.dwg file. We're starting a new chapter now on how we organize our mechanical drawings in the AutoCAD mechanical toolset. We've got a drawing for you. It's robot001.dwg, and you need to make sure that you download the robot001.dwg for this chapter. Also, make sure that you download the external reference file that is attached to the robot001.dwg as well. Now, the way that you can check that is just jump to the Insert tab here and go to the Reference panel and click on this little arrow here. You need to download these two drawings for this chapter, Robot 001 and Gripper Assembly New. And just make sure that they are in the same folder, because the Robot 001 has a relative reference path to the Gripper Assembly New. If they're both in the same folder, you should be fine. I'll just close the external references palette. So when you open up your robot 001.dwg file with that Gripper Assembly New in the same folder, you shouldn't have any problems with the robot 001.dwg. Now, the other thing you will need for this particular chapter is your mechanical browser. If it's not there and it looks like this, simply go to the View tab on the ribbon, over to the Palettes panel. You want this icon here, Mechanical Browser. That'll switch it on. Now, you'll also notice as well that I've expanded out all of the elements in the mechanical browser. Now, there's a reason for this. I want you to see how these creation workflows work in your AutoCAD mechanical toolset. When you're building up all the elements of, say, this robot arm in a drawing, you want to make sure that they're all related to each other. And that's where this mechanical browser kicks in. Our main drawing is here, and then we've got all different elements of our mechanical assembly. We've got main, which is the parts list. That's the main drawing. We've got robot 1, which is one part of it. If I click on it, you'll see it highlights there when I'm in the mechanical browser. If I come outside the browser, obviously it disappears. If I right click on robot 1 and select in model space, it selects all of the robot assembly, like so. I can hit escape just to deselect it, just as you do in regular AutoCAD. If I, for example, selected only the top view, you'll see the top view, if I hover over it in the mechanical browser, is showing there towards the bottom of the screen. Again, if I right click and select in model space, it selects all of those elements that make up that top view of the assembly robot 1. So what you're doing is you're allowing this mechanical browser to form a nice functional flow, a creation workflow of all the different elements of your mechanical drawing. I'll just hit escape there to deselect that robot top view. Now, the nice thing is, if I click on something like Robot 1, like so, and then I right click on it, I've got the option here to either insert existing components that I've already created in the browser, or I can add a new component. So I've got different types of new here. I can add a component view, say top or front, and I can also add an annotation view where annotation might be added as well. I'm just going to select component, and there's my new component name. So let's call that, say, rectangle for now. Now, I'm not going to add a component at this point. I'm just going to show you the workflow. So that's my new component name. So I press enter. Now, the new view name could be top, front, or whatever. I'm just going to type in front, like so. So there's my front view. That's my view name. If you look at the mechanical browser on the left, Robot 1 has a top view, a front view, etc. I'm selecting the front view of this. So I would then go into the DWG file and select something from the front view over here, not the top view. That's the top view there. So I'm selecting something from the front view. So I press enter after I've typed front, and then it asks me to specify the parent view. Now I need to specify the parent view there by typing it in. So I could potentially type in Robot 1 if I wanted to. So if I type in robot:1 like that, make sure you type it correctly, otherwise it won't apply it to the view in the browser. So there's my parent view, Robot 1. So if you look at Robot 1 in the mechanical browser, you've got a parent-child relationship. So the parent view is Robot 1. I've created a new front view of a new component called rectangle. I haven't selected any objects to apply to that, if you see what I mean, but obviously I would, and that would then create this creation workflow in the mechanical browser. I'm going to hit escape there because I don't want to mess up my mechanical browser creation workflow. But you can see how you can just add to this and keep going. There's all these different views and components. Can you see there's clamp 1 there? So there's clamp 1. Can you see it highlighting up there in the front view at the top? So if I right click there and select that in the model space, there they are. There's the grips there where they're selected. They're also down here because I've selected clamp 1. I've selected the actual component and the two different views of clamp 1. So you can see there I've got a top view, a front view, and a front 2 view. So if I now select the front view like that, and then right click and select in model space, the front view is the only one there. If I hit escape to deselect everything, there's the front view and it's highlighting. Can you see it at the top there? So what I'll do is I'll right click, select in model space, and bear in mind you do need to deselect before you go back to the mechanical browser and select a different view to select in the model space, because you'll notice a few bits on the top view were still selected. So I need to hit escape first, go back into the mechanical browser, right click and select in model space. So if I zoom in now, there's the front view of clamp 1 and it is selected. If I pan down with the little grip there, so there's that little clamp front view right there. And front 2 will be this one here. So if I now select front 2, there it is there. Can you see it's selected over on the right hand side? If I right click on that and select in model space, I've now selected both front and front 2 of those clamp views in the mechanical browser. It just allows you to move around and navigate your assemblies in your AutoCAD mechanical drawings. And the lovely thing is as well, I can right click on that. I can also zoom to it if I want to, and it zooms to the extent of that particular view in the mechanical browser. I'll just hit escape a few times now just to deselect everything and double click on the wheel to zoom extents, and we're back to our full view of our robot drawing in the robot001.dwg file. We're staying in our robot001.dwg file, and in the drawing area, I'm zoomed into the basement area of the robot arm on the front view. Now you can see there that I've got specific objects in that particular area. Now if I click on one of those objects, you can see it's an individual line, or if I click on that center line, it's an individual center line like so on a specific AutoCAD mechanical layer. Now, going back to the creation workflows that we talked about in the previous chapter, I'm going to go over to the mechanical browser now. Now, all of this should be switched on already because you set it up in the previous video. Now, the basement area is here. There's the basement there. If I click on that in the mechanical browser, can you see it highlights all of the objects that make up that basement 1 in that particular assembly in the robot001.dwg file. So all of those elements have been selected and have been applied to that basement component in the robot001 in the mechanical browser. So that's everything. If I just go to the front view of the basement now, that's the same thing. Now, what I've got to look at here is the overall view. So if I just hit escape now a few times and double click on the wheel to zoom extents and then go to that basement one, can you see it highlights both the top view and the front view? So all of those elements that make up basement one have been applied to that basement one component of the robot one here that is in the robot 001 drawing. Now, if I click on top, it will only show me the top view, as you can see at the bottom there of the drawing area. If I click on the front view like that, you can see there's that front view. But if I come out, can you see if I try and click on something here, it's just one line, like so. So one of the benefits you have is if you start applying all of these individual lines, center lines, etc. to your views here in the mechanical browser using those creation workflows, I can hover over that front in the mechanical browser. I can right click on it and select it in the model space. I can then right click again and zoom in, and it's selected and I'm zoomed into it. And all of the objects that make up the front view of basement one in robot one are then highlighted nice and neatly and tidily. And I don't have to worry about that. I don't have to think, if I hit escape there, oh, I need to select this line and then select this and then select this. I don't have to think about that because I've applied it in my creation workflow in the mechanical browser. I know that there's the front view there. I can right click, select that model space, and I've got everything selected that I need to work on for the front view of that basement part of robot one in the drawing. That's a great workflow. Now, they don't have to be organized alphabetically, numerically. You can do that if you want to in the mechanical browser, but just get it sort of into your methodology that what you do is you start from the top, robot one, and start adding a top view, a front view. You've got a basement, an axis. And as you start building these up, start adding them to the mechanical browser. Now you can do that based on what I showed you in the previous video. So for example there, if I go to basement one, right click, I might want to add a new component to that. So I click on component and I start adding that component to this particular part of the mechanical browser. I'll hit escape there, but I can start adding all of these components and adding those properties of those components to my mechanical browser as I go, working on that creation workflow in your AutoCAD mechanical toolset. In the previous video, I showed you how to build up your structure for your AutoCAD mechanical creation workflow. Now that structure is defined in the mechanical browser, but I haven't actually showed you how to add anything or build up that creation workflow yet, how to add a component. Now, the whole idea is as you build up your different elements of your AutoCAD mechanical drawing, you add those to the mechanical browser by adding components. Now, that's the bit I haven't shown you yet. Right now, if we go and look at something like the top view of the basement, if I hover there, you can see there's the top view, there's the front view, like so, and they highlight in the drawing area. And like we did earlier, I can right click on that and select it in the model space, and it stays selected in the model space like that. You then hit escape to deselect it, like you would in regular AutoCAD. So what we're going to do this time is we're going to zoom in on the front view of the basement part of the robot here. What I'm going to do, I'm going to generate a little shield. Now I'm going to make sure I'm on the AM0 layer. That's going to be my current drafting layer, that one there, AM0. So I'll just go to the layer drop down, make sure I'm on the AM0 layer. I'm then going to draw a regular rectangle to act as a shield where the robot rotates here on the axis, and this little shield will protect people from stepping into where the robot is rotating. So I'm going to go to the Home tab on the ribbon, draw panel, there's the rectangle command, click on the flyout, and you'll see there's lots and lots more rectangles in AutoCAD Mechanical. The reason for that is you need to define rectangles all the time, not just corner to corner. Now I am going to use a corner to corner, just the regular rectangle command, that one there. I'm going to click there on that endpoint snap and just come up a little bit, and then I'll perhaps hover over this one and come up a little bit there. Again, I'm just going to go for a random height and click. So there's my little shield there on the layer AM0. There you go, AM0, and there's the rectangle there. Now I want to add that as a component of the overall robot. So if I come over here like this to Robot 001 and right click, I can go New Component. So I start right at the top. It's a new component in the drawing. So I click there. Now the new component name will be Shield. It's a shield. So like so, let's make sure you spell that right. I before E, except after C. Press enter. Now the new view name this time, it's the front view. So I'm going to go Front, front, like that, and select object for the new component view. So I'm going to select that little rectangle there, press enter. It'll ask for a base point. I'll utilize that little endpoint snap just there. So that has now been added as a component in my AutoCAD mechanical creation workflow. And you'll notice down here in the mechanical browser, Shield 1, there it is there, and there's the front view there like so. So I can click on the front view. Now, if I just come out of the mechanical browser, that obviously doesn't highlight, but if I right click on it, I can select in the model space like so, and there we go. It's selected in the model space, and there's the base point that I specified. I'll just hit escape a couple of times now just to deselect that. Now, what I need to do is add another view, don't I? I need the top view. So I'm going to zoom out, and I'm going to zoom down here, and there's the top view. And what I need to add is a rectangle here. So I'm going to go back to the rectangle command and go corner to corner like I did previously. There's my corner to corner, and there's my little rectangle there like so. So I'll just hit escape now just to deselect that. And what I need now is a new component view. I've already got the component, Shield 1. So I select Shield 1, right click, and I want a new component view this time. So I'm going to come in here. Now the new view name this time will be top, so I can just press enter to accept that. And I'm going to select the rectangle here for my component view and press enter to confirm. Again, it wants a base point. I'll go, let's say, with that intersection there for now, like so. Now that's been selected as well. So now if I click on the top view, there's the top view there, and I can right click and I can select that in the model space, and there's the base point I selected. I'll just hit escape a couple of times to deselect that. I'm now going to double click on the wheel to zoom extents because I've got a front view. There's a front view of my shield there. I've got the top view of my shield there. If I select Shield 1, it shows both those views like so. Can you see that? When I hover over the mechanical browser, they're both highlighting. And if I right click there and select in model space, both those views of that new component are now highlighted. I'll just hit escape there to deselect them. Now I've only added a very simple component to the overall drawing, but that's how you add these components as you build up your mechanical assembly of, say, this robot arm. So you start up here in the Robot 001, right click, new component, and you just keep doing that, and you keep building up the actual assembly of your mechanical design as you go in the Robot 001 drawing in this case. So that's how quick and easy it is to start developing that mechanical structure in your mechanical browser by adding the new components to the Robot 001 drawing. We're staying in our robot001.dwg file. And you'll notice in the drawing area, I've zoomed out and panned across a little bit. So I've got lots of space over here on the right-hand side. Now, the reason I've done that is I want to show you how you can reuse this structured data in the mechanical browser. Now, at the moment, I've got the basement 1 selected. Can you see that in the mechanical browser? So when I come into the mechanical browser, it highlights all of the basement part of the Robot 001 drawing, both the front and the top view. Now, it may be that I want to replicate this basement front view here and place it elsewhere in the drawing. It saves me a huge amount of time. I don't have to draw this, copy it, or anything like that. I just come in here like this, right click on basement 1, and I want to insert a component view. Now, in this particular case, I want the front view, so I'm going to click on front. Now, it asks me for the parent view, and it's like, hang on a minute, what is the parent view here? Well, the parent view really is going to be the top view, because you've probably drawn up the top view first and then linked the front view to the top view. So you'll notice on the command line, I can just press enter to accept top. It's in the little brackets there. It's the default sort of answer. So I press enter, and there's my front view like so. Now I can specify the insertion point. I can use a bit of object snap tracking for that. So I'll zoom in and I'll just hover over that end point, midpoint there. There's an intersection. Just drag that along a little bit and click there like so. So when I zoom out, I can then define the rotation angle. I'm just going to press enter to accept 0. And you can see there that I have duplicated that basement 1 front view. But look, I've now got a front 2 view and a front view. So it's duplicated it. So there's the front view, there's the front 2 view. And it's easy. Front number 1, front number 2. Very quick and easy. I can right click on that. I can select it in the model space and now it's selected. Hit escape a couple of times to deselect, etc., etc. So it's that quick and easy to duplicate what you've already got in the mechanical browser. So if you've got a group of steel girders, perhaps, and you need to replicate them at equal spaces, don't do copying or moving or anything like that. Set it all up in the mechanical browser, quick and easy. You can generate a view of each one, and then also you're itemizing each of those elements of the model as well. Or you might have a group of nuts and bolts that are evenly spaced as part of your assembly in a drawing. You don't want to have to redraw them all or bring them in or move them or copy them. Set them all up as different recurring component views in the mechanical browser. That way they're all itemized, especially for something like a bill of materials later. So you've then got that structure in the mechanical browser. You can reuse objects in the mechanical browser, but they're also all then forming part of that mechanical assembly in your AutoCAD mechanical toolset. Once again, we're staying in our robot001.dwg file. We're going to take a look now at editing our data in our mechanical structure in the mechanical browser. Now we've got various tools to do that. So if I come into the mechanical browser at the moment, can you see that front 2 view is selected? And when I move into the mechanical browser, it's highlighted like so. Now, for example, what I could do here is I could go up to something like basement 1 and I could right click on that and I could rename. And it prompts me, do I want to change that definition name? So at the moment it's called basement. I might want to call it, let's say, rotating robot base, and type that in. If I did that and clicked on OK, it would change the name here in the mechanical browser. I'm just going to click on OK and keep it as basement for now. And that all stays in there, as you can see. So I've also got the top view, the front view, and the front 2 view. So there's the front 2 view like so. If I right click on that and go to rename and rename the view this time, can you see the definition name is front? So I could perhaps change that to say side, because it's a side view as well, right? So I click on OK. Can you see that updates in the mechanical browser? They're now side views, not front views. And I can easily just right click on that again and rename the view like so, and change that back to the front view like so. Just click on OK, and they're back to front and front 2 again, like so. Now, that's really clever because that means that I can rename everything in my mechanical structure in my mechanical browser. So renaming is pretty easy to do. You just right click and rename. Now, here's the other thing that you might want to do. Now, you might want to, for example, remove an element or remove a view from your mechanical drawing. You can do that again using the mechanical browser. Now, we created that front 2 view, didn't we? We kind of duplicated it earlier. So what I'm going to do, I'm going to select front 2 in the list like that for basement 1, right click, and I just select delete. That deletes the view that quickly and that easily. So I've deleted the view, not the component. I do not want to delete the component at all. Now, you'll also remember that I created that shield 1, didn't I, there? So you've got those 2 little components there, the little shield on the front view at the top there, and the little shield on the top view at the back of the view there. If I right click on shield 1 and delete, I'm deleting a component from the drawing, not a view. So I click there, and it'll also say the last instance of the following definitions has been deleted and is no longer used in the drawing. So what that means is that the front and top views have gone. Would I like to also remove the component definition, which in essence is an AutoCAD block? So there's shield there. I just say yes to that, and that component has now disappeared from the drawing as well. So you've kind of removed the block in essence that you would have been using for the shield there and the shield there. That's how quick and easy it is to reuse, rename, and more importantly in this video, edit and change the structure of your mechanical drawing using the mechanical browser. We're starting a new chapter now where we're going to be taking a look at creating key geometry within your AutoCAD mechanical toolset. Now, to do that, we need to utilize some of what I call the core design tools. Now, in your regular AutoCAD, we use things like line, arc, circle, rectangle to create geometry for our designs. We would then annotate that and then obviously output that as a drawing via PDF or through a printer, etc. And it's all about communicating your design intent using those tools within the particular application you're using. Now, one of the benefits you've got with the AutoCAD mechanical toolset is you've got an enhanced group of core tools. So you'll notice as we work through this particular video that the core tools that you use for drafting are very different to your regular AutoCAD. So we've got a new drawing for you. It's called cylinder underscore part, and it's a part of a cylindrical assembly that we might be working on in the AutoCAD mechanical toolset. Make sure you open up cylinder underscore part.dwg, open it up in AutoCAD mechanical. Make sure you've got your mechanical browser here as well, even though there are no extra parts, subsets or anything in the mechanical browser right now. Now, when we zoom into the drawing, you'll see that we've got a plan view with the concentric circles and the hidden detail. We've also got some section marks. We've got A and A. If I come down a bit, can you see we've got AA there, waiting for a sectional view to be placed here. We've also got an area here which shows the side view. These purple lines here are hidden detail. And basically they're on a different layer. So if I click on one of those, you can see that they're on layer AM3 in the layers panel. I'll just hit escape there to deselect. Make sure you are using the layer AM0 for this particular drawing that we're working on. Now, what we're going to do first of all is I'm going to zoom in here on the side view where we've got the hidden detail, the purple sort of dashed kind of color there. And we're going to add a rectangle around this shape and chamfer the corners. And I'll show you how the core design tools of the AutoCAD mechanical toolset are different. So the first thing we need is a rectangle, a closed polyline in a rectangular shape. Now, if we go to the Home tab on the ribbon and go up here to the Draw panel and click on the flyout for rectangle, in regular AutoCAD, you normally get rectangle and polygon. That's it. You'll notice in this particular drop-down in the AutoCAD mechanical toolset, we've got a lot of rectangles and squares that we can work with here. So you've got things like, there's your regular rectangle there, corner to corner, but we've got all these different permutations of the rectangle command. We've also got different permutations of squares, i.e. equal sides. Now we need a rectangle, and I'm going to use this one here, midpoint of base. So I'm going to click there like so. First thing it asks me for is the base middle point. And you can see the little icon there on the crosshair letting you know that you're using this midpoint of base rectangle. Now there's a small yellow circle there. That is going to be my base middle point. So just check on your object snaps down here, click on the arrow, you can do it mid-command. Make sure that that center snap is on, which it is. So I'll just come back into the drawing area and click, and it's asking me for the base middle point again. So I'm going to hover over the circle, get the center snap, there it is there, and left click. Now, as I start moving the mouse around, can you see I can drag left and right for the full base of my rectangle. Now, I know the size of that. I'm going to put in 62 for the full base and press enter. And now, can you see as I move up and down, I can specify a height. The height is going to be 12.5 in this case. So I type it in, press enter, and there's my rectangle neatly placed in my view, ready to go. Now, that was quick and easy. And if you think about it, all those different permutations of the rectangle command are going to make your core design in the AutoCAD mechanical toolset so much easier. Let's have a look now at the chamfer. We need a chamfer on this corner here and a chamfer on this corner here. Now, the chamfer command looks just as it does in regular AutoCAD. It's still on the modify panel here. Click on the flyout here, and you've got fillet, chamfer, and blend, just like you have in regular AutoCAD. That's where the similarity stops. If I click on chamfer now, it'll do something somewhat different. And you'll notice now you have a chamfer contextual tab on the ribbon, and all of your settings are visual. Now this is really, really helpful because I can do distance and angle, first chamfer, second chamfer. I can also measure distances. I can trim the geometry. I can even insert dimensions if I want to when I'm chamfering. You can't insert those dimensions in regular AutoCAD. Now, what we're going to do, we're going to set a chamfer distance here. If I click on the down arrow, there are some preset ones. So if I go to 5 there, and then click on the arrow here and go to 5 there, there's my 2 distances for the distance, which I've got blue and clicked on and highlighted there. I want to trim the geometry, so make sure that's ticked, but I don't want to insert a dimension, so make sure that's unticked. Come into the drawing area now, and I can select the first object. So I'm going to go vertical line there, horizontal line there, and it trims it. Vertical line there, horizontal line there. What else did you notice there that was different from regular AutoCAD? I can just keep going now, chamfering to my heart's content. I don't have to use that right-click multiple tool like I do in regular AutoCAD. So those are my chamfers. They're all done. So I can now just press Enter to finish, and it will prompt me now for Select First Object. So you'll notice there I'm still in the chamfer command. So if I want to get out of that, I can right-click, and I've got Polyline or Add Dimension. But how do I get out? Right-click, Enter. That still takes me to Select First Object. You have to just hit Escape. That's it, like that. And it's one of those commands that it's a slightly different workflow, slightly different keys to press, and so on. So you'll find that that is very different from your regular AutoCAD. Okay, looking down here, we've got some really nice little fillets going on these options here, but we need some fillets on these rectangular ones. So we go back up to the Modify, click on the flyout, click on Fillet, and again, it's got its own little tab on the ribbon. Now, the distance for the fillet, the radius, I'm going to click on the down arrow, and there's a 2 in there. There's some preset ones. I'm going to use 2, like so. I want to trim the geometry, make sure it's ticked. I can also select a distance if I want to, and I can also insert a dimension. I'm not going to, so make sure the Insert Dimension is unticked. I come into the drawing area, and it prompts me now to select the first object. So I'm going to select a vertical line there, horizontal line there. Now it asks me to select an object to create the original length. So it's kind of saying pick another object to create the length or radius of the fillet. That's where you do have to hit Escape, right-click, and repeat AM Fillet 2D. It keeps the same distance, but you have to do it that way, like that. Hit Escape, right-click, repeat. And the reason you have to do it that way is it works slightly differently to the regular one. Look, watch. If I do that now to create original length, can you see it kind of does that weird thing and extends that line? So I'm going to hit Escape there, undo what I've just done, and I'll right-click, Recent Input, there's AM Fillet 2D, and then I'll do it again. So it's going to be 1 and 2, Escape, right-click, repeat, and then 1 and 2 again. And then hit Escape, like with the chamfer command to come out. So there are different workflows to the way that those behave in the AutoCAD Mechanical Toolset. So let's just zoom out slightly. We've got one more thing to do. We need to create our sectional view, our AA view here. Now, be careful when you're copying in AutoCAD Mechanical. If I go up to the Modify panel, you'll notice I've got 2 copies. I have a Power copy and a regular copy. Power copy, you'll notice, produces an identical copy of a specified object. Note the term object, not objects. You need to select just your regular copy that duplicates objects. So I click on Copy, pick there, drag across, get the window selecting everything. Everything is selected. Press Enter to confirm. Now, the base point's going to be nice and easy. I'm just going to click on that corner there, left click, use my polar tracking, just bring it down so it's roughly about there, and click there like so, and Enter to finish. All regular, just like AutoCAD. So we're going to zoom in, and we're zooming in on our section now, so we need to tidy that up a little bit as well. And again, we're just going to use regular commands. If I go up to Trim here, you'll see Trim is there like so, and I can select objects to trim. Now, be aware that the workflow changed a few versions of AutoCAD back. So if you want a cutting edge, it's a right-click and then cutting edges. Use the center line as a cutting edge, press Enter to confirm, and then you can trim everything back to that cutting edge like that. Press Enter to finish. The bits that you don't need, you can then obviously remove. So just select those, hit Delete or right-click and erase like that, and they go. And then all we've got to do is just select these objects here, put them onto a different layer. Let's put them onto AM0 so they're a continuous line. Hit escape, and there's our sectional view as well. So you can see how there are some tools in there that make your life a lot easier when you're working in the AutoCAD Mechanical toolset. But just be aware that they are different and explore that, because I can guarantee first time around when you're using the mechanical toolset, you'll go to do something like copy and you'll end up power copying instead. Or when you're using fillet, you'll get that funny little line extension and you'll think, what's going on? So just watch the video through and then go and explore and check out those new commands that you've got in your AutoCAD Mechanical toolset. We've got a new drawing for you now. It's called Cylinder Part 2.dwg. So make sure you download the right drawing to follow along with this particular video. Now you will recognize the drawing. It's at a state where it was at the end of the last video. And what I'd like you to do is zoom in on section AA at the bottom. So we'll zoom in, pan upwards so that we've got a bit of space underneath as well, like so. Now, section AA has not been finished yet, and the reason that I deliberately left it unfinished at the end of the last video is I want to show you in this video how to utilize some more of the core design tools and how to set up your power snaps within the AutoCAD Mechanical toolset. Now, before we do anything else, we need to make sure that our dynamic input settings are set appropriately. So we're going to do that first. Now, you'll notice down here on the status bar, my dynamic input icon is there. It's on the status bar. And I can turn dynamic input on and off like that by clicking on it. You may not have that dynamic input icon. So what we do, we go to the little 3 lines here, click on them, go up near the top there on the menu, there's dynamic input. If it hasn't got a tick next to it, click on dynamic input, a tick will appear, and your icon will appear on the status bar down here. Click on the little 3 lines again to lose the menu, job done. We then come down to dynamic input here and we right click on it. We go to dynamic input settings and we're going to set our dimension input settings here. So we click on settings, and what we want to do is change the visibility on the dynamic input for dimension input settings. So we set this button here, show the following dimension input fields. I want to make sure that you've got the right ones ticked. So untick length change, untick arc radius. You only want these 3. Resulting dimension, angle change, absolute angle. And you want those 3 there and that lower one of the 3 dimension field settings, okay? Make sure your dialog box looks like mine. Note as well the little note here. You can press tab to switch between the dimension input fields. So there they are there, dimension, angle, angle change. Click on OK. Click on OK again to apply that in your drafting settings. So that's all set up. Now we're going to set our power snaps next. So that's a right click down to options on the shortcut menu. And there's lots more options in the AutoCAD Mechanical toolset. So you'll notice with this little arrow here, I can go all the way along. There's the ones you recognize: files, display, open and save, etc. Use the arrow keys there to go all the way along to the other end, and you want AM preferences. Now, there's lots of settings here. Just make sure that you are set to System Settings and Snap Defaults. Click on Snap Defaults, and there's 4 different snap configurations. So these are all presets. So you can jump in and set them to your heart's content. I'm going to use Settings 1, just because it's the first one. And I'm going to make sure that Object Snap is on, like so. And you can also switch on Object Snap Tracking and your regular snap for Snap and Grid if you want to. You'll notice that you've got endpoint, midpoint, center, and intersection already on. Crosshair size is at 5 and the entity filter is on as well. Leave all of that as it is. Then click on your polar snap settings. Make sure that polar tracking is on, and make sure that your increment angle is 90, like that. Everything else here on the right you can leave as is. Click on Apply, click on OK. Now, you've made some changes there, so again, click on Apply, click on OK, just to make sure that you've set all of that. Now, that's all been set up and ready to go. Now, you'll notice when you do that, did you see what happened? A zoom extents kicked in. Now, that's not your fault. That's my fault, because I clicked on my zoom extents button on my mouse. I've got a preset button. So don't panic if that doesn't happen in your drawing. I'm just going to make sure that we've got that section back at the top of the screen like that. Okay, so there's my section AA. Now, we're going to utilize some of the standard commands now in your AutoCAD Mechanical toolset to tidy up our section, but I'm also going to show you a few little discrepancies from regular AutoCAD to the AutoCAD Mechanical toolset as well. Now, we're going to go to the Home tab on the ribbon and into the Modify panel. And the first thing we're going to do, we're going to go to Trim. Click on the flyout there, you've got Trim and Extend. They are just the same as if you were trimming in your regular AutoCAD. So hover over Extend, it extends an object to meet another object. Hover over Trim, it trims an object at a cutting edge. Click on Trim. Now, one thing you'll notice, if you're using the latest version of your AutoCAD Mechanical toolset, which is 2023, it's a different workflow for the trim. It changed a few versions of AutoCAD back, and it applies to AutoCAD and the toolsets. So you'll notice now it goes straight into trimming. You do not need to select a cutting edge. So it's doing that select all for trimming. If I want a cutting edge in newer versions of AutoCAD, I would simply right click and go cutting edges and select my cutting edge. I'll just hit escape to lose that menu. So basically everything on this sectional view is a cutting edge, which makes my life easy. I don't need to set any cutting edges. I want to get rid of that line there. I click on it, it's trimmed, press enter to finish. It's a little bit quicker on the workflow in the newer versions of AutoCAD for that trim command. Now the other line here, this one, I'm going to get rid of as well. So I just select that, right click. I can just erase that on the shortcut menu like so. So now we've tidied up our sectional view. What I want to do is I want to hatch. Now the good thing is we've got a layer for hatching for you. Just pop to your layer drop down. There's hatching there. Click on the word hatching. Obviously hatching is now the current drafting layer. Now, hatching in the AutoCAD Mechanical toolset, is that a bit different? Well, yes, it is. So, draw panel, it's still in the same location. If I click on the down arrow, though, I've got all these preset hatches that I can use straight away. If you want the regular hatch command, you come down to the bottom and click on hatch, like so. It's still there. There's the hatch creation tab on the ribbon. I'm going to set it up for pick points, like so. I'm going to select the ANSI 31 pattern there, which is normally at the top. I'm going to change my hatch scale there to 0.5 and press enter. That's all I'm going to change. Everything else I'm going to leave as is. Hover in the area there. There's the preview of my hatch. I left click. Places the hatch for me. Press enter to finish. That quick, that easy. So the hatching doesn't change, but there's lots of other preset hatches that are available if you need them. Now I'm going to show you a really cool feature in AutoCAD Mechanical. Now, it's a thing called contours. Now, these contours allow you to pick an area in a drawing that is bounded by other objects, and it will create a contour, a bit like a boundary in your regular AutoCAD. But what's lovely is it puts this contour on the appropriate layer. You'll notice if I go to the layers panel and click here, there's various contours available. Can you see that there? So these contours allow me to generate different shapes from perhaps a sectional view so that I can create a profile of something and use it for something else elsewhere. Now you'll notice we're on the hatching layer right now. If I go to the construction panel here and click on this down arrow here, I've got contour trace. So I can trace around an area. I can do a contour on the outside objects, or I can do a contour on the inside objects. So that will create a closed polyline that traces the inner contour of an enclosed area. I'm going to click on contour inside. Come into the area as if I'm hatching, like I'm using pick points, and left click. Now, you might not see it easily on the screen there, but what that's generated is a contour boundary. There it is there, in green, on the AM4 layer. Remember layer management previous in the course? That's what it's done. It's created a contour and put it onto one of those layer definitions, which is AM_4 in this case, which is great. So I'll just hit escape to deselect it. It's sitting there. I need to move that now and place it to a different location underneath my section AA in the drawing. Now, again, one of the things I will suggest here, if you want to use a command in your AutoCAD Mechanical toolset, don't select the objects and right click. I can do that. If I click there on my contour and right click, you'll see I've got all the regular tools like move, copy, scale, rotate, but there's other commands available. So if I go up to the modify panel first and click on the flyout next to move, I've got move, my regular move command, but I've also got move, copy and rotate, copy and then rotate, copy, rotate, then move, copy, move, then rotate. Lots of different permutations and combinations. I'm going to select move, copy, and rotate. As soon as I do that and come into the drawing area, it asks me for the operation type. So I can just do a regular rotate, I can do a move rotate, or I can do a rotate move. I'm going to do a move rotate. Click on it there. Do I want to copy the objects and leave the original behind? No, in this case I don't, so I click on no. Now it asks me to select the object to perform that move, copy, rotate on. There it is there, the contour. Click on it and it highlights. I press enter to confirm, and as usual with any move or rotate type command, I've got to specify a base point. I'm going to go with that lower left corner there and just drag down. Now you'll notice, can you see, I can now just come down here, and when I click, this is the clever bit with the power snaps. So I come down here, I don't need to confirm anything or any distance, I just left click. Then I rotate, and can you see there, I don't need to specify anything, I just left click again, job done. Now it's asking me, do I want to copy that again? Now obviously in this case I don't, so I just press enter to finish. And there's my move, copy, rotate, just done with clicking using those power snaps from the contour created from the hatch area here on the section. So there's some really cool stuff going on in your AutoCAD mechanical toolset. You've got your power snaps, you've got things like altering your dynamic input settings, you've got move, copy, rotate on the move command. The hatching is different. Everything is different in your AutoCAD mechanical toolset, which is why you need to understand AutoCAD first before you then appreciate all the tools here in AutoCAD Mechanical. We're starting a new drawing now called motor_centerlines.dwg. So download it from the library to follow along with this particular video. In this video, we're going to look at placing some center lines and some holes, but also how we set up our center lines in the settings within the AutoCAD Mechanical toolset. Now, something you can do if you're not using the mechanical browser is turn it off to give yourself a bit more screen real estate. Now, you can do this in two ways. I can come up here, there's a little cross there, that will close the mechanical browser, or I can go to the View tab and click on this icon here, that will also close the mechanical browser. I can turn it back on again at any time by clicking on the icon, you'll notice. But just turn it off for now, we don't need it right now. I'm now going to go back over to the Home tab on the ribbon, like so. Now, the first thing I'm going to do is show you a really neat trick with center lines. Now, the good thing is we've got some centerline commands in the AutoCAD Mechanical toolset. You don't get these in your regular AutoCAD, and boy, oh boy, I wish we did. So I'm going to go to the Draw panel on the Home tab on the ribbon, and up here and click on the flyout. And can you see I've got lots of different types of center lines available. Now, the one that I want is a centerline cross, this one here. So it places a centerline cross at a specified point. So I click and come into the drawing area. Now you can see there it's asking for the center point. Just pop down to your object snaps, click on the arrow, just make sure that your center snap is on. There you go, endpoint, midpoint, there's center there. Just make sure center is on. If it is, that's great. If it isn't, just switch it on. And you're going to touch on the edge of the outer circle. There's the center snap there, left click. Now what I love about this, look, it's dynamic. I can move that little crosshair any which way, like so. So I can drag that out and move it around. But what's really nice is I can come up here, find that quadrant on the circle like that, left click, and it automatically places my little center cross. But what it also does is it expands it past the geometry so that I've got that little extra bit of center line so that it just allows me not to have to snap to that intersection, but I can snap to that endpoint there for dimensioning annotation purposes. Now, that's gone out a specified distance. You can change that specified distance at any time. So if you right click now without any commands running and just pop down to options, you'll remember there's all these different options available with AM in front of them, AutoCAD Mechanical. So if you go to AM standards, you'll see that it's all set to a specific standard. There's all different settings in here. I'm not going to go into all of them because we could disappear down a rabbit hole for days with standards in the AutoCAD Mechanical toolset. I'm going to go here and just double click on Centerline. And that will allow me to set the settings for my center lines for the ISO standard in the AutoCAD Mechanical toolset. So it's using this particular standard, ISO 6410 1993. The type is fixed and it's known as overshoot length. So that's that little distance here, overshoot length. I'm going to change that value to 3, like so, and I'm going to OK that. That's all I'm going to click on. I'm then going to apply it in the options and click on OK. Now you'll notice my center cross doesn't change, but if I double click on it, I can edit it. How cool is that? Wouldn't that be lovely to have that in regular AutoCAD? Just double click on my crosshairs and I can resize accordingly. So I'll just come up to the quadrant again, click on the quadrant. Notice the overshoot length is now 3. It's shorter. So much easier, isn't it? Really, really easy. Now, that's great, which means I've got a nice center line to work with on that front view, the circular view of my little motor that I've got in this drawing. We're now going to work with some more center lines. So we're going to go back up to the draw panel, up here like so, click on center line there. I'm going to go for a regular center line this time. So I click on center line, quick and easy, midpoint snap there to midpoint snap there. And there's the overshoot again, the little distance of 3. Now, if I select any of these center lines, the layers are already preset. Look, they're all on AM7. If I hit escape to deselect that one, click on that one there, again, AM7. So AutoCAD Mechanical is doing its thing. It's placing the objects on the appropriate layers. I'm not having to think about that whatsoever. Really lovely, isn't it? All these center lines kicking in, so it's quick and easy. Now, the other thing that you can utilize in AutoCAD Mechanical is construction lines. You'll notice we have a big construction panel here with all different construction line settings. I'm just going to expand the layers panel by clicking on the flyout there and pinning it open. Because what I can do is I can switch my construction lines on and off. So that's that little icon here. Now, there are some construction lines in this drawing. So if I click there, you'll see that they come on. Like so, I've turned them on. And there's one red construction line, and it goes through this little part of the motor here in the side view and goes through our little intersection here with our little center line there. So what I'm going to do now, I'm going to zoom in on this area here where the red construction line goes through our vertical center line. Now, you'll remember we had all those different center line tools. I'm going to pop over now to the draw panel, click on the flyout for center lines again, and you'll notice I can do a center line cross with a hole. Isn't that cool? Click on it, and it asks for the center point. Now, the center point this time will be that intersection. I just left click, and I then specify the diameter of the hole. Now, the diameter of the hole is going to be 6 in this particular case. Type in 6 and enter, and there's my crosshair with my hole. I press enter to finish. Job done. And you'll notice when I press enter, I can select a method to even create the center line. I can do all different methods to create center lines there as well. Isn't that cool? Now, I don't want to, but that second enter when I'm creating the center line with the hole allows me to do that. I'll just cancel. And as you can see, job done. I'm out of the command now. I'm just going to zoom out slightly. And you can see there that there's my hole. And you can just see my center marks there like so. What I'm going to do now is I'm going to click back here on this icon, turn the construction line off, and unpin the layers panel again. Now, I've got my nice little hole there, and that represents this little outstand here. But you'll notice there's another outstand that's slightly bigger, and that will also have a slightly bigger diameter. So I'm going to zoom in on the hole I've already created, go back now to my center line command, and I'll do another center line cross with hole. And I can utilize now that midpoint there where they intersect, left click, specify another diameter, 7, and enter. And I'm done now. That's all good. If I press enter again, it will give me that dialog box to select the method to create center lines. I just click on OK there, and it's done. Now you'll notice I clicked on OK instead of cancel. Be careful. Clicking on OK will select the method to place the center line. So you'll notice now it's asking me for an offset of center cross from contour. Just hit escape a couple of times for that one. Be careful with that enter twice thing sometimes that you might use to close a command. If you do it when you're creating a center line with a hole, it takes you down all these different routes of creating center lines with holes. Utilize escape more in AutoCAD Mechanical. Now, last but not least, you'll notice we do have quite a few center lines here as well. So they're all sort of sitting on top of each other. So what you want to do is zoom out slightly and just tidy this up. If you hover there, there's one there. Can you see it? See the grips? So I'll just right click and erase that one. And there's another one here. There's two on top of each other here. So if I right click now and erase, can you see that's got rid of it? If that happens, don't worry, quick undo like that. And just make sure you get rid of the ones that you don't need, like so, by using erase. Undo is a good option. See, I've got rid of another one there. So I'll just undo that again. And now I know that I've just got the one there. So if I click there, right click erase, can you see it gets rid of it again? So just make sure that you get rid of the ones that you don't need. And then you've only got the one on top of the main center line here. When you zoom out now, though, you can see how you've placed those center lines and holes quickly and easily using those time-saving tools in the AutoCAD Mechanical toolset. We're going to take a look now at how construction lines and the automation of construction lines in the AutoCAD Mechanical toolset can save you a huge amount of time. For that reason, we have a new drawing for you. It's called lines_construction.dwg. And you'll notice there that we've got, in essence, two views. And what we want to do, we want to project from this view here to the right and downwards so that we've got another view here so that we can take details from this view and place them on a view here. Now, normally in regular AutoCAD, you would have to draw a 45-degree construction line ray down there, and then draw in all your construction lines from the various vertices here individually. Now, we don't need to do that in our AutoCAD Mechanical toolset. We've got tools that allow us to do it very quickly and very easily. So make sure you're in the Home tab on the ribbon, go up to the construction panel here, click on the flyout and just pin it open for a moment. You'll see these three weird looking little spidery icons here. If you hover over each of these, you'll see there that you've got projection, you've also got trace contour, and you've also got make contours visible. So that's making contours that are hidden by construction lines visible, because the construction lines might go over the top of your contours. Remember contours in the previous video? Now, what we're going to do is we're going to utilize this one here. We're going to utilize the projection tool. And that creates projection lines on the construction lines layer to assist you to create those orthographic views that we need. So I click there and come into the drawing area. Now, do I want the projection on or off? Well, surprise, surprise, we want it on. And there's our projection line. So you'll notice there's my 45-degree line and various other projection options there. I'm going to hover over this point here. Can you see there? Specify insertion point. And then I'm just going to drag a little bit to the right. So you'll notice the extension snap kicks in. I'm going to type in a distance of 20, 20, and enter. And you'll see it places it in that point there. So can you see where I'm rotating around? That's 20 units away from that original bottom right corner of that top left view. Now, I'm going to specify the rotation angle of my projection now, and that's going to be 90 degrees, like so. Type in 90, press enter, and now we've got that 45-degree line. So I can project from here to the 45-degree line, project down, and then project across from here, and I'll get a view over here somewhere that is in true orthographic projection, because I'm using all of my projection lines to do it. Now, here's where it gets even clever still. I really love AutoCAD Mechanical for this. If I go to construction lines here, like so, and the good thing is all these construction lines go on their own layer automatically, courtesy of the Mechanical toolset. I've got a tool here, Automatic Construction Lines. So if I click on that, it'll bring up this weird dialog box with lots of red and black lines. Where the red lines are is where the construction lines are going to go. So I can project in any direction, in the direction of the red lines, and place construction lines on my drawing. I want my construction lines to come off of this view here and this view here and project to the right. So I need this one here. There's my little view. There's the red lines going to the right. So I click there. Now it prompts me to select the objects that I want to project from. This is the clever bit. I can simply click, release the mouse, drag, put a window selection around there, click again. Do the same with the lower view, click, release the mouse, drag, and just click again. There's all the objects that I'm going to project across to the right. I just press enter now. Just watch the screen. How cool is that? All of my construction lines on one click of a key on the keyboard. I've selected those objects, job done. Now, you can unpin the construction panel here. That can go back into the ribbon. I'm going to do a little bit of zooming and panning, and I'm going to zoom in on this area here like so. Now, you'll notice if I click on this particular rectangle here, like so, it's on layer 0. So what I'll do, I'll place all the other objects on layer 0 for now. So I'll make sure on my layer drop down, I'm using layer 0, like so. Now, I'm not going to draw everything because obviously there's a lot of construction lines going on there. What I am going to do, though, is do the overall outline of the new view, and I'm going to place a horizontal center line off of these horizontal center lines there. Very quick and easy to do. So I'm going to go to the rectangle command on the draw panel and use just a regular rectangle, corner to corner. And I'm going to go from this intersection on my construction line to this intersection on my construction line. Job done. There's the outline of the view. I'm then going to jump up here to the center line drop down that we've used previously and just go for a regular center line like so. And the center line starting point is going to be here on this intersection and then to here on this intersection. Now, if you want intersection, you will get perpendicular because it is perpendicular. If you want to make sure that's an intersection, just do your shift and right click and use intersection on the snap override menu. There's the intersection there. And you'll see the little sort of overshoot kicking in, the little 3mm that we preset in the previous video. Now, we've already done this before, but if you go to your layer drop down and click on the little arrow there, go to the flyout, you can turn your construction lines off like so. And then you've got that nice little orthographically projected view there, which is part of this view and part of this view here with details from both. Now, if you want those construction lines to come back on, it's just a case of clicking on the icon again on the expanded layers panel, and there's our construction lines and our 45-degree projection lines. So I can turn them on and off at my leisure and utilize them accordingly to develop the orthographic views from my details in my AutoCAD mechanical drawing. Once again, we've got a new drawing for you, and we're going to be looking at designing with lines in the AutoCAD mechanical toolset. The new drawing is called lines_designing, surprise, surprise, and it's a .dwg file that you'll find in the library to download and follow along with this particular video. When you open up the drawing, you'll notice lots of red construction lines and a center line already preset over on the right-hand side, along with a front view with some hidden detail here, showing what's going on at the front of our part that we're going to be designing with. Now, ideally, what we want is a section through this front view so that we can actually see the profile of the shape. Now, to do that, we're going to utilize some very clever line tools available in the AutoCAD mechanical toolset. Now, you'll notice all the construction lines are already there, so that's already been projected, so we don't need to worry about those. What we do need to create is what they call a symmetrical line. Now, we can use a regular line and just draw and connect to all the object snaps here if we want to, but wouldn't it be nice if I could just draw one side of the center line, and then on this side of the center line, let's say the bottom side, it does it automatically and mirrors what I'm doing. Now, I could do that. I could draw everything on this side of the center line and mirror it. I don't need to. What I can do is make sure I'm on layer AM0, which I am already. There you go, there's layer AM0. And you'll find anyway, when you start drawing these lines in your AutoCAD mechanical toolset, using the layer management, it will obviously put the appropriate objects on the appropriate layer anyway. So I'm going to go over to the draw panel and I'm going to click on the flyout underneath the line command. And you'll notice I've got some choices. I've got line, symmetrical line, or zigzag line. We want symmetrical line, and that will draw symmetrical polylines. Click on the symmetrical line command and come into the drawing area. It prompts you now to select the existing center line or first point of, in essence, that mirror line. Now, you only need the one point. Just jump down to your object snaps. Click on the little fly out there. Make sure that you've got your midpoint snap on. Just click on it if it isn't on. Tick will appear. Click on the little arrow again to close the menu. Now, the good thing is I can now just pop in there and use that midpoint snap there on the center line. Can you see there? It's automatically selected that center line. Now it's asking me for the start point of my symmetrical line. So what we're going to do, we're going to start here at the intersection. Going to come up to the first construction line, which is there. We're then going to step in and come up again. And you'll notice we're just stepping in each time as we come up. Can you see what's happening below the center line? It's literally, as I draw, mirroring what I'm drawing above the center line, which is incredibly useful. So you can see there, I'm just using these object snaps as I come across. I'm now repeating what we had on the left-hand side. And when I get down to here and click there, I'm done, like so. There's my sectional view. So all I've got to do now, press enter, and there it is there. Isn't that great? Half the time to create that sectional view. So quick and easy within the AutoCAD Mechanical toolset. Good thing is as well, if I click on that, can you see there? That's a polyline on AM0. If I hit escape to deselect, if I click on this one, it creates another polyline on AM0. So that's great. I've got two polylines there that now are mirrored along that center line. I'm just going to jump into the layer drop down flyout here and just click on turn on and off construction lines, just so the construction lines disappear and we can kind of see the wood for the trees. Now, this right-hand view is a section of this circular front view here. So ideally, what we want to do now is we want to show this as a section. Now, the good thing is there is a section command in the AutoCAD Mechanical toolset. It's up here on the detail panel. So home tab on the ribbon, detail panel, and there it is there with the two little A's on it, AA, section line. So it's asking now for the points that form the section line. We're going to use the vertical center line. Endpoint there, left click. Endpoint there, left click. Now it'll ask for the next section line point. Just press enter once, and now it'll ask for the first section symbol. Now, we're just going to use AA. You can see the A in the brackets, so I can just press enter to accept that. And then we want the side of the section. Now, we're ideally going to be looking this side. Can you see I can move and place the arrows either side? So I'm going to click on the left-hand side for the arrow placement. And then it says specify origin of the section view. Now, the origin of the section view is obviously going to be here, like that. So we're going to go there, and there's our AA there. Now, obviously that AA there, I've put it in the wrong place. Doesn't matter. Just click on it, click on the grip, come down a bit, and we'll just pop that down there, and it moves like so. Now, the reason that you've done that, obviously, is that you just want to make sure that the origin of that section view is in the right place. If I'd left it up there, the AA would have been there, and it wouldn't look right. I can move that origin of that section view just using that grip at any time, and I'll just move it up a bit, hit escape to deselect. So there's my section there, and there's my section arrows all in place in my drawing, using lines and section lines to develop those views in my AutoCAD Mechanical toolset. We're going to take a look now at how we generate holes and slotted holes, sometimes known as slots, in our AutoCAD Mechanical toolset. To do that, we've got a new drawing for you. It's called features underscore holes and slots.dwg. You know the drill by now. Download it from the library to follow along with this particular video. Now you'll notice we've got two views in the drawing. The upper view is the top view. The lower view is the side view. And we've got a red construction line going down sort of one side of both views. You'll also notice if you go to the Home tab on the ribbon and on the layer drop-down, we are using the AM3 layer. That is the standard AutoCAD Mechanical hidden detail layer. And a lot of what we're going to be drawing in this side view will be hidden detail. Now, we're going to zoom in on the side view and we're going to create basically the hidden detail for an M6 screw going through the top plate. Slotted hole will be in the middle plate, and then we'll have a threaded hole for the screw in the lower plate. Now, very quick and easy in the AutoCAD Mechanical toolset as well, because what I can do now is I can utilize that extensive content library. Unbelievably quick and easy to use. Go to the Content tab on the ribbon, and we're going to expand our holes panel here. So I click on the flyout, just pin that open. You can see that we have a massive library of different types of holes. We've got through holes, blind holes, tap through holes. We've also got all these holes here as well. There's all different holes here. Look, we've got things like a counterbore. We've also got things like a countersink hole. We've got a blind slot, a through slot, etc. So there's all these different tools. Now, the lovely thing is these are all parametric and all automated. Can you imagine having to draw all of these holes and slotted holes manually and remembering all of the measurements that you need as well? Absolutely insane, right? So let's get into it. We need, first of all, in the top plate, this one here, we need a countersink from the content library. So we click there. Now, you'll find that this kicks in straight away and it is a massive library. You could get lost in here. I'm going to expand the holes like so, and you can see I've got all different standard types of holes. We're going to be using metric ISO for our M6 screw. So there's our ISO countersinks. Click on it. Do we want a front, a top, or a bottom view? We want a front view, or in essence, a side view. Now, again, we get to choose all different types. So you've got all these different types of holes, isometric holes, not isometric view, isometric, 2 words. Now, we're going to go for this one here. We're going to go for the ISO 70461 1994H regular thread. So as soon as you select that, you've got a choice of front or side. We're going to go for front again, because we're looking at it from the front. And again, we've got a choice again. We want, obviously, metric threads. We're not going to have a user one. We're going to go for metric. Just going to go for a standard one. And then it jumps into another page of the library. Isn't this great? You're just jumping from page to page, and it's parametrically modeling this in the background based on all this data that you're giving it. So we're using a regular thread, and there you go. For metric threads, we want M6, that one there. And we just click on next. Now, there's lots of other settings in there, but just click on next. Now, it's asking for a start point of the hole. Make sure your object snaps are on down here, which they are. And I'm going to use that intersection there, left click. I'm then going to come down to that point there. Now, it should be an intersection, but it's also perpendicular to the construction line. If you're worried, do a shift and a right click, and on your snap override, select intersection again, and make sure you get that intersection just there. Now, another page of the library pops up, and you're thinking to yourself, is this ever going to end? It does. This is the last one. But we're just going to accept all of these settings, all of these X and Ys and insertion angles we've just specified with our object snaps. You can obviously update them if you wish, but I'm just going to hit next. And then we've got a choice of how it just presents on the drawing. We've got a normal view. We've got a hidden view. We've got a no view and a sectional view. The no is obvious. There's no detail at all. Normal shows it as if it's going through. Hidden detail, or if you're creating a section view. We want hidden, like so. Click on finish, and it places it right there, straight in the drawing, quick as that. So there's our M6 hidden detail, our hole, ready for our M6 screw. We now need, in this second plate down, a through slot. So that's going to be this one here. So we're going to go through slot from the content library. And lo and behold, we have lots of different slots to choose from. If you scroll down the list, you'll find there are some ISO ones. Keep going down to I. And we've got ISO close and normal, etc., etc. Just go for ISO normal 1, that one. And again, we want the front view, like so. Now, the insertion point is going to go from this intersection. And again, you want to do a shift and a right click and go to intersection again and do that intersection there too, like that. And then you're looking for M6 because it's for an M6 screw, like that. Just click on finish. And now, weirdly enough, it asks for the size. So basically what I'm doing is I'm dragging from that red construction line out left and right. And the size of it, I'm going to type in 18. So type in 18 for the distance, press enter. And the distance of the hole goes from that purple dash line there to that purple dash line there. They are actually magenta, to use the official AutoCAD color. So there's our slotted hole in our plate in the middle. Now we need to add a threaded hole. Now we're coming up here. So we've got tapped blind hole, tapped through hole, through hole. If I look at all of these, I've got so many different holes. Tapped internal thread. Which one do I need? Do I taper? Do I use an external thread from the content library? What do I use? Well, I'm going to use a blind hole, this one here. Now, a blind hole, as you can see, basically creates a blind hole like that. Is that what I want if I'm putting a screw in there? Really, I want a tapped blind hole, don't I? Because I need it to be threaded so the screw can grip. Screw's going to go in here, go through the slotted hole, and then come into this tapped one here. So ideally, I need a tapped blind hole, like so. There's the thread. Visually, you can see it. If I expand that, again, loads of different ones to choose from. We're going to go for ISO 262 regular thread. Front view again, like so. Insertion point is going to be this intersection here in the third plate, the lower one. And we can come down and it asks for a rotation angle. Now, the rotation angle, if you think about it, we don't want 0. We want 90 degrees, don't we? We want it going vertically downwards. So if I just press 90 there, type in 90, sorry, and press enter, that'll give me a vertical thread. We want M6, and we click on finish, and there's our threaded hole there. And I'll type in 14 for the depth into the plate and press enter, and it's put it the wrong way round. Now, the reason it's put it the wrong way round is I've put the wrong angle in there. Don't panic. These things happen. You thought, hang on, 90 degrees, and you're thinking, no, hang on, counterclockwise, clockwise. It's one of the things you learn in the AutoCAD Essentials course. So let's just undo that last step. All we've got to do is go back to tapped blind hole, like so. It remembers the 262, so I can go to front like so. I'll use the same insertion point, the intersection just there, and come down. Now, the rotation angle is not going to be 0. 0 is off to the right. The angle we need is actually 270. 270. And then enter. Then we go for the M6. Then we go for the finish. And we need to specify the distance, which is 14, and press enter. And now it's going 270 downwards, which is where we want it to go. So what we've got is a countersunk hole there with no thread where our screw drops in. It goes through the slotted hole and then it comes down here like so and threads, actually tightens into this tapped blind hole. So if I zoom out slightly now, you can see that that side view is all neatly done with all of our nice hidden detail using that particular layer. I'll just unpin the holes there and go back to the Home tab on the ribbon. We're now going to change our layer here. We're going to go to AM0, which is one of the default AutoCAD Mechanical continuous line type layers. Now, what I want to do is I want to place the hole in the plan view as well. So I now need to go back to my content. And what I need now is to show that hole again. So I'll expand the holes out, or do I? I can use a fantastic tool in AutoCAD Mechanical up here in Tools. So Content tab on the ribbon, Tools panel, and Power View. And what I can do now is I can select the object that I want to do a power view of. If I click on that little countersunk hole there, which view of the screw connection should be drawn? I want the top view. And I'm going to specify the insertion point. So I just hover over that midpoint snap there, use my tracking, come across. When the intersection kicks in on the construction line, click there like so. And there it is on the AM0 layer. So that shows my hole in the top plate. So you can see there it is in the side view, like so. And there it is in the plan view, like so. If I go back to the Home tab on the ribbon, just expand the layers panel there and just click on the on off for construction lines. I want to zoom out slightly. You can see now all my hidden detail is displayed. My hole on the plan view is displayed. Everything's ready to go in my drawing. Isn't it cool drawing holes and slots in AutoCAD Mechanical? The AutoCAD Mechanical toolset saves a huge amount of time. There's a whole load of productivity that can be gained when you're working with the AutoCAD Mechanical toolset. In the last few versions of AutoCAD and the associated toolsets, including AutoCAD Mechanical, the break at point command has been revised ever so slightly. And when I say break at point, I mean the regular AutoCAD break at point. Now, we've got a new drawing for you just to work with these break at point commands. It's called pump001 underscore subassembly.dwg. Just make sure you download that from the library to follow along with this particular video. Once you've got the drawing open, we're going to zoom in on this line here. So zoom in nice and tight so that you can see what's going on, like so. And we're going to have a little play around with the break at point and the break commands. Now they're all on the Modify panel on the Home tab on the ribbon. You might want to click on the flyout and just pin it open. And there's the brake commands there. So these two here, this one, brake, brake at point, they work as they do in regular AutoCAD. But you've also got this one. You've got AM, brake at 1 point. So if I do the AutoCAD mechanical toolset specific one first, that's that one there, little white sort of box with a blue dot on it. Click on that one and it will say specify cutting point. So you want to make sure now that you pick the point on the object where you want to brake. Now that's going to be my midpoint snap on that horizontal line. So I just go down to my object snaps, click on there, make sure that midpoint is on, and then click on the arrow again, back into the drawing area. There's where I'm going to break the line. So I click there like so. It then says select the entities to brake. So I'm going to click on the line itself like so. And then it says select more objects to brake. If I press enter, you'll notice that it's asking for the cutting point again. So it has broken that line for me, but it wants me to go in and do another line elsewhere, another object elsewhere. To get out of the command, you have to hit escape like that. But you'll notice now we have a line here, and also if I hit escape, a line here like so. So that's broken it at that point, that midpoint I selected. So that's the AM brake at point, the AutoCAD mechanical toolset specific one. So let's just undo that quickly. I'll just click on undo and we'll just check that that's one whole line again, which it is like so. Now the flow for the brake at point command, the regular one, this one here in AutoCAD, has changed as well. It's slightly different. It's different to this one, the brake at 1 point. So I'll click on brake at point like so. Now you need to select the object first this time instead of the cutting point. So I select the line. So I left click on it and then it asks for the brake point. I go to the midpoint snap. Now you'll notice, hang on a minute, there's no midpoint. What's going on there? Because I did an undo, I need to go back and make sure that my midpoint snap is on and my object snaps. So that's done. And then back to midpoint, click, and it takes me straight out of the command. It's a one-off like so. But I can right click and repeat brake at point on the shortcut menu if I want to, or I can just press the space bar or the enter key and that repeats the brake at point. Look down at the command line. You can see that brake at point is waiting for another object to be selected. I'll just hit escape a couple of times and you can see now that we have a line here again, hit escape, and a line here again, hit escape. I'm going to undo that again, like so, and just make sure that it's one line again, like so. Now it isn't, so I need to do two undos in this case. Let's jump back again, and you can see it's one line again. So what we've done there is we've gone through here, the AutoCAD mechanical brake at 1 point, and the brake at point command, the regular AutoCAD brake at point. Now there is one more brake command available. Again, it's in your regular AutoCAD as well. It's this one with the little 2 blue dots on it. So if I click there and select brake, it says select the object. So I'm going to pick on this line like so. Now it asks for the second brake point. The first point where I selected the line becomes the first brake point as well. So what I need to do is right click and go first point. And I'm going to go to the midpoint snap. Remember, the midpoint is undone because I did an undo. So let's pop that back on again, like so. And I'm going to go from the midpoint there to the intersection just there. Now I want that intersection with that balloon line. So why am I not being able to intersect with that? It's a bit interesting. There's something going on there. Let's just check the object snaps, make sure that intersection is on. I'll switch on apparent intersection as well. Let's see what happens now. There you go. It's still not linking with that balloon line. Now, the reason it isn't is balloon lines aren't actually snappable like that. So what I can do, I'll pick a point along the line, and as you can see, it breaks between the 2 points, the first point and the second point. You'll notice there that that is all one object, that balloon. Can you see that there? So there's a point there and there's a point there, but there's no other points I can snap to on that line, unfortunately. It's not a problem at all. But as you can see, if I did have an intersection there, I could have snapped to it and got a second break point and made a little gap there. I'll just hit escape a few times to deselect everything. Undo, just to bring the line back to its original line again. So we'll keep clicking on undo until we get back to where we were before. So we want to make sure that we undo everything. Keep going back and we're zooming and we should now have a whole line. There we go. So just double click on the wheel, zoom extents, and you're back to the drawing the way it was before. So those break at point and break commands are incredibly useful when you're working with line work on your drawings in your AutoCAD mechanical toolset. So just make sure you get used to those, and remember the workflow for the AutoCAD mechanical break at point is subtly different to the workflow, the regular break at point in regular AutoCAD and also the mechanical toolset. In this particular chapter, we're going to look at how we can manipulate our mechanical geometry in the AutoCAD mechanical toolset. We've got a new drawing for that because we're going to look at some basic editing tools first, and that is a drawing called weld_flange001.dwg. You can see it on the screen there. Just download it from the library to follow along with this particular video. As usual, open it up in your AutoCAD mechanical toolset. Once you've opened it, just zoom to extent so that you can see everything that's going on in the title block on the screen. Now we're going to take a look at some of the basic editing tools. Now I'm going to show you a really clever little trick with the offset command. Now you'll notice here in the sectional view and the side view that we've obviously got some offsets going on. So if I took those across here orthographically, you'd have various concentric circles. Now, one of the really nice tricks with the offset command is it allows you to offset more than one distance at the same time. You just need to use a specific symbol on the keyboard. So I'm going to jump to the Home tab on the ribbon, into the Modify panel, and there's the offset command right there. Click on offset. You'll notice it is the AM offset, AutoCAD mechanical offset. It's not the regular AutoCAD offset in this case. So you've got some various things that you can do. Now, you'll notice it says specify offset distance down there on the command line. Click in the command line, it will highlight, and there's the little flashing cursor, like so. Can you see that? There's a little flashing cursor. I'm going to type in 5, like so. It's asking for an offset distance. Then I'm going to type in what is called the pipe symbol on the keyboard. It's like a little vertical line. It's normally located either shift and your down arrow on the keyboard, or if you're using something like a Mac-based keyboard, it's often near the enter key, but it's normally a shift and then you press the key. It's that one like that. Can you see it's like a vertical line? I'm then going to put in another value, 22.5, and another pipe symbol, like so, and then 24, and then another pipe symbol, and then 39. So what I'm telling AutoCAD there is I've got 4 offsets to do to those distances. So when I press enter now, it'll prompt me to select the object to offset. If I click on the outer edge of the circle with the pick box and move inwards for the direction of the offset and left click, there's my offsets all done. I just press enter to finish, job done. I don't have to offset any of those circles more than once because I just use the outside circle and just put the values into the offset command, the AM offset command. It's kind of clever, isn't it? Looks good. So let's move along now to this side view. There's the sectional view. So that now all tallies up here with the front view. All those concentric circles represent all these little details here on the section view. I'm going to zoom in on the top of the side view here, and you'll see that some of the lines don't meet up at the top. So I'm going to get in nice and close so I can see what's going on. Again, I'm going to the Modify panel, but I'm going to click on the little flyout arrow and just pin it open. Now, in regular AutoCAD, you have the regular join command, which will join lines and arcs that are collinear. In AutoCAD Mechanical, the mechanical toolset, I've got this one here, join, and it joins non-parallel lines, polylines, arcs, and circles. If I go to that one, I can reverse the lines, but it's this one here. Notice there is no regular join command, just this one. Click on join and come into the drawing area. Now it's asking you to select the first object to join. So if I select this vertical line here and this horizontal line here, just click on each one. Look at that, just join them together. How quick and easy is that? And they are non-parallel. If I go back to join again and I select this horizontal line here and come to this side of the angled line here and click here, it joins that as well. If I zoom out, the end of that side view is now nice and neat and tidy. What I can do now is just click on the pin and allow the Modify panel to go back into the ribbon. So you can see there now that I've got a nicely tidied up side view. We're going to copy that side view now twice for version 1 and for version 2. Remember to use the regular copy, not the power copy. So this is one of those occasions where you go up to the modify panel, click on the flyout next to copy, and select the regular copy command. Power copy produces an identical copy of a specified object. You just want to copy objects. You just want to copy multiple objects. So use the copy command. Click on copy, and again, left click there, drag the window over everything that forms the side view, like that. Left click again, like so. Enter to confirm the selection, and it'll ask for a base point. Just use the intersection there of the two center lines, left click for that, and then just drag it along. Make sure your polar tracking's kicking in so they're all level. So I'm going to put a version 1 there, left click, and a version 2 there, left click. Enter to finish, copy is done. Now we're going to use a really clever little editing tool in the AutoCAD Mechanical Toolset. You'll notice we have a scale command up here. It's the same scale command that works in the regular AutoCAD, but it will scale in both the X, Y, and Z directions all at the same time. There's a really cool command available in AutoCAD Mechanical, and it's called AM Scale XY. So type it, AM, and then scale, and you'll see it pop up. There it is, AM Scale XY. It pops up on the dynamic input. Just select it, and it will prompt you to select the objects that you're going to scale. So this time it will allow you to scale in either the X or the Y direction. So what we're going to do, we're going to select all of the objects. So we click there, drag the window over all of the objects like we did when we were copying, and left click again, like so. We then press enter to confirm the object selection. Now it'll ask for a base point. I'm going to use that intersection again. So make sure you get that little intersection in there like so. It might be a midpoint as well. Don't worry if it is, and then zoom out again. Now it's asking for the X-axis scale factor this time. So what I'm going to do, the X-axis scale factor, I'm going to change that to 1.25. So that's horizontally the X-axis. Press enter. And the Y-axis scale factor, 1.00. So it'll stay the same size. So the height of that version 1 will stay the same, but the width will change. When I press enter again, can you see it gets wider? It's now 1.25 wider. So in essence, 25% bigger. So I can do that in the X direction. I can also do that in the Y direction as well. So let's have a look at version 2. So I can right click, repeat AM Scale XY, select the objects, just click, release the mouse button and drag, and then click again. Get everything in that window selection. Enter to confirm the selection. Same base point, it will be a midpoint there or an intersection where those lines intersect. And then the X-axis scale factor this time, I'm going to leave it the same. I'm going to leave the width of the object the same. So it's going to be 1.00 and press enter. The Y direction, the vertical direction, I'm going to change that to 0.75. When I press enter, you'll see it's 0.75 high, so 3/4 of its original height, but the width, 1.00 in the X direction, has stayed the same. So you can see there that there's some really cool basic editing tools available in your mechanical toolset. And some of them can save you a lot of time, especially that offset one with the concentric circles with that little pipe symbol on the keyboard. It really makes a difference. So get into some of those basic editing tools in your AutoCAD mechanical toolset. We're going to be taking a look now at the power commands available in the AutoCAD mechanical toolset. So we've got a drawing for that purpose. It's called power_commands.dwg. You know the drill by now. Download it from the library to follow along with this particular video. When you open up the drawing, you'll see that you've got a title block and various orthographic views of a component in the drawing. We're going to zoom in on the lower right part of the title block first, where it says using power commands. Now, this particular part of the title block is editable as a block using attributes, but it's preset using the preset standards in the AutoCAD mechanical drawing. So if I hover over this title block and double click, can you see there that I can change the title block entries? So if I change the drawing number from a hyphen to something like 001-1983 and click on OK, I've power edited the title block. Now the title block itself forms part of the actual title sheet, so to speak. If you double click on the wheel and zoom extents and then double click on the edge of the title block, you'll see that you can set up drawing borders with title blocks using the preset standards in the AutoCAD Mechanical toolset. Saves you a lot of time because they're all preset with preset attributes. So there you go. There's the A3 sheet that I'm using. There's the title block I'm using, ISO title block A. Notice there's also a title block B in this particular standard, and the scale is 1:2. There's the scale 1:2 on the title block there. Now I can set up all these different scale factors, automatic placement, etc. I'm not going to make any dramatic changes. Also be aware though, you can import from other drawings if you want to. I'm going to click on cancel because I don't want to make any changes to the title block right now. Now we're going to zoom in on the top view here. It's the top left view in the drawing. So we're going to zoom in on there and then just pan down a little bit and look at these dimensions on the top right corner of that top view. We've got 120, we've got 150, we've also got a 135 plus or minus a tolerance of 0.1. If I double click on that dimension, I go into the Power Dimensioning tab on the ribbon. Power Dimensioning is specific to the AutoCAD Mechanical toolset. And you can see there's a whole load of tools up there where you can work with your dimensions in your mechanical drawings. Now this particular dimension has a tolerance. So if I go to the Fit Tolerance panel, there's the tolerance switched on, there's the tolerance values there, and I've got the method that it can be displayed as well. If I just switch off the tolerance by clicking on the word tolerance, see it's not blue anymore. If I click on it again, there's the little tolerance again. So I can turn it off. Then if I click on the green tick, close the editor, the dimension becomes a normal dimension without a tolerance. Very quick and easy. I'm just going to zoom out slightly now, and I'm going to zoom in on this hole in the top view. You can see we've got a radius 10 there, like so. Now this hole, you can see it's got varying fillets going all the way around, all of a radius 10. I'm going to double click on the fillet that has the radius 10 dimension on it. So if I double click on that radius there, that arc, can you see it's a fillet and it's letting me know what the fillet size is. Now I've got preset fillet sizes. So if I select 2.5, that will update the fillet size. I'm also going to tick the insert dimension on fillet box. So when I click on OK, you'll see now that it kind of gets rid of the fillet and the dimension. Just hover down here. Can you see if I hover on that line there, can you see it places a new fillet? Can you see it's highlighted in blue to the left? Come down here, hover on there, and it places a fillet between the horizontal line and that highlighted blue vertical line. Click there, and there's the fillet, and I can now place the new radius 2.5 dimension. Job done. Now that will automatically take me into Power Dimensioning as well. I don't want to make any changes there, so I click on the green tick to close the editor. So I've updated that particular fillet. Now, if I select this one here, I want to change the other three, and just press enter, you'll see I get this option with the fillet there. I can either go to next or accept the fillet command. So if I come here and accept the fillet command now, can you see it takes me back into that fillet dialog box? I'm going to go back to the drop down and go to 2.5 because I want the other three to be that 2.5 size as well. I'm going to untick the insert dimension on fillet this time. I don't want the dimensions. I click on OK, and you'll see there that I get to select the object. So I click there, and you'll notice, as you can see, it's updated that fillet there like so. So it's found 1 and 2 in total. If I press enter now, can you see it updates, and all I've got to do is highlight that one there. Click there, enter to finish, and it's done all three. Now that is a little bit of a weird workflow, but you'll get used to it. It's very, very kind of picky on where you select the lines to put the new fillets in. It takes a little bit of getting used to. It's very different to the regular fillet command in the regular AutoCAD. But you can see how useful it is. It's a big time saver because you've got all the radii on the drop down. You can define on whether you want the dimension for the fillet radius to appear or not. So it's a big time saver. It's quite a useful one, that fillet command. I'm going to zoom out a bit now and pan down to this view here. So you can see there's the side, one of the side views there. If I zoom in a bit, you can see we've got various dimensions available. So we've got things like the 35 dimension, the 30 dimension, the 71, etc. Now, what I can do is I can use a really clever tool called Power Erase. That's up here on the Modify panel. And if I click there, there it is there. So it's AM Power Erase. If I click on that and I select some power dimensions, which are the 35 and the 71, and I press enter, watch what happens to the rest of the dimensions. Because they're power dimensions, they all tidy up neatly for me and pull in towards the geometry of that particular view. That power dimensioning is incredibly powerful, if you'll pardon the pun. There's a lot of tools in that power dimensioning that will make your dimensioning annotation so much quicker and so much more productive. What we'll do now is just double click on the wheel to zoom extents, usual CAD etiquette, make sure that everybody can see everything in the drawing. And you've now edited your drawing in the AutoCAD Mechanical toolset using some of the power tools that are available. We're starting a new video now, and we've got a drawing for you to download from the library. It's called workcell_001_conveyor.dwg. And you know the drill, download it from the library, open it up in your AutoCAD Mechanical toolset, and use it to follow along with this particular video. Now, in this particular video, we're going to look at how the mechanical structure works with what they call associative hides. Now, associative hides select specific geometry and show it as hidden detail in what they call a hide situation. Now, the first thing we need to look at is the structure setting in AutoCAD Mechanical. Come down to your status bar and you'll see an icon here, and it says Mechanical Structure On. So what that indicates is that there is a structure with various components in the mechanical browser. If I try to turn that off, it'll tell me it can't be turned off because there are structure entities existing in the drawing. Delete the structure entities and then I can turn it off. I'll click on close and I'll come down here to the workspace cog here. So if I click there and select structure, you'll notice that I've got a workspace that kicks in and there's the mechanical browser. You'll also get the structure catalog palette. You don't need to worry about that for this particular course. That can be closed. So we'll close that palette. So basically all I've done there is I've switched on the mechanical browser, which we've had switched off for the last few videos. I could have done that in the view tab here in the ribbon and gone up here and turned the browser on or off like that as well. It's entirely up to you. I'll go back to the home tab on the ribbon now. Now, one of the things I can do now is you'll notice if I click here, I still can't turn that mechanical structure off. Now, the reason for that is I have a structural entity there, like that. If I expand that out, I've got footplate 1 with a side view. So if I click on that, it's that little footplate down here. Watch down there, hover over it in the mechanical browser, there it is. So what I'm going to do now is I'm going to click on footplate 1, and I'm simply going to right-click and delete that structure entity. So there's footplate. I don't even need to select it in the list. I just say yes. And that all disappears. So now I'm left with just a mechanical drawing with no structure in the mechanical browser. I can now come down here and you'll notice I can click on the mechanical structure and that can now be turned off because I've got no entities in there. Now what we're going to do is we're going to create what is called a hide situation. Now that's going to be on this left-hand leg of the conveyor platform here. So make sure that you've got that zoomed in. Like so. Now you want to get in so that you can see all of that leg and all of the holes and all of the lines. We're then going to go to the structure tab on the ribbon. And there you can see hide situation and we can create one there. If I go to the home tab, you'll also notice hide situation here and you can create one off of the home tab as well. It's up to you which way you go about it, but click on create like so. So we need to select the foreground objects for the hide situation. So these are going to be the lower part of the leg itself. So you'll see there's an outside edge. I want that one there. And I also want here the elements inside. So if I zoom in, what I'm going to need now are these holes. So I'm going to go for 1 and 2. And you need to zoom in nice and tight and get the hole. Can you see that? That one there, that one there. And there's a hole in there somewhere. You just want to get in nice and tight. There it is like that. Now, again, you want to make sure that these elements are selected and it's prompting you to select the foreground objects in that case. So they're the ones that are going to be at the front. Now, I am just going to zoom in on that one there because it looks like I've got a hex bolt instead. So I can hold down Shift and deselect what I don't want like so. And I want to get just the circle. So you'll notice there should be a circle there. Just click on that circle and you'll see it does actually form part of that bolt. So again, just a quick sanity check there to make sure I'm selecting the appropriate foreground objects. So now I right click to confirm that, and you'll see now that the hide situation dialog appears. You'll also notice now that you've got a hide situation in the mechanical browser. Now, level 1 was the elements that you've just selected, but it's preset level 2, which are all these highlighted objects here. So we're going to go to level 2 there and see where it says free objects. I'm going to right click on that and remove those objects like so. So now when you zoom out a bit and you click in the drawing area in a moment, you'll see 1, 2, 3, 4 and the outline. That's your foreground objects. We need to come into the drawing now and select the objects for the level 2 part of the hide situation. So I'm going to click here, select objects, takes me into the drawing. I'm going to roll back a notch and pan down. Now the objects on level 2 are going to be these ones here that go into the channel to allow this leg to be adjustable. So I zoom in a tad and just pan down a bit. Make sure you can see everything. You want 1 and 2 and 3 and 4. So there's the outline of the leg that goes in and out of the channel to adjust the height of the conveyor. Now you also want the slotted holes. So there's 4 of those. So there's 1 there. There's another one just there. And if you zoom in, you've got to make sure you get the right one. That one there. And there's 1 there as well. So there's 4 slotted holes. Can you see them? And the outline. Again, it's a right click to confirm those objects. And they're now in the free objects for level 2. I'm going to click here and create a new level, which will become level 3. Make sure you select it in the list and click on select objects. That's going to be these square holes here, like so. So there's those square holes there. They're kind of square sectional holes. Right click again and they're added to level 3. So now I need to rename the hide situation because it's just called hide at the moment. Right click on it, rename it. And that's going to be leg and then a dash, and then I'm just going to put front left for now. It could be anything, but it's just a very simple description. Press enter to confirm. If I click on OK now, what will happen is I've got my hide situation here, and if I expand that out, there's the 3 levels of the hide. And if I click on leg front left, you'll see there, can you see all the objects highlight when I'm in the browser? I can also right click and display the hidden lines. I can suppress them, I can highlight them, etc. But the whole idea of these hide situations is with that selected in the browser now, when I hover over it, they're all the objects that are hidden. So if I come out again and just hit escape there, you can see that there's all the objects that are hidden. Now, if I go back to main, for example, that's the main drawing, and you'll notice there that you can see there that obviously I've got various hidden detail. You can see all the purple. Now, all that purple is on a specific AutoCAD mechanical layer. And if I zoom out now, it looks a lot better. You can see what's going on there. Everything's hidden, and that hide situation allows me to obviously show what's going on behind the actual outside of the steelwork for the adjustable leg for the conveyor belt. Now, if I come over the hide situation here, you'll notice I can expand it or collapse it like that. I can do that. If I click on that hide, it highlights that. And can you see it's highlighting each one that I set up previously? Each one is highlighting as we go. And there's the leg front left with all of the elements in the hide situation. So the whole idea of these hide situations is that it's providing you with the ability to show what's in the foreground, i.e. if you're standing there in real life and looking at it, and then what's hiding. The hide situation shows the hidden detail. So instead of having what I call permanent continuous lines, the hide situation in this case is showing everything that needs to be shown in hidden detail on that magenta dashed line type. And it's very clever in AutoCAD Mechanical. You can have as many hide situations as you need for whatever you're working on in your AutoCAD Mechanical drawing. We're going to take a look now in a bit more depth about how we create and edit those associative hides that we talked about in the previous video. For that, we have a new drawing for you. It's called mechanism001.dwg. You know the drill by now. You need to download it from the library and follow along with this particular video. Now, when you open up Mechanism 001, you may notice that the mechanical browser isn't available. You can open it up in 2 ways. You can come down here to the workspace and set the structure setting there in the workspace. That'll do it that way. and you'll see that you've got your structure catalog there. You can just close that. We don't need that for the video. There's the mechanical browser there, or you can just use the View tab like so, and there's the mechanical browser there in the palettes panel as well. Now, you'll notice in this particular mechanical drawing, we are in the Mechanism 001. And if I expand this out, we've got Drive System 1. Now, if I click on Drive System 1, you can see that highlights everything. Then if I click on Drive System and I come, there's a top view, there's a side view, and so on. What I'm going to select is Frame 1, like so, and then I'm going to hold down Control, and I'm also going to select the Sprocket Bracket Base 1 there, like so. So those two parts of the structure in the mechanical browser. You can see them highlighted there as I hover over the mechanical browser as well. Come away, they de-highlight, come back to the mechanical browser, they highlight again. I'm going to right-click on Frame 1, and I'm going to go to Property Overrides. Now, I want to override some of the properties in these particular parts of the mechanical structure. So I'm going to click here, Override Properties, switch off Hidden Lines, like so. We don't want to display the hidden lines. So you'll notice here, all of these magenta dash lines, when they're switched off, they'll disappear in a moment. We only want the center lines to display. So make sure that center lines is ticked. The predefined and the color, just leave them as they are. Click on OK. And you'll see all of those hidden detail lines disappear and only the center lines are left behind. So that's all great. What we're going to do now is we're going to work on the side view over here. So see the side view there? There it is, that view there. I can actually double click on that in the mechanical browser. And can you see it kind of highlights it a little bit? But what you'll notice on the ribbon as well, can you see we've got an Edit Structure panel kicking in on the ribbon? I'm going to go now to the Structure tab on the ribbon as well. And can you see those are still there? There's the Edit Structure, Add, Remove, Change, Close, Edit Structure. Now, what we're going to do is we're going to create a hide situation, like we did in the previous video, but on a specific part of this side view here that's highlighted in the drawing area. So what you might want to do is zoom in a bit as well. So let's do a bit of zooming and panning like that. We need to be able to see the side view. I'm going to click in here on the hide situation panel and click on create, and it now asks me to select the foreground objects. Now I'm going to ask you to do something a little bit strange, which is just keep clicking on the objects. Can you see that? As I keep clicking, it keeps showing me all the different elements like that. So there's a line there. If I click here, can you see? And that's what I need there, that bit there. And if I hover over it, it's Drive Axle Bracket 1 Front. That's what we're looking at right there. So that's the view we're looking at. Now, that is everything we need in this particular hide situation. So if I now press enter, you'll see there's my hide situation popping up. And I've got all the elements there. So I've got the axle bracket and so on, holes and so on. So what I can do now is if I click on each of these, it will show me the bits that I've got in the hide situation. There's the 3 objects there. I've got the holes. See, there's the holes there, the 4 holes. There's the sprocket, which is that bit there. And I've got some free objects there as well. Now, there are some free objects that I don't need. Now, some of those objects are there. See those free objects there? So I select them, click on the cross. It removes those from the view. So now, can you see that hide situation is only including that little bit there? So I need to just make sure that this is all working. So the trick now is to rename the hide view. You don't want to call it hide. So click on there. Right click, and I'm just going to rename this as, let's say, front or end drive or something like that. Drive end front. Let's just call it drive and then dash and then end and then front like that. Now you could call it whatever you want, but you need it to be something a bit more descriptive than just hide for a hide situation. Press enter and that renames the hide situation. So what I can do now is I can click on OK, and that hide situation is now employed in my particular AutoCAD mechanical toolset drawing. If I expand the side view here, there's the hide situations there. If I select drive end front, there it is there, highlighting in the drawing. Now, here's the clever bit. I can right click on this. I can zoom to it. There you go. And I can also right click on it. I can suppress the hide as well. If I click there, can you see it all goes back to the regular layers? So it's got like a continuous line on the sprocket. If I right click on it again and switch off suppress, it goes back to the hidden detail, the magenta dashed lines. And as I said in the previous video, what it does is a hide situation shows the objects in hidden detail. So it's as if you're actually standing and looking at this side view now, and you're actually looking at it and you can't see it, if you see what I mean. That magenta hidden detail will be behind what you're seeing on the object. And that's how you create these hide situations in your AutoCAD mechanical toolset drawings. That's how quick and easy it is. So once that's done, I can go back up here now to close edit structure, click on the green tick. That's all been done and dusted. And there's my hide situation there when I need it. I can right click on it. I can zoom to it. I can even highlight it. There you go. I'm highlighting it now in the drawing. And I can right click again and I can zoom to it, edit it, rename it, or even delete it if I want to. I just hit escape a couple of times to deselect, like so, and I can now save the drawing if I want to. I'm just going to double click now on the wheel to zoom extent. And can you see now that that hide situation is highlighted there like so? And what I can do is if I don't want to see it highlighted as if it is a hide situation, I just simply right click and suppress it like so, and it just looks like regular detail. And then I can right click it and unsuppress it again, and it shows the hidden detail again in the view in the AutoCAD mechanical toolset. It's that quick and easy. And these hide situations can be utilized for when you want to plot your drawings or display your drawings and communicate your design intent. So get into those hiding situations in your AutoCAD mechanical toolset. They're incredibly useful. And what's lovely about it all is all the layering, the magenta color, the dashed line type, etc. It's all automatic. As soon as you start hiding and adding objects to a hide situation, the AutoCAD mechanical toolset puts it on the appropriate layer in those managed layers to make sure that you've got the appropriate color and line type to show it as hidden detail. One of the major benefits of the AutoCAD mechanical toolset is what they call mechanical part generators. And we're just going to look at some standard parts in this particular drawing. Now, the drawing that we've got for you is called bush_assembly001.dwg. You can download it from the library to follow along with the video. You'll also notice I'm in the Content tab here on the ribbon, demonstrating all of the content that comes with your AutoCAD mechanical toolset. Now, we're going to be looking at the sectional view over here, top right. I'd like to zoom in towards the top of it, like so, and just pan down a little bit to make sure that you can see this face here. There's a line, flat line there at the top, and we're going to place what is called a drilled bush through that particular part. Now, I'm going to ask you to type something, so make sure that your dynamic input is on. My dynamic input is down here, like so. You can also type in the command line there if you wish. By clicking in there, you'll see the little cursor appear like so. Now, I'm going to start typing AMD bush, like so. And you'll see eventually on the suggestion menu that you've got AMDR bush 2D, AMDR bush hole 2D. You want the one that says hole 2D. And we're going to insert a drill bushing and the corresponding hole from the content library. So if I click there, like so, that'll take me into drill bushings. Now, this might sound a bit strange and a bit weird, but those drill bushings are what go in place to allow a drill to go through a particular part. Now, we've got a choice. We've got front or top. In this case, if we look at our view there, it's obviously a front view, so we click on front. That'll bring up the different types of drill bushings that you can use. There's a headed type with a flange around the top, or there's a headless type that is just smooth, as you can see. We're going to go for a headed type, like so. And this is one of the standard parts that you get in those content libraries in your AutoCAD mechanical toolset. Lots of different standards there. We're using millimeter metric, so we're going to go for the ISO 4247. Now, we need to specify the insertion point of that bush. Go down to your object snaps, click on your little arrow there, just check that that midpoint is on. It is now. And then I'll click on the little flyout arrow again, and you want the midpoint just there. Can you see the midpoint snap? Left click. Now, it'll ask for the whole length. So as you come down, you need to specify the whole length as you come down vertically like that. Now, I'm going to specify a whole length there of 20, like so, and press enter. and that's the hole in place. And now it asks for the rotation angle. Now remember, 0 is over here to the right. You're coming downwards. So that angle, can you see on the polar, is 270. Enter. Now it will ask you for the nominal diameter of the bush. I'm going to put in 8 millimeters there. That's the diameter. And then click on finish, and that'll place it like so. Can you see that? And now it's asking me, where do I want this to go? Drag the size. Now you'll notice as I come down, it gives me different sizes, different increments. I'm going to type in 20 and press enter. And there's my bush with a hole like so. Now you'll notice I've got an edge of a hole there as well because I've done the bush with the hole. Now you might have thought that you need the hole there as well, but really all you need is the bush going through that part. The hole you don't really need because there's a gap there. So how do I fix that? Well, let's just undo what we've just done. And obviously it disappears like so. Now if I AMDR again like that and just go AMDR bush 2D, you'll notice it's a very, very similar workflow. There's the headed type. I'm going to come down the list and find my ISO 4247. I'm going to go for a front view. And again, the insertion point will be the midpoint snap. Remember, you've done an undo, so check those object snaps. Midpoint will need switching on again. And then click on the arrow there to lose the object snap menu. There's the midpoint snap there again. And I come down the polar tracking line. Remember, can you see? I want the angle there like so. So I want 270, 270 for the angle. And then again, dialog box is exactly the same. Put in the 8 millimeter nominal diameter and click on finish. And look, there's the bush again, but without that extra hole, without those extra lines. And again, I'm getting the same increments. So I drag it down, type in 20 for the drag size and enter. And notice this time it puts a hide situation in automatically for me. So I'll just OK that, and any hide is in place now. So if I brought in, for example, the mechanical browser now, let's go over to view and the palettes panel. You'll notice there now, if I start looking and start checking things like the press fit bushing head type, there it is there, and there's the front view there. And it's put a little hide view in because it's got things that are hidden now where it's going through. And also, if I create other views off of that, I might need hide situations placed elsewhere. So you can see there that using the standard parts from the content library in the content tab here, you can add information to your mechanical drawings very quickly and very easily. We're staying in our bush assembly 001.dwg file. All I've done is performed a zoom extent so that you can see all the views in the drawing. You'll notice over here, there's our bush that we added earlier. There it is there, our press fit bushing headed type. Now we're going to look at this top left view here and we're going to zoom in a bit so that we can see what we're doing. Ideally, you need to be able to see this center line here and also this center line here, this one here, because we're going to be using the intersection of those two lines. Now we're going to place a new object from the content tab. So we're going to go to the content tab and we're going to go to the fasteners panel. Click on this little fly out here and we're going to add what is called a clevis pin. Now a clevis pin you can see is a little pin with a hole in the end, and you normally put a little fixer through the hole to stop the pin coming out. So I'm going to click on clevis pin like so. Now I've got lots of different types of clevis pins in the content libraries. We're going to use a headed type, that headed type there. And then as you can see, as usual, lots of different standards to work with. Now, as I said, I'm working in metric millimeters, so I need the ISO standards. And I want this one here, 2341 1986A. Click on that one, and you can see I've got various views of it. I've got the right side, the left side, and the front view. Now, we're going to need a left side view. Now, a left side view is looking from the left over here, looking at the top face of the pin. The right side view is looking from this end, hence you've got the hidden detail, the magenta, showing the top outside diameter of the top of the pin. So I want left side, like so. Now, the insertion point is very easy. We're going to utilize our object snap tracking. So we're going to hover over this endpoint here, like so, don't click, and then hover over this endpoint here again, don't click. As you drag outwards, you'll see an intersection between both of those endpoints. That's your object snap tracking kicking in. Just left click, and you'll see now that you've got the rotation angle of your clevis pin. Now we're just going to press enter to accept 0 this time, and it'll now ask us for the size of clevis pin. Note on the left hand side which piece of information you're putting in. It's diameter first. So it's a diameter of 4, and then click on next. The length will be 20, like so, length 20, and click on finish. And that places a nice little clevis pin with its own little center mark as well. If I hover there, you can see it's a content part, and it's a clevis pin using ISO 2341, and it's a size A 4 by 20 based on the information we put in. Now, I'm going to go back now to the annotate tab on the ribbon. And what I want to do now is add what is called a leader note to notate what that is. It's a clevis pin. So if I click on this down arrow here for leader note, you'll notice there's not much in there. Nothing recently used. I can insert a new symbol. Don't worry. You don't need to worry about that at all. You just click on this one here, leader note. It creates a leader note and attaches it to an object in the drawing area. Click on it and select the object. You want to click on the diameter circle bit of the clevis pin, like so. And can you see it's a bit like a multi-leader? You've got the arrow coming off. That's all standardized and on the right layer using the layer definitions in the AutoCAD Mechanical toolset. So I'll just take that out to about there and click. Then it asks for the next point of the leader line or symbol. Now, based on the symbol we've already provided, what I can do now is just press enter. And you'll notice as soon as I do that, it goes, oh, look, it's a clevis pin using that standard. It's an A type and it's 4 by 20. It's remembered all of that because it's linked it to the content library. All of that information has come from the content library, but you do have a leader note tab on the ribbon where you can edit that leader note if you wish. I don't want to edit it, and I'm not going to bore you by going through all the different settings, templates, etc., etc. But a lot of it is standard text type stuff, things like justification, leader justification, underline, and all that kind of thing. I'm going to close the editor by clicking on the green tick. And I've now put a lovely little bit of notation in my AutoCAD mechanical drawing to let people know that that is a clevis pin using ISO 2341, and its diameter is 4 and its length is 20. How quick and easy is that? What a fantastic productivity tool and time saver in the AutoCAD mechanical toolset. In this video, we're going to take a look at how we use the content libraries and the content libraries palette. So you'll notice I've got the content tab going here up on the ribbon. Now, when you open up this new drawing, it's standard part 001 underscore content.dwg. The standard is spelt STD, so it's STD part 001 underscore content.dwg. You know the drill by now. Download it from the library to follow along with this particular video. Once you've got the drawing open, just make sure that you're in the Content tab on the ribbon, and then we're going to zoom in on this little area here on this bottom right view. You'll see that there is a section view there. We've cut through the section, the actual steel section. There's some bolts, but also there's a part section here. So that's the bit you want to see with the hatching there and the hatching there. And we're going to be working in this little part section area here. Now, what I've done deliberately is when you go and click on the content libraries here in the library panel on the content tab on the ribbon, it'll open up the content libraries palette in a certain location. So you can see there we've got DIN, shaft parts, roller bearings, radial. I'll explain why in a moment, but also you'll notice it's a palette. So the good thing about palettes, you can auto hide them and leave them open if you want to. Hovering over the title bar, and there it is there. I'm going to switch off the auto hide. I can also right click, I can anchor it left, anchor it right, dock it, etc. Just like any other AutoCAD palette. Now, staying in the content libraries palette though, I'm going to use this slider bar and slide up to the top. There's so much content in the content libraries palette. There's the standard content there. So I've selected standard content, and then I've gone to the DIN standard. And then once I've gone to the DIN standard, I've gone and looked for roller bearings under shaft parts, because it's a shaft and we need to add a roller bearing to it. So there's shaft parts. I then click on roller bearings and go to radial roller bearings. And there's a standard there, DIN 615-2008. That's the one I've selected, and there's the views we've got there. I just wanted to explain how we got there. That's really important. Now we need a front view of our roller bearing, that one there. So I'm going to click on front. And as soon as I do that, you'll notice when I come into the drawing area, it's asking to specify the insertion point on the shaft contour. Now, we need to be able to see that. So I'm just going to drag the palette over a bit like so. That'll come over there. And then in the drawing area, hold down the mouse wheel and just pan a bit so that you can see your part section here. Now, the insertion point on the shaft contour is going to go to that little intersection just there, because I want the roller bearing to go around that rectangle there. So this rectangle here. So I'm clicking on that intersection there. And then it selects a point on the center line. You can drag, see the nearest snap kick in, as long as it's somewhere on that little blue center line. Left click. Now this is where it gets interesting, because we've got to make sure that the inner diameter and outer diameter have specific values. Now also, you've got conditions. So you want equals there, and it's going to equal 17, 1, 7. And then the outer diameter, we're going to have a less than or equals, and the value is going to be 44, like that, 17 and 44. Don't ask me how I know, it's just because of the way that this exercise is set up. Everything else can be left as it is. Click on next. Now, you'll notice here it's done various calculations for loading. These are all default values, all these calculations. Leave them exactly as they are and click on next. So it's done its calculations. There you go, L and BO, those are the two values we need. We select both of those, click on the first one, Control, click on the second one. See the results, update accordingly. So we're utilizing those results there to actually place our roller bearing. So when I click on Finish now, you'll see now that there's our little roller bearing, and we can specify it can go there. We don't want it there. We want it around that rectangle. So if I drag my crosshair over here somewhere, sort of top left, and just left click for position, you'll see it's now placed that roller bearing around that shaft in the part section. We can now close the Content Libraries palette, zoom out a little bit, and you can see there's our roller bearing going around that shaft in section. And if you hover over it, you can see there, it'll take a few seconds, but there's our content library item. It's a magneto ball bearing using DIN 615 with the calculations that we put in earlier. And it's really clever stuff. It calculates all this for you and puts it in as a standard content library part from the Content Libraries palette. One of the really cool things that you can do in your AutoCAD mechanical toolset is calculate the lengths of chains and belts that go around your gear wheels, your sprockets, etc. Now we've got a very simple drawing for you to use for this particular video. It's called gear_assembly001.dwg. As usual, download it from the library to follow along with the video. When you open it up, you'll see a couple of gear wheels, and there's a sprocket over here as well with all the teeth on it. Now, what we're going to do, we're going to go to the Content tab on the ribbon, and we're going to go all the way over to the calculation panel at the end. And you'll see there's a chains and belts option. Click on the down arrow, and we want to perform a length calculation first. So we click there like so. Now, you'll notice there's various settings in this particular dialog box, and we need to do a belt and chain length calculation before we add the belt or chain to those gear wheels, sprockets, etc. So we need new tangent definition between the sprockets or the pulleys. We are also going to be using a chain. Now, you'll notice library, I can click on it and go to the library and pick a chain. We're not going to do that yet, so don't click on library there. If you've already got a library definition here, don't worry, we can fix that as we go through. Now, we're going to select length calculation there like that. So we've got new tangent definition, chain is the option we're using without any library issues here, and we're going to go length calculation. Everything else is grayed out, you can ignore that, just click on OK. Now, this is where you need to be somewhat methodical after we've selected our chain. So you'll notice we've gone into the library anyway to select the chain. Now, you'll notice in the chains, there's lots of different ones. I'm going to go down and find an ISO one, and I'm going to use the ISO 606 metric. I'm working in metric millimeters in my drawing, so ISO 606 metric works, that one there. Now, there's lots of different part sizes for chains. I can scroll down, you can see that there's loads of them, all different ones. I'm just going to use the one at the top, an ISO 60605B1 roller chain. Select it, click on OK. Now, this is where it gets a bit interesting. You need to be methodical. Now, it's asking for the first point of the tangent. Now, the chain is actually going to join using the center lines, which are the cyan colored lines, the center dash lines here, these ones. So can you see you're hovering over that blue one and clicking? If I zoom in a bit, it's this one here, the cyan one. Click there. That's the first point of your tangent. I'll zoom back a notch on the wheel, and then there's the next center line there. So there's the first part of my tangent there. I need to be methodical and do the next part of the length calculation. So I'm going from a tangent here, left click, to a tangent here. Remember the cyan center lines each time. Can you see it's tangentially adding these as we go round? And then I'm going to come over here, again, just click on this center line here to this center line about here. And can you see it's calculated all of those using tangential object snaps without me even having to worry about the tangents. The length calculation puts the tangents where you need them to be. Press enter to finish. And it will now say select existing polyline. Now the polyline is there. You'll notice it's created a polyline with the arcs and the lines using those tangents. So I click on that existing polyline. And you'll notice now, can you see that down on the command line? Number of links in chain, length, etc. Now I can expand the command line, and there's all the information there. It calculates the number of chain links based on the ISO 606 standard. There's the number of links, there's the distance to the next link, and there's the length of the chain. All neatly calculated for me. I'll click on the arrow to lose the command line expansion there, like so. Now, we need to add the chain to the drawing now. So we go back up to the calculation panel, click on the flyout, and we're going to select chain belt links. It opens up the content again. So we're using the library again. Belt and chain, we're using chains, obviously, and we're selecting the polyline again that's had the length calculated. And we now need to select a starting point on the polyline. Just drag the crosshair up to this line here. Can you see there? Can you see the endpoint snap up towards the sprocket, the little green square? That's where your chain will be starting. That's a perfect start point. Left click. Now it will take you to the size selection. We calculated the length using the ISO 60605B1. And the reason I picked the one at the top of the list is it's easy to find in the library like that. So we select that one, click on next. Now it'll ask for the number of links to draw following that red polyline. A good number there, there's quite a few links in there. Well, I'm going to go with 10. That's a good number normally. And then I'll click on finish. And you can see now I can specify the direction I want the links to go. Do I want them following that blue arrow, or do I want them flipping and going the other way? I'm going to accept the direction, following the blue arrow sort of downwards to the left. And then I want the orientation of the links. The links at the moment are in sort of a side view. Can you see that? I can flip that and have that in plan view, perhaps, depending on what I'm designing in my mechanical drawing. I'm just going to accept the orientation. And you'll see there, it's popped those 10 links in. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's the start point of the chain there where it connects to the other end. It's also created a hide situation as well. Now that hide situation is great because that's added to my mechanical browser and I can go back to that and edit that as necessary. I'll just click on OK there, like so. But as you can see, that hide situation is great for the mechanical browser if I need it. But I've now calculated the length of a chain going around the gear wheels and the sprocket. And I've also calculated which chain, number of links and everything else. It does it all for you. It's a fantastic productivity tool. Imagine trying to calculate that manually in your regular AutoCAD. We're going to take a look at placing a shaft in an assembly drawing. And we've got a new drawing for you. It's called shaft001_assembly.dwg. As usual, download it from the library to follow along with the video. You will recognize it from previous videos. It's that drawing with the clevis pin. You can see the clevis pin notation there. Now we're going to zoom in on the top right view with all the hatching there. That's the sectional view. Zoom in so that you can see this area here where all the spaces are there. We're going to place a shaft going through there. So make sure you can see that part of the drawing and just kind of go over here to the right a little bit using pan. Go to the Content tab on the ribbon and we're going to go to the Shaft panel and select Shaft Generator. Now, as soon as you do that, it asks for the starting point or select the center line of the shaft and where you're going to place it. Now, our starting point needs to be a midpoint snap, so just do a quick sanity check. Object snaps down here. Make sure you click on the arrow. Make sure that midpoint is on. You will find it's not on based on those preset power snaps. Remember we talked about those earlier? So just make sure that midpoint is on and then click on the little arrow there to close the menu. And the midpoint you want is this midpoint here. See that midpoint there? Click. And then you're just going to drag all the way through to the right. See the line there? Keeping the ortho going at 0 degrees. Click again. And there's our center line for our shaft. Now the shaft generator will appear on the screen. And we're going to work through generating our shaft as it goes through this area here. So we're going to use this one here, cylinder. See it says cylinder when you hover over it, click on it. And it's now asking for the length and the diameter. So the length is going to be 5. Just type in 5 and press enter. And then the diameter is going to be 35. Type that in again and just press enter. And you'll see that we've added, can you see that part of the shaft in there? Now, that's the first part of the shaft. We're going to select cylinder again, like so. And this time it's asking for a length. And also we need to specify where it's going to go. Now, I'm just going to snap to this point here, like so. If I click there, like that, can you see it's asking me for a diameter now? So it knows where it's going to go, but it just needs a diameter. So my diameter this time will be 20. And I press enter and it places the diameter going through there like so. So now in this little area here, I'm going to apply what is called a wrench. Now we're going to use a specific standard for that. But if you look through all of these, if you hover over each one, it tells you what they do. You see that? You've got a slope, you've got a wrench, you've got things like a thread. Now there's wrench there. We need a wrench. So I click on wrench. And it now takes me to the content library to find the right type of wrench opening that I need. Now, I'm going to scroll down and I need the DIN 475. So there you go, DIN 475, and I need the four-sided one, the square one. So as you can see, it's a square in shape. Click on it like so. Now, I need to set the specific standard here. There's lots of different sizes with millimeters and lengths, etc. Now, I'm going to go up a bit because I need the SW 18.1. So if I keep clicking, there's the 18.1 there like that. And it's got a millimeter of 18 as well. Now, that's the one I want to use. I need the length of it as well. Now, the length of it is going to be 10 in this case. Now, I know all of these dimensions because I've obviously created this drawing for training purposes. But you might be working in a specific environment. You might need to look up these length values. Now I'm going to click on OK there, and you can see there's the wrench with that green X showing that it's a wrench part of the shaft. Now we've got to a point now where we need to have a thread coming out here, so the thread can be attached to something else in the mechanical assembly. So this time I'm going to add a thread, which is just there. There's the thread option. Click on thread, and again it takes me to all the different types of threads in the content library. This is great, isn't it? It's all parametrically designed. I don't have to go and look in any sort of books or anything for this. It's all stored in the content libraries in your Autodesk Mechanical Toolset. It's great, isn't it? So what I'm going to come down here is I'm just going to come down and keep looking. And what I'm looking for is an ISO 261. I'm working in millimeters, so I need an ISO thread. There we go. ISO 261 external threads. I select it. Now, again, lots of different ones to choose from in the content library. The one I'm looking for is an M16. So I keep clicking here on the down arrow. You can see it's all different sizes, lots of different M values. Keep coming down, keep clicking, and just keep scrolling. You might want to use the slider bar a little bit, and then just perhaps come down a bit more. And there's my M16 with a diameter of 16 millimeters with a pitch of 2 millimeters. Now, again, I want to make sure that certain settings are on here. I I want the length to be 22. Trust me, I know that because of this drawing. And I want the undercut ticked like that. I'm going to change the G2 value there to 6 as well. And all these values are just little sort of parts of this particular thread. So see, look, there's the G2 value in the little preview. And L is the length going that way, DG, and so on. Can you see they're all shown in the preview there? So once you've got that all in place, I'm going to click on OK. And you can see it adds my thread here at the end of the shaft. Now, I'm just going to stay in the shaft generator, but move it over here a little bit. Now, the reason I'm going to do that is I'm going to click here. I want a side view of my shaft as well. So I click. Now, I've got a choice. I want a side view from the right or the left. I'm going to do it from the right-hand side. So I'm going to be looking from here, from the threaded end, this way. So I click right. See the little red dot appears with the one that I've selected. I click on OK. And then, as you can see, I just drag across here to specify the insertion point. Utilize the polar tracking so it all lines up with the center line. I'm going to click like so. And there's my side view, all done. If I click on close now, I've updated that drawing. I've put the shaft through the assembly. And I'm looking now from this side here. And you can see, look, there's the thread. There's the wrench, the square shape. And there's the shaft and the shaft going through like so, with the widest diameter, this circle, being this part of the shaft here. How clever is that? It's saved me a huge amount of time because I don't have to develop the side view myself. I put the shaft through using all of the content libraries, and there's just a simple click to say I want another view of that shaft here. Quick and easy, productive, and saves time. That's what's great about the AutoCAD mechanical toolset. There's often a need to insert springs into your AutoCAD mechanical drawings. Now we can do that very quickly and easily using, again, the Content tab on the ribbon. Now before we do that, we've got a drawing specifically for you to insert a spring into, and it's called shaft001_spring.dwg. It might look familiar to you. It's the drawing we've been using quite regularly throughout this particular chapter. Now, the drawing that you want, like I said, shaft001_spring.dwg. Download it from the library and use it to follow along in the video. Now, we're going to place our spring over here on this top left view. Zoom in over here, and can you see you've got this circle here? Now, you may remember from previous videos, that represents a clevis pin. And that's where our spring is going to come off of, the clevis pin. So you might want to zoom in nice and tight so that you can snap quickly and easily to that circle there, and also this small little circle here as well. So what we're going to do, we're going to set it up so that basically our clevis pin comes here, like so, and our circle is here, and our spring's going to span between the two. So we go to the Content tab on the ribbon, over to the Calculation panel, there's the springs there, click on the down arrow, and we want an extension spring, that one there. Now it opens up, again, the content library. Expand extension springs, and you'll see that there are standard ones. So expand standards, and we want the Gut Kunst catalog, that one there. So we select it, and as usual, we've got a choice of front or front section. We're just going to go with a front view, like so. Now, the starting point is very, very important. Zoom in on your clevis pin, and you want that intersection there, where the outer circle hits the center line. And then we're going to specify the direction by dragging down vertically on our polar tracking line, anywhere on that 270-degree polar tracking line. Just left click. Then you get what is a very complex dialog box. You can see lots of things there. The only thing we're going to change is the length, and we're going to change that to 65, like so. We're then going to click on Next. And then we're going to select the third one down. Now I'm just going to expand this across. You can see there's all different sizes. We want the 14.1 there, and that's the outer diameter, 14.1. Nothing else. We just select that like so. Now we're going to go to Settings, and we're going to draw the form together with the spring. You'll see why we have that form in a moment. I'll click on OK now. And then we click on Finish. Now you can see it's got the topical length of the spring there, like so. Now we want to make sure that this spring goes to the right place. And we're going to come down and you need to zoom in on the smaller circle. And again, it's that top intersection just there. And then it'll ask you, what angle of view do you want for your spring? You've got various options, angle between ends and angle between ends and so on. You want the left-hand one, that one there, which is the default anyway. Click on next. And then you need to select the rod. Now, if you zoom out, we don't actually have any rod between our clevis pin and our circle, but read the prompt. Enter equals continue. Just press enter, and there's your spring going from your clevis pin down to your smaller circle. And if you zoom out now, you've got this form that shows you all the calculations for your spring. So I'm just going to pop that there to the left and left click, and there's our form. If you zoom in on all of this, it tells you everything about the specification, the calculation of that particular spring. So all of that is on your drawing now, explaining exactly how that spring is formed and all the standards that were used to obviously place it in the first place. How cool is that? Saves you so much time, and all your details are just dropped straight into the drawing about that particular spring as well. Again, another productivity gain using the AutoCAD mechanical toolset. We're starting a new chapter, and we're going to start taking a look at how we create mechanical drawing sheets in the AutoCAD mechanical toolset. Now, the first thing we're going to take a look at is we're going to take a look at layouts and viewports and how we create those in our mechanical drawings. So we've got a new drawing for you. It's called views_layouts.dwg, and you can download it from the library as usual to follow along with this particular video. Now, when you open up the drawing, it will be in the Model tab, and you've got a big sectional view here on the left and some detail views over here on the right. Now, we're going to work with some of those views by creating some viewports in one of the Layout tabs, first of all. So you'll notice that we're not doing any work in the Model tab. We're going to go straight to Layout 1. Click on Layout 1, and you can see that we've already got a preset title block in place with a viewport of that larger sectional view on the left-hand side in the Model tab. Now, if I click on the edge of the viewport, like so, you get the usual data coming up. You can see down here in the status bar, it's at a scale of 1 to 5. What I want you to look at is the Layers panel in the Home tab on the ribbon. Can you see it's on a layer, AM_views? Now, that's really important. That layer is your viewports layer in your AutoCAD mechanical toolset. And basically, every time you create a viewport in a layout, the AutoCAD mechanical toolset will put it onto that AM views layer for you. So I'm just going to hit escape a couple of times, and you'll notice because I'm in Layout 1, it's automatically brought up the contextual layout tab here on the ribbon. So when I click on that blue layout tab, there's all the standard AutoCAD tools for working in layouts, as if you were in your regular AutoCAD. I do not want you to use the blue layout tab. I need you to go to the View tab on the ribbon. Now, the reason for that is we have a Viewports panel in the View tab on the ribbon that is specific to the mechanical toolset. And we need to click on Viewport here, like so. As soon as we do that, it prompts me to create my viewport. So I'm going to click on this corner here, left click, and just drag, and I'm going to hover over this endpoint there, use a bit of object snap tracking, just drag it downwards, and we'll get to about there. I might line it in with that one, actually. There we go. Get it exactly lined up, and just try and get it hovering over that endpoint, and just move it along and click there. There we go. Now, you can see there now that it's asking me for a scale. Now, at the moment, I want to change that scale of that viewport. I'm going to change it to 1 to 2.5, like so. Now, it doesn't change the viewport immediately, but what it allows me to do is it allows me to jump back into the model space and specify some settings. So I'm going to click on the midpoint option. Now, that takes me back into the Model tab. Now, the view center is going to be the view on this object here. So if I zoom in, I want the view center to be the midpoint on that blue center line. So object snaps first. Just check that your midpoint snap is on. If it isn't, like me, click on it and make sure you've got the tick next to it. And then just click on the little flyer arrow to close the object snap menu. And then I'm going to go to that midpoint there on the center line and left click. Now it knows the midpoint, it knows the scale. I need it to zoom according to the scale. And I want the view to be active, like so. When I click on OK, watch what happens. Automatically, it's gone and centered that view. And if I click on that viewport, you'll see it's at a scale of 1 to 2.5. How clever is that? It's kind of useful, isn't it? Saves a huge amount of time. One, because the view is centered in the viewport, and two, because I can go and specify what I want in that viewport in the model space using those settings. It's kind of clever. I like that a lot, and it works really well and saves a huge amount of time. Now, what about if we're creating a new viewport on a new sheet, and perhaps we need a specific area from the model tab brought in? Well, I'm going to go to Layout 2. If I click on Layout 2, what you'll see is a blank sheet, okay, with the printer limits there like so. It's just a blank sheet. Don't worry about a title block or anything. What we're going to do here is we're going to create a different type of viewport in this new sheet. Now, imagine you're just starting to create a new detail sheet and you want a detail from the Model tab on this new sheet, which is at the moment Layout 2. Again, we're in the View tab on the ribbon, not the Layout tab. I click on Viewport here in the Viewports panel, like so, and I've got a choice of specifying the first point. Now, if you look down on the command line, there's some options: circle, border, object. If I right click now and select border, it automatically takes me back to the Model tab. Now, I'm going to zoom out, and you'll notice right down here at the bottom, if I just pan up a bit and zoom in, can you see we have a detail with a red border around it? Now that red border is on the AM Views layer that I talked about earlier. So if I pick that border and click, it takes me back to the Layout 2 tab, and there's that border as a viewport in the Layout tab. So I'm going to pop that top left and just left click. And you'll see there the scale, it's already picked it up from this particular viewport. There's the border. I can perform rescaling. I can zoom according to the scale, which is what I want it to do, and I want the view to be active. If I click on OK now, you'll notice that that viewport is now on the AM Views layer. If I go back to the Home tab on the ribbon and just click on the edge of it, it's on the AM Views layer, like so, and it's at a scale of 2 to 1, which is what was preset. Extremely useful. And what it's done is it's used that polyline in the Model tab to create that viewport. If I jump back to the Model tab and just do a little bit of zooming and panning, that is simply a polyline on the AM Views layer. With it selected, I'll right click, I'll go to Properties, bring up the Properties palette there. You can see it's a polyline. It's on the AM Views layer. That's it. It's a regular polyline. Simple rectangular polyline. That's all I've done there. And now when I jump back to Layout 2, that is now a viewport at the appropriate scale, just using that polyline from the Model tab. Now, there's one little thing you do need to be aware of, though. That viewport is in essence on top of the rectangular polyline in the Model tab. So if I click on this viewport and I resize it using a grip, click on that bottom right grip and drag, you'll notice that the polyline is still displayed in the viewport. If I double click inside the viewport to activate it and do a little bit of panning, can you see the viewport still displays the rectangular polyline? I'll double click outside the viewport to deactivate it. So just be aware of that. That viewport, if you resize it, will display the polyline border that you used to create the original viewport. It's one of those things that you've kind of got to get used to with the AutoCAD Mechanical toolset. However, there's nothing to stop me changing the scale of that viewport. I can click on it there, click on the little arrow there. I can change that to say 1 to 2.5. And you can see there, it resizes everything in the viewport there to 1 to 2.5. Just acts like a regular viewport. So if I change that back to the 2 to 1, which is there, brings it back to where it was before. I'll just hit escape now, deselect the viewport. The viewports behave in exactly the same way as a regular AutoCAD viewport. You can also lock the viewports as well. So if I click on that viewport, I can lock it and then it retains that scale like so. And I can unlock it to change the viewport at any time. That's that little padlock down there on the status bar. You can also right click and use display locked as well. So you've got this view lock here, which is on or off. So if I set that to on now, you'll notice that that view is now locked and the padlock is on there. I can unlock the padlock and that turns it off again, or I can right click and turn the view lock off on the shortcut menu if I want to. So I'm just going to hit escape now to deselect that viewport, and you can see now how layouts and viewports can be utilized in the AutoCAD Mechanical Toolset. We're going to be taking a look now at how we can work with scale areas in your AutoCAD Mechanical Toolset. We've got a new drawing for you. It's called sheets_model.dwg. Download it from the library to follow along with the video. Now, when you open up the drawing, it'll be in the Model tab, and we're going to work with some detail views and some scale areas in the Model tab and create different scale areas. Now, again, this is very different to how you might work in your regular AutoCAD, so just be aware of that. So what I'm going to do is we've got our title block here, you'll notice, and you'll see here that we've got a scaled sectional view. Now, that is actually at a scale of 1 to 5, and I'll explain why that works in a moment when we talk about scale areas. We're going to create a detail view first using a specific scale. So I'm going to zoom in on this sectional view, and when you zoom in, you can see you've got a really nice detail sitting there in the middle. Can you see that little detail there? Now what we want to do is we want to blow that up and have a detail view over here on the right in the title block. So I'm going to zoom in on it a bit, get in nice and tight like that so you can see what's going on. Make sure you are in the Home tab on the ribbon and go to the Detail panel, and you want this funny little circular one here with an A on it, Detail View. So when I click on Detail View and come into the drawing area, it's prompting me for the center of a circle. The default for a detail view is a circle. So there's the center of the circle there. It's prompting me for a center. If I right click, I can also select rectangle or just use an object as a detail view as well. I'll just hit escape there once and it takes me back to the center of the circle prompt. Now I'm going to zoom in nice and tight because I want to make sure that I get the right place for the center of the circle. Now I'm going to go down here and use that intersection there. Can you see? And left click. And then my circle appears like so. So if I zoom out slightly, I can then place that circle, freehand by the way, just to make sure it's around the detail. Now, don't worry about the actual radius value. It's a freehand circle that is letting the mechanical toolset know what you want in the circle, basically. The circle won't appear on the drawing. So I'm going to go to about there and left click. Now, as soon as I do that, I'm allowed to create what they call a detail ISO. Now, the ISO is the standard I'm using in this AutoCAD mechanical drawing. ISO stands for International Standards Organization. It basically represents a metric mechanical drawing in my case. I'm working in metric millimeters. Now you can see here that we've got a selected area scale. I'll explain that later, but you'll notice that we can specify by absolute scale or we can specify by factor. Now I'm going to change that to specify by factor. I'm going to change that to 5. Now, you'll notice that some numbers change here. So the area I'm working in at the moment, the scale area, is 1 to 5. If I want this detail to be 1 to 1, I have to make it 5 times bigger. Now, you'll notice the label contents here say A 1 to 1. Now, that 1 to 1 has picked up from here, where I've got the 1 to 5 and I'm timesing it by 5. The A is the identifier. Now, I can obviously change that. I could potentially have a little annotation leader. I'm going to tick annotation leader there, and I can place a little annotation leader off of that circle in my view in a moment. Now, the label contents are fine. It's identifier, it's detail A, and it's at 1 to 1. I'm going to create that detail view in the current space. I can also check my settings if I want to. So if I click on settings, there's all different settings. You can see text style, text color, and so on. It's all by ISO, which is the ISO standard I'm using. So I can change that. I can change the detail boundary, the view label, and so on. I'm not going to change anything. I'm going to click on cancel. Now we can create associative details, but that's grayed out at the moment. I'm not going to worry about associative details. So when I click on OK now, you'll see that there's this massive kind of conglomeration of things. Don't worry about it. That's basically letting you know that where the original one is scaling up. Can you see the green circle and the big circle? The big circle here is that detail view that I'm moving across. So I'm going to place the detail view about there. Use polar tracking if you need to, just to get it to line up, and click. Now you'll notice as soon as you click, you've got the green circle with the little annotation A there. Everything has been scaled up to a 1:1 size, and there's our A identifier and our 1:1. Very quick and easy, and oh my goodness, what a time saver. I don't have to worry about scaling that up, measuring it, does it all for me. If I zoom in on the green circle now, you can see there's a little leader there. So if I click, can you see I've got a little grip there? I can click on that grip, move it around, click there, and the A moves with it. Can you see that? So that allows me just to maneuver where that A detail identifier is, like so. So I'll just hit escape a couple of times, and now it's kind of obvious that that's detail A. And then if I come over here, there's my A. Again, I can move this, click here, click on the grip. I can place that elsewhere. I can perhaps place it there, like that, and hit escape to deselect. So you can see how all of that is easily set up with a detail view like that. Now, let's talk about these scale areas. Now, these scale areas are a little bit weird and wonderful. If I go back to my View tab, you'll notice here I've got scale areas. I can set up a new scale area, or I can monitor the scale areas. We'll monitor the scale areas in a moment, and that will explain the 1:1 and the 1:5 here that I talked about earlier. I'm going to zoom out a bit, and I'm going to zoom in on the shaft here on the right-hand side. And I'm going to create a new scale area. So I click on scale area, and it asks for the first point. Now, normally this can be a rectangle, or you'll notice on the command line there, it can be a circle or an object. If I right click, I can select that circle or object on the shortcut. I'll just hit escape to go back to my first point. I'm going to click here, drag a rectangle around, and there's my scale area. And you can see the scale and type of scaling. I want it to be 2:1. So I want it to be twice its original size in that area. Notice length scaling, text scaling are automatic. I can have an automatic view creation in a layout if I want to. I'm not going to tick that at this point, but I am going to allow rescaling to happen if it needs to happen. So when I click on OK now, there's a scale area in there. I now need to select the objects for rescaling. Now, I'm not going to do this, but those objects there would be the ones that would be rescaled in that scale area. I'm not going to worry about rescaling at the moment, though, so I'm just going to hit escape a couple of times. So that's created a scale area of 2:1. Now, if I zoom out a little bit here and just kind of have all these areas sitting like this, I can now go to the scale monitor. Now, these scale areas, as I move around, will pick up. You'll notice, look, if I hover there, the crosshair, it's at 1:5. So that area where I picked the original detail was 1:5. If I come over to my 1:1, I've got 1:1. If I come over here to the shaft, that's at 2:1. This one over here is at 1:1. This one down here that you'll recognize from the previous video, remember it was 2:1. There's the scale area of 2:1. And then this one down here again is at 1:1. So these scale areas allow me to take information from the model tab into layout tabs if I need to at an appropriate scale. So I'm basically setting everything up in the model tab for the appropriate scale, and then I can set up those views from the scale areas in the model space, but I'm just placing them in the layout space. It's very, very clever. The scale monitor is great because you can monitor any scale area and just check what scale it's at. And you just click on the little cross to close the scale monitor when you're done with it. So that's how quick and easy it is to work with these scale areas in your AutoCAD mechanical toolset. Saves you a huge amount of time, especially when you're creating things like details, like we did from the detail A to the A 1:1 detail in the drawing. Those scale areas are incredibly useful, and also just general scale areas like the rectangular one here around the shaft. They can then be dropped into a layout tab, into a new title block if you need to. In this video, we're going to be taking a look at how we can utilize annotation views in our layout tabs from the mechanical structure in the mechanical browser. Now, that does sound kind of complicated, doesn't it? It's not. Don't worry about it. I'll take you through it in this particular video. Now, we've got some drawings that you need to download for this particular video. You'll notice the drawing we're in is the annotation_views.dwg file. And you can see there that there's various views in the model tab. Now, that annotation views.dwg file uses some external reference files, some XREFs, and you need to make sure that you download those from the library as well and put them in the same folder as the annotation views.dwg file. If I jump to the Insert tab here on the ribbon like so, and go to my Reference panel and click on that little arrow there, that'll open up my External References palette. So there's our current host drawing, annotation_views, and you'll see we've got 3 external reference files attached to that particular host drawing. We've got crossbrace D, roller, and side rail D. They all need to be loaded as XREFs into the annotation_views.dwg file. So, simple way of fixing all of this, just make sure that you download these 4 drawings: annotation views, crossbrace D, roller, and side rail D. They are all available in the library. Download all 4 and put them in the same folder. That way, when you open up the annotation views.dwg host drawing, it will find the other 3 reference files. Otherwise, you're going to start getting loads of dialog boxes saying, oh, where's the XREF? Where's the XREF? If you're all in the same folder, you'll be fine. So I'm going to close the external references palette. We don't need that anymore. Just make sure you've got all those 4 drawings stored in the same location. And then when you open up the annotation views.dwg file, you won't be asked for any additional external reference files. So that's all good. We're ready to go. Now we need to utilize the structure workspace to work with the mechanical browser. So we come down here to the status bar, click on the cog there for workspace switching, click on the arrow, and we want to select structure, like so. Now you can see there the structure catalog kicks in. We don't need that, so we can just close that. And you can see there's our roller conveyor 1500 in our annotation views drawing. Now that roller conveyor 1500, we're going to set up the annotation views in one of the layouts. Now the lovely thing when you're working in the structure workspace is if I go to the drawing tab in the mechanical browser, there's my layouts. There's a layout 1 and a layout 2. If I double click on layout 2, it says simple end view in the title block. If I double click on layout 1, it says roller conveyor 1500. Make sure that layout 1 is active with the roller conveyor 1500 title block. It's just like any layout in regular AutoCAD. You can zoom, you can pan, etc. I'm just sizing that so it sits nicely in the middle of the screen. Now we're going to utilize the mechanical structure in the mechanical browser that we had in the model tab that had that roller conveyor. Now, because we're in the structure workspace, we've got our structure tab up here on the ribbon. Click on the structure tab and you'll notice we have a build panel. I'm going to build up my annotation views from this build panel. I'm going to click on new and I get this great big dialog box pop up. And it's asking me to set up a new annotation view known as an AV. You can see the view name. Can you see AV1, annotation view 1? Now we need to make sure that we select the appropriate part of the mechanical structure in the mechanical browser. So I'm going to click on the down arrow here and you'll see roller conveyor 1500. That's the one we need. So the annotation view name is roller conveyor 1500 AV1. We're going to place that in the layout 1. And we're using a paper size of A3. This is an A3 title block, and the view scale, based on the size of the elements in the model tab, is 1:15. So it's calculated that for me. I don't even need to think about it. I don't need to go to base point or pick point. Leave that all at 0, 0, 0. And I'm not going to create any labels for all the subviews either. I'm just going to click on OK, and you'll see there's my top view. So that's my top view using the top view from the mechanical structure in the mechanical browser. I'll pop that about there. And the rotation angle, I can rotate it if I want to. Just press enter to accept the 0. There's the next view. There's the side view there. Bring that down a little bit to say there. Click there again. You'll see I can specify a rotation angle. Press enter to accept the 0. And then there's the last view from the mechanical structure in the mechanical browser. So I'll click there, like so, and again just accept a rotation angle of 0 by pressing enter, and then it starts all over again. So I'm done now, so I can just right click and I can say that I'm done. Click on done there, like so. So there's my views, like so. So those views have been added. Now, if I expand out in the layout one now here, you can see I've got a top view, it highlights it, I've got a side view, and I've got an in, out, end view as well, like so. So that's the end view of the conveyor. Now, I can start adding some annotation to these. So if I select the top view and I right click, can you see there, I've got select in layout, property overrides, right at the bottom there, create label. As soon as I do that, ignore the gobbledygook. I'll explain that in a moment. I'm just going to click on OK, and you'll kind of see, where did that label go? It's there. Can you see? It always places it above based on the settings. So if you click on that label there, you can see you've got two grips like so. That grip is where it's associated with the view. The top grip, click on it and drag. And I can just move that label and I'll pop it about there. So there's my roller conveyor 1500 using the top from the actual mechanical structure, and the scale is 1 to 15 in brackets. Hit escape to deselect. Let's do the same. Let's go to the side view, click on it here in the mechanical browser, and it's a right click, create label. Just click on OK. There's the label there. Click on it, click on the grip, and we'll move that one over here to the right as well. Hit escape to deselect. And last but not least, the in, out, end view is there. Right click, create label, and again, just OK it. Click on the label, click on the grip, and we'll pop that out to the right as well. And just hit escape to deselect. So there's my 3 little labels that I've created. So I've created 3 annotation views, and the annotation is this bit, the annotation view part of the view. Now, here's the weird thing. If I double click on this label, you'll see all the gobbledygook that I talked about earlier. Now, if you just use your arrow keys, click in that space and go all the way to the left-hand end, you'll see there's an equals, and then you've got these funny little brackets. Now, those funny little brackets are pulling the structure and the component name, the view name, and then there's a little bit of text that says view, and then we've also got, you'll notice, the structural SV scale. That's that scale that it calculated, the 1 to 15, and you can see it's in brackets like so. Now, if I go to settings in this dialog, you'll see there you go, there's the label, and it positioned it above. There's the text style, there's the height, etc., color, etc. So that's all in place based on my little standard that I've got set up in my AutoCAD mechanical drawing. I'm not going to make any changes. I'm going to click on cancel there, but I can edit this, but I can't do what is called a text edit, for example. So I can't just put text in there. If I do that, it will start bringing up all these weird things in all the brackets. So here's what I'm going to do. I'm going to show you a neat little trick. I'm just going to click in here like so. And can you see where it says structural SV scale? I'm going to delete that bit like so and just leave the brackets behind. So we've got view and then brackets. If I OK that now, can you see it's left the brackets behind? It's taken that scale out. If I double click on that label again and click inside the brackets and then click on this little button here, I can then add that scale back in. There you go, structural SV scale. Click on OK, and you can see it puts the 1 to 15 back in. So you have to use those actual physical attributes. They're a bit like block attributes where you assign them to a view. And that's how these annotation views are created. It's kind of clever, isn't it? It saves you a lot of time. As long as you've got everything set up here in your mechanical browser in the structure, it'll pick that information. So it's very easy. There's the name of the component in the mechanical structure. There's the view, top, and then you've got a bit of text that says view, and then the 1 to 15 is the scale that it calculates for the annotation view based on the sheet size you've selected. So all of that hard work that you would normally do in regular AutoCAD when you're creating views with scales, the annotation for those views is quickly calculated in your AutoCAD mechanical toolset. We're going to take a look now at how we can utilize all of the preset title blocks in the AutoCAD mechanical toolset. Now, these title blocks give you nice borders in your layout tabs, and they also give you a title block where you can put information in the title block so that you can communicate your design intent with your mechanical drawings. Now, one thing you can do with AutoCAD Mechanical is you can preset all of the standards that you're using. You can also preset all of the title blocks, and they can be preloaded into your projects as you work with the AutoCAD Mechanical toolset. Now, I'm not going to go into that. There's a lot of deep and meaningful stuff going on when I talk about that. Just bear in mind that this is all preset using the default settings in my version of the AutoCAD Mechanical Toolset. I'm working to ISO standards that are metric and in millimeters. Your standards may differ to what we have in the video. Talking of videos, we've got a drawing for you to download from the library. It's titleblocks_borders.dwg. Download it from the library to follow along with the video. Now, you'll notice that we've got Layout 2 current at the moment. Now, you'll notice if I click on the Layout tab here, you'll see that we've got all the different regular type layout stuff going on. Now, you get all of that in your regular AutoCAD. Now, I'm not going to use that. I'm going to use a different tab. So if I go to the View tab, you'll see I've got different settings there. If I go to the Home tab, I've got different settings there. If I go to Insert here, I've got different settings as well. And if I go to Annotate, you'll notice I've got some sheet settings. So while you're searching for where to put this sheet into your mechanical drawing, you now know that you need to look in the Annotate tab. That's where it is. You're adding, in essence, annotation, the title border thing. You can also add things like parts lists, whole charts, etc. It's all over here on the sheet panel. So we want title border. So you may click on a few tabs like I did. It's like, where is it? Where is it? It's on the Annotate tab, not where you'd usually expect to find it. Click on title border. Now, the good thing is, based on the settings that I've got preset in my AutoCAD Mechanical Toolset, it opens up the drawing borders with title block dialog box. Now, I'm using an A3 sheet size, which is 297 by 420 millimeters. I can define a different sheet size if I want to. They're all in there in the list. They're all preset and in my AutoCAD Mechanical Toolset. Title blocks, I've got some title blocks preset. I'm going to use the Company XYZ title block 1. Now, that particular one is, again, preset in my AutoCAD Mechanical Toolset. I'm going to leave the scale at 1:1. I'm going to switch off all the options in this case like that. Now, all of these options are different options that you can utilize when you're bringing in the drawing borders with an associated title block. I'm going to leave all of them off for the moment. It's just easier. And I can also import a drawing border with a title block from another drawing if I wanted to. I'm now going to click on OK, and it'll put it into Layout 2. Now, you might recognize this dialog box. Oh, look, we're in the Page Setup Manager. So all of those preset settings set up a page setup in your AutoCAD Mechanical Drawing. So it's putting it into Layout 2. And all I've got to do now is literally make sure that I'm using Layout 2. So it corresponds down here with Layout 2 on the tabs. Click on Close, and there's my title block coming in like so. Now, it's saying specify insertion point. Literally 0, 0 to go to the bottom left corner of what they call the printer limits, those dashed lines on the sheet. Press enter and you'll see that the corner of the title block lines in with the corner of those printer limits. Don't worry if it looks a bit off kilter at the moment. We will sort that out in a second. As soon as you do that, it then prompts you for all the attributes that are going to go into your title block. So this is very much like regular AutoCAD using a title block that is an AutoCAD block with block attributes. It's working to a very, very similar setup in the background. The background processing is kind of similar. There's the drawing file name, title block borders. You can see that at the top there. Scale 1:1. Drawn by date, that's today's date. It's in English format, 3rd of August, 2022, not American format where the day and the month are in a slightly different order. Now, it's drawn by, that's my login on this particular machine I'm using. So obviously I'll change that. It's going to be me, SCB, that's my initials. And the sheet size is ISO A3. If I click on Next, I can also have checked by, sheet number, revision, etc. I'll click on OK. That all updates in the title block. So you'll notice now, there you go, SCB, there's the date. Now there is some gobbledygook down there. Let's just zoom in. As you can see, that is a rather long file path that is condensed into that tiny little space. That's because my file path for this particular drawing is quite long. So if I zoom out now and just come out a little bit, you can see that it doesn't quite tally up with the sheet. So what I'm going to do, I'm going to do the Page Setup Manager trick that I often teach in the classroom. I'm going to right-click on Layout 2, go to Page Setup Manager, And we've just set up a page setup for layout 2. So select layout 2 in the page setup manager and go to modify. Now this will take you into your page setup dialog box. And there's a little trick if you ever get this happening to you where the sheet and the title block don't tally up. If I go here, what to plot, and set it to extents, basically the extents of the title block and the extents of the sheet can then be centered by using center the plot. If I click on OK now, can you see that all tallies up? And I'll just close the page setup manager. Now you'll notice that my printer limits aren't quite right. Anything outside of those printer limits won't plot. But what I can do there is I can go back to the page setup manager and do another modify again. And I can change the paper size. So if I went for an ISO A3, I've got an expand or a full bleed. So if I go full bleed, let's say 420 by 297, and then OK that, watch what happens to those printer limits. They disappear. They've gone right to the edge of the sheet. So if I click on close now, I don't have to worry about anything being truncated or not printing. Now, normally, nowadays, you would plot to something like a PDF, not to paper. Now, if I'm plotting to PDF, I would normally use a full bleed sheet size where the printer limits go right to the edge because it's an electronic file format. I'm not printing it to paper. If I was printing to paper, I might right click on layout 2 and go to page setup manager again and modify the layout 2. I might use what is called an ISO A3 expand, this one here. And when I click on OK there, you'll see if I close that, can you see the printer limits just come out a little bit there? So again, I'm going to lose those numbers above. So it does depend on the setup of the title block and the layout of the title block on the sheet. Just be aware of that. So I'm going to go back to layout 2 now and go back to page setup manager. I'll just modify that again and go back to my full bleed A3 420 by 297. And then when I OK that, those printer limits disappear because I could potentially be just plotting this to PDF, for example. So when I zoom out now, I've got a nice title block. It's all set up. I'll just double click on the wheel there to zoom extent. Everything's set up and ready to go. So that's all set up. And if I hover over this and double click on the edge, I can change the sheet size, title block, etc. If I double click here, I can change the title block details as well. I'll just cancel that. If I go back to layout 1, we've got another nice preset title block that's inside the printer limits, I hasten to add. And again, I can hover over the title block, I can double click, and you can see I can change the settings, and I can also double click here on the title block details and update that. So I might change that to say SCB, my initials, and I might change the date there to something like 03/08/22, which is today's date. Click on OK. And you can see that all updates in the title block like so. So that's using your title blocks and your borders in your AutoCAD Mechanical toolset. Again, you can see the productivity tools there. It's a lot quicker, easier, and a lot more intuitive than your regular AutoCAD. You can set up your regular AutoCAD to do this, but in the AutoCAD Mechanical toolset, it's all there preset for you to use. You don't have to set any of this up. It's all based around your standards and the title blocks that are already set up in your AutoCAD Mechanical toolset. Sometimes you'll need to add revision clouds to your mechanical sheets in your mechanical drawings. One of the nice things across all of the AutoCADs, regular AutoCAD and the toolsets, is the updated revision cloud command. Now, the good thing about this is it allows you to accurately place the revision clouds a little bit more, and it also allows you to work with the arc length of your revision clouds as well. We've got a new drawing for you. It's called pump001_subassembly.dwg. You may recognize it from previous videos, but make sure you download this one for this particular chapter. And you'll see that we are using the Rev Clouds layer there. So in the Layers panel, on the Home tab on the ribbon, Rev Clouds. Make sure you're using that Rev Clouds layer. Now, you could use a different layer. You could use an AutoCAD Mechanical layer if you wanted to for your Rev Clouds. I'm just using a separate layer for my Rev Clouds. Always put your Rev Clouds on a separate layer so that you can freeze them, turn them off, etc. Now, you can see in the drawing here in the Model tab, we've got a balloon going down here, number 8, to the end of this particular part of this shaft here. So I'm going to zoom in. get in a little bit closer so that we can see what we're doing. And I'm going to place a rev cloud around that end of the shaft there. Now, the rev cloud command is on the draw panel in AutoCAD Mechanical. It's also on the draw panel in all other flavors of AutoCAD and the regular AutoCAD. So home tab on the ribbon, click on the flyout there for the draw panel and just pin it open, and you can see the rev cloud icon there. Now, it's been updated in the last few versions of AutoCAD. So if you click on the flyout there, you've got different types of rev cloud. You've got rectangular, polygonal, and freehand. Just for speed, I'm going to use the rectangular revision cloud, and it creates it as if you're drawing a rectangle, corner to corner. So it's prompting me now for a corner point of my rectangular revision cloud. Now, the way that it works now in the newer versions of AutoCAD is I can right-click and I can select arc length. Notice I can also change different parts of my rev cloud on the shortcut menu. I'm going to click on arc length. And you can see there it's prompting me for an arc that is 5 units, in my case 5 millimeters long. Now I'm going to change that length of arc to 25 and press enter. Then it'll ask for the corner point. I'm going to click up here, left click for the top left corner of my rectangular revision cloud, and drag it down here to the bottom right corner. So if I click about there, you can see it's added what looks like what's meant to be a rectangular revision cloud. Now, the reason it doesn't look very rectangular is my arc length was way too long. You can see there, look, the arc lengths are really long, and it doesn't really look rectangular, and the annotation just looks a bit unwieldy there for my mechanical drawing. So what we're going to do, we're going to change that. So I'm now going to click on the cloud and just delete it. So it's a right click and erase, like so. So that was a rectangular, allegedly, revision cloud. Let's go back and change that. Let's go back now to the flyout and select rectangular again. I'm going to right click and go back to arc length. Let's be sensible this time and go with an arc length of 5. So that's basically much, much smaller than that 25 we originally put in. I now press enter, like so, and we'll do the corner point up here, left click, and can you see it's calculating those arc lengths much better this time because the arc length is a lot shorter. It's only 5 instead of 25. So when I click there like that, you can see that now looks much better. If I zoom out, that looks like a much better revision cloud. It actually looks rectangular, which helps. Now, your revision clouds are just like anything else in AutoCAD or AutoCAD Mechanical. You can click on it. You've got the grips. So I can click on a grip, make it bigger, make it smaller, etc. Stretch the vertex like that. I'll just hit escape there just to deselect it. Bear in mind, you've also got those midpoint grips now as well. So if I click there, I can expand it up that way, upwards, downwards, etc. So if I wanted to get that in a little bit closer to the shaft, I could bring it down to there. But you'll notice it's automatically calculating those arc lengths for me. I'll just hit escape to deselect. And as you can see, I can do the same at the bottom. Click on the midpoint one there, bring that up a little bit more, and hit escape again. And you can see that you can really be accurate with those revision clouds now. So you've got rectangular, polygonal, or freehand, and that arc length works across all of them. And you can specify your rev clouds quickly and easily from the draw panel on the home tab on the ribbon. In this new chapter, we're going to start taking a look at annotation and dimensioning. And we're going to look at how that works in the AutoCAD Mechanical toolset because it does differ quite dramatically from your regular AutoCAD. We're going to take a look at some annotation first, and we're going to look at how we can add some symbols to our mechanical drawings. Now, these symbols are not available in your regular AutoCAD, and I just want to show you some annotation tools that are really quite unique to the AutoCAD Mechanical toolset. So we've got a drawing for you. It's called annotation_symbols.dwg. Download it from the library to follow along with the video. Once you've got the drawing open, pop over to your View tab on the ribbon, and make sure in the Palettes panel that you click on your mechanical browser, like so. Now, the reason I've got you opening your mechanical browser is because we can go to the Drawing tab and we can work with our Layout tabs. Now, our Layout tabs are down here in the bottom right corner this time. Don't worry about that. That's no problem at all. We're not going to use the tabs. We're going to use our layouts here in the Drawing tab in the mechanical browser. I can just double click on each one and it will change accordingly. Make sure that you double click on block. That's the one that we're going to be using for this particular video. Now, once you're in the layout, you can see there that we've got a plan view that's dimensioned up with tolerances. We've also got a list of coordinates here for various things, and we've got a little view down here showing some hidden detail. We're going to zoom in on this little area here near the title block, and you'll see that there's a 150 dimension with a 0.4 tolerance. We want to be near that. Now, I'm going to go to the Annotate tab now on the ribbon, and we're going to be utilizing the symbol panel. I want to show you some annotation symbols that are quite useful and quite unique to the mechanical toolset. First one of these is up here on the symbol panel. It's this one here with the A on it. Looks a bit like sort of a TV screen on a stand with an A. Click on it, and it's a datum identifier. Now, we're going to select the object to attach it to. That's going to be this edge here on the 150 dimension. See it highlight? When it does, just left click. Then it'll ask for a start point coming off of the dimension itself. I'm going to go to that little end point. If you zoom in real close, you want the end point of the extension line. Just there, left click. And then as I come down, can you see the datum identifier appears like so? I'm going to do a little bit of zooming and panning. I'm just going to drag that down and move to the right like that. So that's my vertical positioning. I then left click, drag horizontally for the horizontal positioning, and then left click again. That'll allow me to add the datum identifier in the symbol tab. You'll see it's using specific standards that are preset in my AutoCAD mechanical toolset. And I can change that. It's an A. A is fine. It could be a 1, a 2, a 3, an A, a B, a C, etc. I can also change the settings to use different arrowheads, text, etc. I'm not going to make any changes. I'm just going to click on cancel there. And if I now click on OK, you'll see that that becomes an A in the datum identifier. Note as well, I can change the leader and the text though, just before I click on OK. I just wanted to make sure that you were aware of what that leader and text tab does as well. So there's more editing tools there as well. I'll click on OK, and there's my little datum identifier. So basically what you're saying there is A is the datum identifier for this corner where this dimension's coming off that view. Now, another one that is fairly unique to the AutoCAD mechanical toolset is this one up here on the symbol panel. If I hover over it, it's called a feature control frame. And you can add all different symbols to this, things like tolerances and so on. So if you click on the down arrow, you'll notice there's nothing there. There's no library, there's no recently used, because I haven't added anything to that library or used anything yet. So if I come across back to the icon and click on the icon, as I come into the drawing, it's saying select object to attach to. Now you'll notice there's a hidden detail line there and a hidden detail line there showing a hole through the plate. I'm going to click on the center line of that hole, and then it's asking me for the next point. Can you see that? So what I want to do is I want to make sure that this goes to the right place. Now at the moment, it's not quite in the right place. So what I'm going to do, I'm going to hit escape and jump back to the icon. Again, if it happens, just hit escape to cancel the command. Select the object to attach to. There's the center line, and it's a quick one left click, and then it should ask you for a start point. Now I'm going to come down here and zoom in, and I'm going to go to that little end point on the end of the center line. That's my start point. Now you'll notice as soon as I click on that start point, can you see it's coming straight off the center line and kind of going all over the view there? I don't really want that either. So hit escape again a couple of times. It's one of those little sleight of mouse kind of tricks, this one. So let's do it again. Click on it again, click on the center line, and then as you come down, your start point, you want to come off the center line down here and then do your left click. Now you can take that arrowhead that way. Can you see? And then you can perhaps pick another point, come down again, left click again, and drag a little bit further along. When you get to the point that you want, you just literally press enter, and then it will take you into the feature control frame dialog. Now you'll notice there's nothing in the library right now, but I can put something in like a tolerance, and there's all these different symbols. So I'm just going to do that, and you can see there that I can add information. So there's my symbol there if I want a symbol in there, or I can just put a numerical value in there. It's entirely up to you, but you can see all the different tolerances and things that you can bring in. Again, like the datum identifier, you can alter the leader and the text if you want to. I'm going to go back to the symbol tab. Now this one, once I've put that information in, I can add it to the library, and then it will show up in the flyout menu next time I go in there. Or I can import from different drawings from different libraries as well. I'm just going to leave the 0.1 in there and click on OK. And there's my 0.1 tolerance. Now you'll notice if I go to the flyout, I didn't add it to the library, like so. So there's nothing there. If I'd added it to the library, it would show here, and it would also show in the recently used panel as well. But I didn't do that, so it's still empty right now. But you can see how these annotation symbols, especially on mechanical drawings, can be incredibly useful. So that's a datum identifier and a feature control frame, which you can use for the tolerances on your AutoCAD mechanical drawings. We're going to look now at adding some power dimensions to your AutoCAD mechanical drawings. We've got a new drawing for you. It's called power_dimensions.dwg, surprise, surprise. And you can download that from the library to follow along with this particular video. Now, we're not going to worry about the mechanical browser in this case, so don't worry about having the mechanical browser present. You can see it's a very simple drawing. We've got a gear wheel here from the side, and we've got a part sectional view AA of the gear wheel with section markers here on the side view. We're going to zoom in on the top half of the sectional view so that we can see the increments going in and out, the little cutouts and so on that have been set up for this particular gear wheel. I'm then going to go to the Annotate tab on the ribbon, and we're going to look at power dimensioning. It's all one command. It's a really cool way of dimensioning in your AutoCAD mechanical toolset. It's over here, right on the left-hand end of the ribbon when you're in the Annotate tab. It's in the Dimension panel. Click on Power Dimension and come into the Drawing area. Now, it defaults to a linear dimension, but I can check that. I can right-click and select Linear on the shortcut menu. And I've got a choice. I can select an option. I can go horizontal, vertical, aligned, rotated, or exit power dimension. I'm going to go with horizontal first. So now it's asking me for the first extension line origin. And I'm going to do it very quick and easy. Endpoint snap there, left click, to endpoint snap there, left click. And that will place a linear dimension. You can see that there floating around. Now, when it goes red, that's kind of the ideal location. So if I click on that red bit there, there's my 12, and the power dimensioning tab then kicks in on the ribbon. You can see it's a contextual tab. It's blue. And I can switch things on and off, and I can add symbols and so on. Now, I'm going to add a tolerance to this 12 dimension. You can see the text 12 is ready to be edited. If I click on tolerance there like that, there's the tolerance. And can you see it's picked up 0.2 and minus 0.8. Those were preset in the drawing. So those are my tolerances in this particular power dimension. So what I can do now is I can literally just click away from that, and it places that dimension. I don't need to press enter. I just click away from it in the drawing itself. So that's my first power dimension placed, with all of that tolerancing just dropped in straight away. The dimension style itself is preset in the standards in my AutoCAD mechanical toolset already. So that's why this is all working really seamlessly. So now I'm going to right click again, and you'll notice this time I've got enter, cancel, recent input, dynamic input, and so on. Now, if I want to go back to a different type of extension line origin, what I need to do is just hit escape once, and it asks for another extension line origin, because I'm actually placing a linear dimension that is horizontal. Now, you'll notice that the only way I can do this now is to kind of exit. So I'll right click and I'll exit. And look at that. I'm still in the command, but you thought you were going to come out of the power dimension command. You're not. So I now want a vertical linear dimension. So now I'm going to go here, endpoint snap here to endpoint snap here. And when it goes red there, can you see that little red is just letting you know that that's the ideal location for the dimension. So I left click, and there you go. It's remembered the tolerance up here on the ribbon and the tolerance values, and it's placed them with that linear vertical dimension. Now, again, first extension line origin is being asked for. I'll right click and exit. I'm still in the power dimension command. I can exit again though, and now I can right click and say that I want a radial type of dimension. So you'll notice I haven't come out of that power dimension command at all yet. I'm going to go for a radius this time, like so, and now it prompts me to select an arc or circle. I'm going to jump down here to the smaller shaft part of the gear wheel, click there on that circle, drag the dimension out a little bit and click again like so. And there's my power dimension radius. And again, it's added the tolerances, as you can see there, like so. Now, what I can do now is right click and exit. That takes me back to what type of radial dimension I want. I exit again, and I'm now in the final part of the power dimension tool. So if I now press enter, it will now say, do I want to go back to arc, circle, line, or dimension? Because it's repeating what I did last time. Quickest way to get out, just hit escape a couple of times. Or you could have clicked on the green cross up on the ribbon as well. That would have closed the power dimensioning ribbon as well. Now, the lovely thing is, if I want to edit any of these power dimensions, just hover over them, double click on them, and you'll see that it all kicks in again, and there's the power dimensioning ribbon. Once you've done your edit, you can close the editor there, or like I said, you can hit escape a couple of times. I'll close the editor this time properly. There we go. That's the proper workflow. Click on the green tick, but you can hit escape if you want to. But you can see how quick and easy it is to effectively dimension your drawings with that power dimension tool in your AutoCAD mechanical toolset. In this video, we're going to take a look at how we can place multiple dimensions in your AutoCAD mechanical drawings. Now, again, this differs from the regular AutoCAD. The AutoCAD mechanical toolset has some great dimensioning features, multiple dimension being one of them. Now, when you open up the drawing for this particular video, it's called multiple_dimensions.dwg. And as per the usual drill, you know to download it from the library to follow along with the video. When you open up the drawing, you will be in the model tab. You don't need the mechanical browser either. We're just going to do some simple multiple dimensioning. Now we're going to zoom in on this plan view here, first of all, the top view. And you can see we've already got one dimension. There's a diameter 13 there. And I want to place some dimensions along the top face of this view here, like so. So I'm going to go to the Annotate tab on the ribbon and click on Multiple Dimension there, like so. Now there's lots of different settings I can use here. I've got parallel dimensions, like so. I've got ordinate dimensions, as you can see, different ordinates. I can also have symmetric shaft dimensions about perhaps a shaft in a side view. We're going to use parallel for this particular dimension setup for multiple dimensioning. And the type will be a chain. So you'll notice that things disappear when you place the chain option. We're only going to do it in one axis. So the both axis button here, make sure it's unticked. Everything else you can leave unticked as well. So now I click on OK. And I need to select the objects that I want that chain of dimensions to go across. So I select the outer polyline, left click, and that's on that vertical face there. I'm then going to select this part of the center line here, there. Can you see I'm selecting each object that I want a dimension to go to and from? And make sure you click back here on this vertical line here as well. It may be a polyline, but you need to let AutoCAD Mechanical know which part of the polyline you're working to. I then just press enter, like so, and it asks for the first extension line origin. So I'm going to start top left on the endpoint snap there. Left click when the endpoint snap appears. And now, can you see, as I move up, I can specify where those dimension lines are going to go. I need to go upwards and see the red there. That red is the ideal location for your dimensions. So just left click and there you go. There's your chain of dimensions. Now it's asking for the starting point for the next extension line. We don't need that. We just press enter to finish. So that's how you can place a group of linear dimensions quickly and easily using this multiple dimension tool. Now I'm just going to zoom out slightly. And I'm going to come down here now to this view here, like so, this one here. Let's zoom in a bit, and we're going to do a baseline setup this time. So I'm now going to go to multiple dimension again, like so, and I'm going to go for parallel again, like before, but I'm going to set it up so that it's a baseline setting. Now I've got a choice. It can be inside out or outside in. Watch the preview. Outside in goes a slightly different way. Inside out goes another way. Now you'll notice in this case, the preview hasn't updated. Now the reason for that is because we're only using the one axis. Both axes has been unticked. I'm going to leave that unticked and leave it as inside out. So the first dimension will be inside, and then we're working outwards with our baseline dimensions. So parallel tab, baseline, inside out, both axes unticked. These can be left unticked, by the way. Click on OK, and it prompts you to select the objects you want to add the baseline to. So I'm going to click here on this polyline, like so, and then I'm just going to come to some points that I want to work to. So there's this object here, vertical line there on that polyline, and then I'm going to click on this one here, this angled line, like so. And I'll also go to the end here, to this one here, like that. Now remember, you've got to click on each of those lines, even if they are a polyline. When I press enter to finish, it asks for the first extension line origin. So I click there, like so. It's going to start at that endpoint there. And then as I come out, can you see I get that little red that indicates, oh, there's the best place for your dimensions. Left click, and there you go. There's your baseline chain of dimensions, like so. And I just press enter again to close, and I've placed some baseline dimensions coming off of that side of that view. Now you'll notice the 10 there is kind of over the 25 extension line. Again, you can just click on it, click on the grip, just move that out a little bit, and it tidies it up accordingly. I'll just hit escape now to deselect it, and it's a bit neater. I've just moved the dimension slightly and moved the dimension text a little bit. But that's how multiple dimensioning can save you a huge amount of time when you're working in your AutoCAD mechanical toolset. We're now going to take a look at how we can edit dimensions in the AutoCAD Mechanical toolset. Now there's a whole load of editing tools available in AutoCAD Mechanical, and we're going to look at how we edit the power dimensions that have been placed in a drawing. Talking of drawings, the drawing to follow along with this video is called editing_dimensions.dwg. You can download it from the library to follow along with the video. Open up the drawing and you'll see that you're in the Model tab. We're going to zoom in on the top view with all the dimensions here first. So let's zoom in close and we can see all the dimensions like so. Now all of these dimensions are power dimensions. So the trick is you just click on them once. So I've got a 150 dimension on the end here. If I click on that 150 dimension, because it's a power dimension, the power dimensioning tab appears up here on the ribbon. Now, something that I might want to add is my alternate dimension style. So if I go over here, can you see dim text? There's an alternate dimension style here. Can you see that alternate text? If I click on that, it adds the other alternate text setting to the dimension. And because it's a power dimension, it does it automatically. If I just hit escape now a couple of times, you can see I've got the 150mm dimension, but I've also got the 5.91 inch dimension. Really good if you're working internationally with different international standards of dimensioning, different international units, etc. Very quick and easy. That's why these power dimensions are so useful. I'm going to zoom out slightly now, and I'm going to pan upwards, and I'm going to have a look here at these dimensions here, like so. Now, again, all of these are power dimensions. So we've got various dimensions on this view in the drawing. I'm going to select the 90 dimension there, like so. And again, it's a power dimension, but you'll notice it hasn't got a tolerance applied to it. So if I go up here to the Fit Tolerance panel on the Power Dimensioning tab and just click on Tolerance to switch the tolerance display on, you can see the tolerance is now applied. And you can see it's 0.1 and minus 0.1. Then I've got the method of display here, so I can pick a different display type. If I go for this display type and click on it, keep an eye on the tolerances in the drawing. Can you see they move slightly and kind of move just to that corner away from the 90 dimension? Again, I just hit escape a couple of times, deselects the dimension, the power dimension is deselected, and the power dimensioning tab on the ribbon disappears. Last but not least, I can just click on this dimension here, like so, and again, the power dimensioning tab kicks in. Now you'll notice in this case, there is a fit setting. Can you see it there? Fit. And if I click that and switch it off, can you see the fit disappears on the dimension? If I click on the fit again, it puts that H7 back in, which is a particular fit symbol for that particular power dimension. Now, one of the things that I love is I can go here to edit dim text. If I click on that, it brings up all of the text editing tools that I can use now to edit my dimension text. You'll notice I've got two diameter symbols. I don't need 2 diameter symbols. So what I might do there is get rid of that one at the beginning. If I click there, put the cursor there, you can see it flashing, and then just backspace to get rid of that diameter symbol. So I've edited some of the dimension text there. I'll close the text editor up here, click on the green tick, and that dimension updates accordingly. Now, editing dimensions as well, power dimensions, regular dimensions, you can click on them, and obviously they've got all their respective grips. If I click on that grip there for the dimension text, I'll just click and just move this a little bit so it's a little bit more sensibly placed. Click again and just hit escape a couple of times. You can see that that's much, much easier to see now just by using those grips to reposition that particular power dimension. If I double click on the wheel now to zoom extents, you can see how quick and easy it is to work on your power dimensions in your AutoCAD mechanical toolset. And it allows you to be a lot more productive when you're annotating your mechanical designs. In a mechanical drawing, hole charts and fits lists are very common. And one of the lovely things about the AutoCAD mechanical toolset is we can generate those hole charts and fits lists really quickly and really easily. We've got a new drawing for you. It's holecharts_fitslist.dwg. You can download it from the library to follow along with this particular video. When you open up the drawing, make sure you are in Layout 1. As you can see, we've got a title block there. It says Hole Charts and Fits Lists. And what we're going to do, we're going to drop the hole chart and the fits lists into the Layout 1 tab. Make sure that you go to the Annotate tab on the ribbon, and you'll see there that we've got a plan view showing some holes in a viewport in the layout. Now remember, this red line here is the viewport. It's not part of the object itself. Now this is a top view of a particular component. You can see all these holes here. These are actually holes. They're not just circles with center lines. They're actually holes from the content library. So let's have a look now at generating our hole chart. So on the Annotate tab on the ribbon, we're going to go to the Sheet panel on the right-hand end, and there's Hole Chart just there. So I click on Hole Chart. Now it asks for the insertion point for the origin. Now the origin is going to be, you'll zoom in here, it's going to be that corner there of your little plate with the holes in. There it is there. Click there. Now you've done that, and the rotation angle, just press Enter to accept the 0. Now the name of the origin, I'm going to call it 1 for now, or you could call it maybe O1, origin 1, and Enter. And then we need to select the holes. So there's the 1. You can just see it there. If I zoom out, I now need to select those holes. Now this is the easy bit. I can click here and just drag across like that. And funnily enough, it'll only select the holes. So that window that I've just placed will only select the holes. That's all it's looking for. So the holes are now selected. I just press Enter, and now there's my hole chart. How quick was that? All generated, tabulated, ready to go. I just need to pick a point where it's going to go in the Layout tab. Now you could be really pedantic and place it exactly. I'm just going to left click up there. And there's my list of coordinates for all my holes. Starting at my origin, which you'll notice now is 01 there. And you can see, look, there's all 01.1, 01.3. If I now look on the table, there you go, 01.1, 01.2. So I've got a list there of each hole number and all of its coordinates and settings and everything else. How quick and cool is that? Now, the fits list is even easier. I just go up to the Sheet panel again and click on Fits List, like so. I'm going to update everything because I've just added a new hole chart. So I'll update all first and then go back to Fits List, like so. And then I want New. And there's my little fits list like that. Just going to hover there and click, place it in like so. And you can see there now, if I zoom in, that I've got, if it's a dimension diameter 6, it's an H7 with those tolerances for the fit. So that's my fits list in place as well. I'll just double click on the wheel now to zoom extents, and there's my hole chart and fits list in my drawing in a few minutes. Quick and easy in the AutoCAD mechanical toolset. It's normally the case to add revisions to any type of drawing when changes are made. One of the lovely things in your AutoCAD mechanical toolset is you can add revision lists quickly and easily to your title blocks in your mechanical drawings. We've got a drawing for you. It's revision_lists.dwg, and you can download it from the library to follow along with the video. Make sure you are in the model tab when you're making any revision edits in this particular drawing as you follow along with the video. So you'll notice we've got a nice drawing. It's got some dimension annotation. There's a nice chain in there. And you can see that we've got a nice parts list and a nice title block all set up and ready to go. Let's go to the Annotate tab on the ribbon and then expand the sheet panel here like so, and then click on the pin to expand the panel so that you can see the revision tools here. Now, the first thing that's really important before you start adding any revision lists is you need to make sure that your revisioning system is on. So I'm going to come here and click on Revision On Off. So can you see there on the command line, revisions system is activated. So now when I add a revision, it will update, and I can update the revision lines as I go. So I'm going to click here, add one revision line. Click there like that. Come into the drawing area and it says select drawing border or title block, or I can press return and just put it in global space somewhere. I'm going to select my title block here. I'm going to add it to the title block, click there, and you can see there's the information. So I'm going to put revision number 1, and I'm going to put in the first line there, updated chain supplier. And in revision line 2, I'll put new chain added. Like so. Now the name there, that's the name that I use to log into this particular PC. I'll put my initials there, for example. So let's put SCB there. Now that's all been updated. So when I click on OK, I've now got a revision ready to place. So I'm going to use that bottom left corner, that endpoint snap, and left click. There's my revision. So I've not only got the revision number, I've got the date, I've got the details of the revision, and the name, the person who made that revision. So what I can do there now is if I want to turn that revision system off, I click on off, and now you'll notice down on the command line, the revision system is deactivated. So if anything gets updated, it won't actually update in this revision line here. So make sure your revisions are on, like so. Now, what I can also do is I can double click here on the title block itself. There's my parts list. There's my title block. Double click there. Notice if I go across to next, there's a revision number there. So I'll say that we're at revision number 1, click on OK, and that number 1 goes in there in the rev part of the title block. Now the good thing there is I can tally that up with that. So there's revision number 1, there's revision number 1. So if I make sure that my revisions are updated, that revision there should update as well. So let's have a look at that. Let's add another revision line. So I'll click on add one revision line. And what I'll do, I'll select the title block again here. I want it to apply to the title block. This is revision number 2. And what I'll do now is I'll put something along the lines of revision line 2, just to be really, really imaginative. So revision line 2, like that. Make sure you spell it correctly. Nothing worse than revisions that are misspelt. And again, I'll put my name in there as SCB. I'll pop my initials in there. Click on OK, and it automatically pops that new revision line in there. Now, if I update revision line here, like so, that will update there. It won't update here. You need to update the drawing and update the title block, remember. So you come in here, click on next, update that to number 2, click on OK, and it all updates accordingly. So you can easily jump in and out of these revisions and update them if you need to. Once they're done though, it's always a good idea just to turn that revision off. So you deactivate the revision system, because that way nobody can update these without switching it back on again. It's a bit like locking your revisions. It's quite handy. So that's how you can add your revisions and your revision lists to your AutoCAD mechanical drawings. Again, quick and easy. It's a lot more difficult to do something like this in regular AutoCAD. And that's where the productivity of the AutoCAD mechanical toolset kicks in. It makes you a lot more productive because all these tools are automated, saving you time to concentrate on your mechanical designing instead. In this video, we're going to take a look at utilizing the text layer override. Now, you heard that right. There is a text layer override in the AutoCAD mechanical toolset. We've got a drawing for you to work with. It's pump001 underscore subassembly.dwg. As usual, download it from the library to follow the video. Now, you're in the model tab, and we're going to take a look at our layers. So I'm going to jump back to the Home tab on the ribbon, like so. You'll notice at the moment, our current layer is the good old default layer 0. And I'm going to leave it at that. That's our current drafting layer. Now, if I type dim layer, D-I-M-L-A-Y-E-R, that's the dim layer override for dimension annotation. If I press enter now, you'll see that it's going to use the current layer. So that use current in the little blue box there, if I just pressed enter, it would use the layer 0, the current layer 0, for any dimensions that I place in the drawing. Now, I'm just going to hit escape there. I don't want to use the dim layer override. I want to use the text layer override. So if I now type text layer in the same format, you'll notice there is a text layer command. Text layer, like that, press enter, and it says enter new value for text layer or use the current text layer, if you'll pardon the pun. Now you'll notice in the inverted commas there, it's actually saying, oh, okay, so the current text layer override layer is the text layer. I'll show you that in the layer drop down in a minute. I'm going to type text like so. And as soon as I press enter now, you'll see down there on the command line, new value for text layer is text. So what I've done now is I've told the AutoCAD Mechanical toolset every time I place any text to put it on the text layer. If I go to the layer drop down here, there's the text layer right at the bottom. Now you'll notice it's not the current drafting layer. 0 is the current drafting layer. So if I now go to a text command, will it place the text on the 0 layer, the current drafting layer, or will it place the text on the text layer? Because I've set that text layer override. We're going to zoom in on our parts list where the blue text is in the yellow boxes here. So you can see number 8 drive shaft. Just zoom in so you're just above part number 8. I'm going to go now to the annotation panel here, click on the flyout, and I'm going to go single line text. I'm going to come into the drawing area. I'm going to go for a start point of the text about here. Now the text itself is just justified to the left, the default left justification, as it always is with single line text. So I'm going to pick a point about there and left click. That's where the left point of my text will start. Now I can specify a height of the text. I'm going to go with 5, but I'll type it in again. There's 5 there, and I'll press enter. Then I want the rotation angle to be 0, so I'll just press enter to accept the default 0 value. There's my little flashing cursor. I'm going to put caps lock on and just type parts list, like that. And then I'll press enter once. There's no text on the next line down. Press enter again. That closes the single line text command. Now, what do you notice about that text? It's red. It's not white. If it was on the layer 0, it would be white. If I click on that single line text, you'll notice it is in the layers panel on that text layer. I'll hit escape to deselect it, and that's how quick and easy it is to use that text layer override. It saves you worrying about whether your text is on the right layer or not. You can set that text layer setting, make sure it's set to the appropriate layer that you want the text to go onto, and that's how quick and easy it is to get your text elements onto that text layer override layer, which in this case is the text layer in the drawing. Quick and easy. So again, another little bit of automation in the AutoCAD Mechanical toolset that just speeds up productivity when you're annotating your mechanical drawings. We're starting a new chapter now where we're going to be taking a look at parts lists, bills of materials, and balloons. The first thing we're going to look at in this particular chapter is part references and adding part references to our mechanical drawings in the AutoCAD Mechanical toolset. We've got a drawing for you. It's called part_references.dwg, and you know the drill by now. Download the drawing from the library to follow along with the video. Now, it will open up in the Model tab, so make sure you're in the Model tab and you've zoomed to the visible extents of the drawing, so you can see the title block like so. Now, part references can be applied to your parts in your AutoCAD Mechanical drawings. So if we come down here to the bottom right corner of the title block, you'll see if I just hover over it, there's a parts list there. And you can see there's various elements of the part list: reflective housing, tapping screw, and UV filter. So what I'm going to do is I'm going to add a new part reference to this particular drawing. So I'm going to double click on the wheel to zoom extents again, and we're going to zoom in on the side section view here, like so. Now we're going to be working on a new part reference for this little part here. There's a cover just there. So that little part just there. Now what we're going to do first of all is we're going to go up to our layers panel here and expand it. And you'll notice if I pin it open, there's a little circular icon with a light bulb. If I click there, can you see it switches on my part reference icons? Now those little part reference icons, they look a bit like the node snap, the node object snap. But what they do is they show you where the part references are in your AutoCAD mechanical drawing. It's kind of like an extra layer that you can switch on and off. I'm just going to unpin the layers panel now, and I'll leave those switched on for the moment. Now I'm going to go to the Annotate tab now on the ribbon itself. And you'll see that we've got a Bill of Materials panel right here, BOM. And if I click on the flyout here, I've got Create, Block, Edit. I want to create a new part reference. So I click on Create and come into the drawing area. Now, one of the things I can do here is I can copy an existing part reference. So what I'm going to do, I'm going to right click and I'm going to select Copy. And it will say select the reference to make a copy of. I'm going to go with that one just there. So can you see it highlights? It says it's unnamed. Don't worry about that. Just click on it. So that is now your particular part reference settings. Now we need to select the object that's going to be where our part reference is going to go. So I'm going to zoom in real close and I'm going to select that little line there on the cover. Can you see it highlight? Left click there and then the part reference dialog opens. Now, because we copied the part reference, the description is incorrect. So I'm going to double click in there, delete that, and I'm just going to type cover, C-O-V-E-R. That's it. That's all I'm going to change. Everything else can stay as it is. Now, when I click on OK, what you'll find is I've got a new part reference there. When I zoom out, you'll see now that it's at the bottom of that particular side section view. If I come down to the parts list now, and zoom in and just hover over that to highlight, can you see we've got a number 4, item number 4, quantity 1, and cover, like so. So that is our little part reference all in place there. Quick and easily done. Now I'm going to zoom out again, and what I can do is I can hover over my part reference, like so, highlight it, double click on it, and I can edit it. Now, this is what's really lovely about the AutoCAD Mechanical Toolset. All of this information is editable and it's parametric. All of it is automated for me. So I can double click in there and I might change the name to Vent Cover instead. When I click on OK, that updates the part reference. If I zoom out a bit, pan across, look now at my little bill of materials there. There you go. It's now a vent cover instead. So when I update the part reference, you'll see the bill of materials, the table in the drawing updates accordingly. Now, the other thing I can do is because these all relate to those part references, I can add balloons to my part references as well. And that's really useful because what I can do now is pick on these part references with the balloon tool here in the balloon panel, and I can add balloons that will actually show me the part reference numbers. Incredibly useful when you want to link it to your parts list in the bottom right hand corner of your drawing. So I go to the balloon panel here, click on balloons. The balloon style is already preset in this drawing, by the way. So now what I can do, I can click on that part reference. See the little blue circle? Click on it, and there's my little balloon. I'm going to just bring that one out horizontally to there, left click, and can you see there, that's a little bit off. So what I might do there is just hit escape a moment and just come out of that. Something that's really useful is polar tracking. Notice polar tracking is on. When I click on balloons though, you'll notice that polar tracking turns off automatically. So just switch it back on again and then click on your part reference. And now you get that nice horizontal line. Can you see that? Click there, it's horizontal, enter to finish, and that is obviously part reference number 2. I'll select this part reference here. Again, just come out horizontally, left click, enter to finish. That's part reference number 3. I'll click on this one here, click there. I might come out here, click once and then come up a little bit, click again, press enter to finish. It's part number 1. And there's our new one. I'll click on that one, hover over it and click on it. Bring the balloon out a little bit. I'll just come out this way, click there, come down this time, click there, press enter to finish. That's part number 4. Once I'm done, press enter to confirm. And as you can see, all of our little balloons are linked to our part references. Now, one more little bit of housekeeping. Jump back to your home tab on the ribbon, expand your layers panel, and just click on this little icon here, where you can turn the part reference layer on or off. Then those little kind of node type snaps, the blue things, disappear. Now you'll notice when they disappear, can you see it's kind of left a little gap there for each one? But at least you can see what's going on. But our number 4 doesn't quite tally up. So if I select it, it's all one object. And what I can do is I can just right click, and you'll see I'll just use the regular move. And what I can do is I can just use the move here. Don't use any of the move, copy and rotate, just move. And I can go there and I can just click on this and just move it up, click there, and now it's pointing at the cover instead. I could do that with the other 3 if I wanted to as well, just move them around using the move command. But bear in mind, they are all one object. Now, if I zoom in real close, you can see that arrowhead is just slightly off. I can click on the grip, click there, and can you see I'm moving it to the intersection with the line? Hit escape. It's even neater still if I want to be that pedantic with my accuracy for my balloons. So click on each one, click on the end grip, get the arrow pointing to where you want it to go. But you'll notice all of those little reference balloons relate to your references here in your parts list, your bill of materials that you created when you created those part references. Very clever stuff. Again, automated, saves a huge amount of time. Double click on the wheel to zoom extent, and you can see the overall effect there of your balloons that have been created from the part references that you've got in your mechanical drawing. We're going to take a look now at how we add a bill of materials, a BOM, for our parts and our part references in our mechanical drawings. Now, in the AutoCAD Mechanical Toolset, you can have all those part references. You remember those in the previous video where we added the little part references and the balloons to point to those parts. You can also generate a bill of materials and generate those balloons from the bill of materials as well, and add the bill of materials to your drawing too. It's really quick and easy to do. Now, we've got a drawing for you. It's called bill of materials _ parts.dwg. You can download it as usual to follow along with the video. Once you've opened up the drawing, make sure you're in the Model tab. No mechanical browser needed for this particular exercise. And I'm going to go to the Annotate tab on the ribbon. Now, again, we're over here. You've got BOM, Bill of Materials, and you can see there's a BOM option there. So if I click on BOM like that and come into the drawing area, it says specify the bill of materials to create or set current. Now, at the moment, if you look at the command line down at the bottom of the screen, you can see there is a default main, M-A-I-N, bill of materials. Just press enter to accept that, and that will open up the BOM dialog box. Now, there's a lot of information in here. You'll notice, look, move the slider bar along. You've got things like material, measurement units, description, etc. So there's a lot of information going on. Now, this is listing all of your parts, your part references that you have assigned in your mechanical drawing, and it's put them into a bill of materials, a bit like a spreadsheet. Now, I want this particular bill of materials in my drawing. I don't just want it sitting in the dialog box. So if I look at all this plethora of icons along here, there's all different ones. Go to the end and you'll see there's a parts list. Now, that parts list is a table that you can then drop into your AutoCAD mechanical drawing. So if I click on parts list, can you see it opens up the parts list dialog box? Now, there's lots of different tools here. Can you see parts list name? It's just called parts list. If I want that in caps, I might put parts list like that, so it's all in capitals. You can insert headers, you can insert the title, you might want to show the grip frame, the insertion point, bottom right, and line spacing single. So what we might want to do there, change that to say bottom left. We'll do a bottom left insert for it. Now, again, there's commands up here, zoom to, and all different tools that you can work with. I'm not going to worry about any of those too much at the moment. I'm going to apply the settings and click on OK. Now, you'll notice there's my little parts list. And can you see the crosshair is on the bottom left corner? And it's kind of placed it horizontally instead of vertically. Don't worry about that. Just click once and it will take you back to the BOM dialog box. You just want to click on OK again, and there's your parts list there, like so. Now, I'm just going to zoom in on this and you can see it's laying on its side. So I just select it. I then do a right click and rotate, use the bottom left corner there, click, and just flip it over like that using my polar tracking. Can you see? And I'm dragging that along the line like that. So I just come down there, click, and there's my parts list. Now, if I want to move that again, it basically behaves in the same way as an AutoCAD table. Click on that lower left grip, and I can just move it around accordingly, just like you would an AutoCAD table. So I'll pop it there. I'll hit escape to deselect and zoom in. And basically all of these item numbers here refer to your part references that you've got applied in your AutoCAD mechanical drawing. Now, the lovely thing about this is if I've got objects in my drawing that relate to this parts list, I can go to balloons here, like so, and I can select a part or an assembly. So if I click here on the edge here, there's a frame there. Can you see it says frame when I hover over it? So I'll left click and I'll bring my balloon out a little bit. Just make sure your polar tracking's on in the balloon command. So I'll drag that out a little bit, click there, get a nice little horizontal going, click again, enter to finish. Now, if I press enter again, that closes the balloon command. Now, if I zoom in on the balloon, you can see there's the little dash line, which is part of the settings for this particular drawing, and there's a number 8 in there. So if I now look at my new parts list from my bill of materials, you can see there's number 8 there. And there's one of them, but that's interesting. There's no actual information about number 8. We know it's a frame, but there's nothing in our parts list or our bill of materials. So I go back up to BOM, like so. Click on it, specify BOM to create or set current. Main is still the default there, so I can just press enter. And you'll notice in my list, in my spreadsheet, there is nothing, description, standard, etc. It's got a name in the actual drawing itself, but it hasn't got a description. So I'm going to put in there, just double click, and I'll put frame, and I might put something in brackets like, I don't know, mild steel, let's say. So it's a mild steel frame. Make sure you obviously get your case right. There you go. So it's a lowercase I. I'll apply that and I'll OK that. So you'll notice now parts list updates accordingly in the drawing straight away because I've applied that change. So number 8, there's one of them and it's a frame and it's mild steel. So if I hover over this now, you can see there's my frame there. And if I click on that, there's my frame and that's number 8 relating to that. And it relates to the parts list and the bill of materials. Very quick and easy to do. And that's how you add a bill of materials for your parts and your part references in your AutoCAD mechanical drawings. We can also generate a bill of materials and a parts list from the mechanical structure in the mechanical browser. We've got a new drawing for you. It's called bill of materials _ structure this time. And you want to download it from the library to follow along with the video. Make sure that you download the right drawing because it's a very similar drawing to the previous video. You want bill of materials _ structure.dwg. Download it and obviously open it up in your AutoCAD mechanical toolset. Now, before we start working with the mechanical structure, we need the mechanical browser. Quickest way to bring that up on the screen, down to the workspace switching here on the status bar, click on the arrow and select structure as your workspace. That'll bring up the mechanical browser. It'll also bring up the structure catalog. You can close that accordingly. We don't need that for this video. Now, you'll notice over in the mechanical browser, there's the drive system 1, which obviously highlights everything. Expand that and you can see you've got all different views of your drive system, etc. Now, you'll notice you've got the drive motor 1 and drive system 1, etc. Now, what I'm going to do is I'm going to generate a parts list and a bill of materials directly from the structure this time. So I'm going to select drive system 1 and I'm going to right click there and you'll notice I can create an assembly bill of materials for my drive system. So I click there like so. Now you'll notice there's different parts in the bill of materials. These are all these different bits and pieces here in the mechanical structure. So we're going to stick with drive system. That's the particular part that we're going to look at, which is down here in the drawing. It's the lower view. You can see there's lots of different elements that form all of this drive system. And the bill of materials looks remarkably similar to the bill of materials that we created from the part references in the previous video. Now, what we're going to do is we're just going to basically create a very simple parts list in the drawing. So it's the same workflow. Back up to all these different commands here, lots of different commands where you can tweak the bill of materials. I'm going to go to this one here, which is the parts list. So I click on parts list and it opens up the parts list just like it did in the previous video. This time though, you're going to change the parts list header. So we're going to change it, the title I should say, it's not the header. The headers are these ones here, item, quantity, description. We're going to give it a title and we're going to call it drive system because it is a particular BOM and parts list for a particular part of the assembly, which is the drive system. I'm going to insert the title as well because I want that to show up on the parts list on the drawing. The insertion point, I'll go with, let's say, bottom left, like so. And there's the item, quantity, description, etc. Now I can enable column splits and things. Again, don't worry about that. We haven't got enough columns to worry about that too much. Our particular parts list is going to be quite small. You can see there's not many entries, as you can see. If it was a great big long list, you could start splitting up the columns and things. Now, what I'm going to do is I'm just going to click on Apply and OK. Now, there's my little sort of parts list there, and I can specify the location anywhere I want, very much like we did in the previous video. I'm going to pop it, say, down here and click. And as you can see, it takes me back to the BOM dialog box. So I'll click on OK, zoom in on the parts list, and you can see there's all the information there for the drive system only, which is over here with the chain and so on. So you can see there's all the parts there listed. There's all the item numbers, which are our part references. So it's done that from the structure in the mechanical browser this time, instead of the part references that we placed in the previous video, for example. Now, what I'm going to do is go back to the BOM. Now, I can do that very quickly. I can go up to annotate here and go to BOM there. But it's much easier, if you think about it, to right-click on Drive System 1 and create assembly BOM again, because that's all the same settings as it was previously. I've applied all the changes, so everything's in there. But in the BOM dialog box, you'll notice right at the end, I can create balloons based on the current BOM that I've created, which is the drive system BOM. This is the same for the parts references that I created in the previous video as well. When you're in this BOM dialog box, you can actually create balloons directly from the bill of materials. So if I click there like that, it now says select a part or an assembly. I'm going to click on the chain there like so. So I'll zoom in. Let's get it sort of nice and neatly on that edge just there. And can you see my little balloon is coming off of there? Make sure we've got polar tracking on. And I'll just come up, I'll click, put a little horizontal in, click again, enter to finish. And you can see select part assembly. It's got that number in there. I can select another part if I want to. I'll just press enter to finish. Takes me back to the BOM dialog box. Click on apply just to make sure any changes are applied and click on OK. So there's the number 7 balloon coming off of a particular part from my mechanical structure. So if I now zoom in on my parts list for the drive system and look up number 7, it's the roller chain, as you can see there. So that's how you can create a bill of materials and a parts list and the balloons from your mechanical structure in your mechanical browser. We're starting a new chapter now where we're going to take a look at how the AutoCAD Mechanical Toolset can help you with design calculations. The AutoCAD Mechanical Toolset has various calculation tools built into it to save you time and effort when you want to look at different design options in your mechanical designs. The first one we're going to look at is the moment of inertia calculations, and we've got a new drawing for that. It's called moment of inertia _calcs.dwg, and as usual, you can download it from the library to follow along with the video. When you open up the drawing, you'll see a beam design options drawing in a title block with various different sections that we can use for this frame here in the drawing. Now we're going to go to the content tab on the ribbon now as well, and we're going to expand the calculation panel here on the end. Click on the flyout, click on the pin just to pin it open like so. Now the good thing about the AutoCAD Mechanical Toolset is all of our calculation tools are here. And it's this little icon here that we need. We need moment of inertia. So I click on it, come into the drawing area, and it asks me to specify an interior point of the section that I want to create a moment of inertia calculation for. So I'm going to zoom in on this first profile here, get the crosshair inside the shape as if you were hatching it, and left click. And you'll see sort of a magenta kind of shape appear. What you do now is you press enter to confirm that, and it fills the area like an AutoCAD region. And it asks, is that area filled correctly? I'm going to say yes, because it is. And can you see now it's asking me where that load force is going to go, and it's going to come vertically downwards. I can utilize that endpoint snap there, left click. So there's my force arrow there. Now the description of this is going to be very simple. I'm going to call it profile 1, like so, and press enter. There's our little calculation table. Zoom out a little bit. I'm just going to pop that above that profile there. And there you go. There's the profile 1 moment of inertia calculation. Now, it doesn't have to be a closed profile like that. You can pick different profiles with different shapes. So if I go back to the moment of inertia now and click here, come into the drawing area and zoom in on this eye section. It's a steel eye section, but I click once and twice and 3 times for each part of the eye section. Then I press enter, and you'll see it's asking you again, is that area filled correctly? Yes, it is. So I click on yes. And again, I'm showing where the force is going to go. I'm going to use that endpoint snap there and left click. The description will be profile 2. Type that in and press enter. And there's my little profile table again. I'm just going to hover over the endpoint there and just use a little bit of polar tracking and the extension snap there, just so they line up neatly in the drawing. So there's the calculations there for the moment of inertia for profile 2. Now, profile 3, the profile is orientated the other way around. It's been rotated through 90 degrees. So I go back to moment of inertia again here, like so, and specify interior points again. So I'm going to go 1 point there, 1 point there, 1 point there, 3 clicks. Press enter to confirm. Is the area filled correctly? Yes, it is. Again, the load is coming vertically downwards. So just drag it vertically down. You'll see it kind of lock in, left click, and you can see a little force arrow there. Description will be profile 3. So I'll type in profile 3 and press enter, and there's our moment of inertia calculation table. And again, just hover over that endpoint and just drag it across using the polar tracking and click there. So I've got 3 profile calculations, and the moment of inertia has been calculated for each of those profiles. That would have taken me a long time manually. The AutoCAD Mechanical toolset has just saved me quite a lot of work. Now, I did have some text here, rectangular hollow. What does that mean? Well, we might want to use a rectangular hollow section. So I can go up to this little icon here, and I can actually have a predefined profile section. So I click, come into the drawing area, and what section do I want? Well, I want one of these, a hollow section, this one here. Click on OK, and now I enter the length, which will be 100, enter. The height will be 300, enter. And the thickness, I'm going to say 30 and enter. And there's my little moment of inertia calculation. I'll pop that just above the text that says rectangular hollow section. There you go, rectangular hollow section, 100 by 300 by 30, and there's all the calculations for it. So I don't actually need a diagram of that, but I can go and look at a predefined moment of inertia calculation for a predefined section. I'll just unpin the calculation panel and double click on the wheel, and there's my completed design options and moment of inertia calculations in my mechanical drawing in the AutoCAD Mechanical toolset. That has saved me a huge amount of calculation time. In this video, we're going to take a look at how we can calculate our beam deflections in a beam on an AutoCAD Mechanical drawing. And again, the AutoCAD Mechanical toolset does all of these calculations for you, saving a huge amount of time. Now, the drawing we've got for this is beam deflection calcs.dwg, and you can download it from the library as usual to follow along with the video. Open it up in the model tab and just make sure you do a double click on the wheel of the mouse to zoom extents. You should recognize some of the content over here on the left. There's all our moment of inertia calculations. Now, the lovely thing about the moment of inertia calculations is each one of these little tables is actually a moment of inertia calculation. It's not just a little text table. It's actually linked to the calculation. So I can utilize the moment of inertia calculation to work out my deflection line and my bending moments. So we're going to take a look at that and work out how that's going to work. Now I'm in the Content tab on the ribbon, over to the Calculation panel, and I'm going to click on Deflection Line. Now it says select the moment of inertia block. I'm going to go with this user profile one here, this one, and click here. Now as soon as I do that, the AutoCAD Mechanical Toolset now knows that I'm using that profile shape and that particular moment of inertia calculation. Now these lines on the drawing are simply lines representing the length of a beam that might be in this design here. So the starting point is going to be here, left click, come to the end of the beam, there's the end point there, left click. As soon as I do that, it prompts me now for all of my beam calculation settings and variables. Now, the table that we're working on, just leave that as it is. It's working to a particular calculation table. I can go and search for other tables if I want to. But I do need to provide some supports and loads on this particular beam. So I'm going to go here. I want this one, which is your fixed support. So I'm going to click there and put a fixed support at this end, left click. I'm then going to put a moving support, this one here, at the other end, left click. So there's my two supports. I'm now going to apply a distributed load first, which is this one with the three arrows. Click there, and the insertion point of this is going to be from here, left click, and we need the end point. That needs to be the midpoint snap of the beam. So I'm just going to do a shift and a right click, and on my snap overrides, I want the midpoint, which is just there. There's the midpoint, and I click there like so. Now the line load, I'm going to set that to 40 newtons per millimeter and press enter. Now I want one more load, and that's going to be a point load. So I select the point load here, like so. Now I need to specify the insertion point, which is going to be a mid between 2 points. So again, shift and a right click to bring up the snap overrides, and you want the mid of 2 points. Click there. First point is going to be the midpoint or the intersection there. Second point is going to be that intersection there. And then it says line division 0.5. That's a bit weird. What does that mean? I'm dividing it by 2, half and half, 0.5. Press enter to confirm, and there is your lovely little point load. Now, it's a bit weird how this works. You've got a rotation angle. Can you see how it rotates round? The arrow is pointing to the left, the arrow is pointing to the right, pointing upwards. You want to be above your little point load because you want it to be pointing downwards, if you get my meaning. Click there for the rotation angle, and the single force will be 100 newtons. Type it in and press enter. So there's all of our values put in. We've got our two supports, we've got our distributed load, and we've also got our point load. Now we want to calculate moments and deflection. We want the bending moments and the deflection line. So I click there like so. So we want a graph draw here. We want all of this. We want direction of main axis 1, main axis 2. We want the result, and we also want the result to be calculated automatically. The table title will be something along the lines of, I guess, deflection line or beam deflection. Let's call it beam deflection for now. Now, again, you could be a lot more descriptive if you wanted to. So I'm going to click on OK now, and it says enter scale for the bending moment line. Now you can see it's kind of worked out a weird 1 to 45.038 there. Just accept that because it's scaling that to fit the drawing, and there's our bending moment line. Now the scale for the deflection line, again, it's got 180.8 to 1. Press enter to accept it, and there's your deflection line as well. There's your little table with all the calculations. Just put it next to it, left click, job done. You've now got all your beam deflection information in here and on your bending moment and beam deflection drawing as well. Can you see there's all the calculations there? Everything is in there. Now, the reason that we were using that table, can you see it was a specific material that we were using for our beam? And the good thing is it's calculated all of that. You've got it all on your drawing. Double click on the wheel to zoom extent. All those calculations are both visual and in a table, ready to go. You don't even need to get a calculator out, and that's how quick and easy it is to work with these calculations in your AutoCAD mechanical toolset. Another thing that can be calculated in the AutoCAD mechanical toolset is your shaft calculations, the strength of a shaft in a mechanical assembly drawing. Now, talking of drawings, we've got a drawing for you to download from the library. It's called shaft_calcs.dwg. So download it from the library to follow along with the video. When you open it up in the model tab, you'll see an end view over here and an end view over here and a side view of your shaft in the middle. We're going to be working with the shaft in the middle, but you might want to do a little bit of panning upwards just to move it towards the top of the screen like that. We're going to go to the Content tab again for our calculation panel here. Click on the flyout and just pin it open. And if you hover over various icons here, you'll see that this one here is a shaft calculation. So I click on it. Come into the drawing area and it says Select Contour. Now that's a little bit weird because a contour is normally a line in the AutoCAD mechanical toolset. The good thing is that center line has a part reference attached to it. So click on the center line and you'll see there that you've got your contour appearing like so. So I'm just going to bring that down a little bit and just pop it underneath the existing shaft there like so. Now, here's where it gets a bit interesting. It's calculated that it's a rotating shaft already. That's great. But we need to add some supports. Here's all our materials. I'm going to leave that as it is. I'm going to add here a support here, a fixed support. Now, that fixed support is going to go on that end point just there. So I'll click there like so. I'm going to go for a movable support on the midpoint snap in there. So down to object snaps, just make sure that midpoint is on. There it is, it's on now. Click on the little flyout arrow there, and I'm going to go for that midpoint snap there. So that's my movable support. I then need to add a point load to the shaft as well. So I'm going to click here on this one, point load. Now the point load is going to go on that midpoint there, like so. Click there, and you'll see you get an arrow just above. You want to make sure that the rotation angle is correct. So can you see when you move the arrow around, when you come up to vertical, it should be 90 degrees. Can you see that? So just type in 90 as the angle and enter, and that'll sort it out. Now you'll see that you've got various types of calculation here. We're going to go to the resultant tab, and our point load is going to be 2000 newtons, like so. That's all we need to change there. Click on OK. And now we've got everything ready to go for our shaft calculation. Now this is where it gets a bit interesting. I want moments and deformations, that one there. So I click on moments and deformations, and I've got lots of information going on. I'm not going to change any of the settings. The only placement I want is under shaft, up here, top right. And the table title, well, it's calculated values. That could be whatever you want it to be. I'm going to call it shaft calculations. So shaft and then calcs like that, or calculations. Click on OK. And can you see it places everything underneath that shaft? And there's the table. So if I zoom out a little bit now, I'll put my table over here somewhere and click like so. And then I'm going to close the shaft calculation dialog box by clicking on close. If you zoom out now, it's done all of the graphs for me, all of the calculations for me, and put them in a table. If I zoom in there, can you see I've got all my load points and so on. Now I can move things around a little bit if I want to. There's nothing to stop me doing that. So what I might do here is just click and drag and come up a little bit. And I want to just come to about here and click there. Now I've got some objects selected that I don't want selected, which are my two supports. So I hold down Shift, click on one like that, deselect, click on two, deselect. And then if I zoom out a bit, you'll notice that this bit here, the 2,800 newtons, is actually on that support. And the 0 and the 4,800 are on that support. So what I need to do now is just come out a little bit, right click and select move on the shortcut menu. And just remember, you've got all the power moves as well. You just want the regular move like that. And I'm going to zoom in on that little top apex there and just come vertically down a little bit to about there, like that. And then it just separates things out a little bit. Can you see that? It just tidies it up. Now, the good thing is you can set all of this up in your viewports. If I go to my calculations layout tab here, I've got some preset viewports in place. I'm going to double click in the left viewport to activate it, do a little bit of zooming and panning. So I'll get that nice and central in the viewport there like so. Double click outside the viewport, click on the edge of the viewport and use the grips to tidy it up. Click on the grip, drag that in that way, click on the grip, drag that in to say there. Hit escape to deselect. That viewport now has all the graphs, all the diagrams needed. Double click in the right hand viewport, do a little bit of panning. There's my table. Make sure it's central in the viewport like that. Double click outside the viewport to deselect. I've now got an entire calculations layout tab set up in a few minutes. All the calculations are done. I've got everything I need to know about the strength of that particular shaft in my AutoCAD mechanical toolset. The AutoCAD mechanical toolset can also assist you by doing FEA calculations, finite element analysis calculations. Now we've got a new drawing for you to work with so that you can do some FEA calculations. Surprise, surprise, it's called FEA_calcs.dwg. You know the drill by now. Download it from the library to follow along with the video. When you open up the drawing, you'll be in the model tab and you can see we've got a simple outline for a pedal pivoting on this little rod here, which is represented by the circle. Now we're going to generate some finite element analysis on that pedal. So we go up to the content tab and we click on FEA here in the calculation panel. Now, as soon as you do that, it'll ask for an interior point. Just pick a point inside the pedal outline and click. And you'll see there that it highlights the pedal. And now you've got the FEA 2D calculation dialog box. Now we do need to add a number of tools here. Now the first thing I'm going to do is I'm going to go down to config though. We want to make sure that our symbols here are set to 0.1. And the reason we're doing that is purely to make sure that the symbols aren't too big in this particular drawing. So that's our config all set up. We're going to set up a new material. I'm going to click on the table here and I'm going to go to ANSI materials. ANSI stands for American National Standards Institute. And I'm going to scroll down the list until I find a particular type of steel, and it's this one here, steel SAE 1025. Click on OK, and you can see that things like the E number change based on the material chosen. What we're going to do now is add some movable supports. Now, the movable supports are here. I'm going to click on that one first and come into the drawing area. This is going to be a bit of a weird one. So we're going to zoom in on the circle, and I'm going to select this intersection here, and then go around the circle and click again on the intersection, like so. And then what I'm going to do is specify the side from the endpoint. I'm just going to go out here and click, and there's our little sort of like loading there. Now that loading is in essence the pivot when you press the pedal up and down. Now I'm just going to move the calculation dialog over this way a tad and click on movable support again here. And this time the support is going to go over here on the right hand end from this point to this point, and I'm going to come up above there, and that's the side from the end point. So I click and you can see the load is added to the pedal there as well. Now we're also going to add some forces on this. We're going to go for the 2 arrows here like so. So I click and that's going to come in like so, and again zoom out and pan, and you're looking at this top face here. So I'm going to go click there, go up again for the side from the endpoint and click again, and it'll ask for a new value. The value is going to be, in this case, 70 Newton millimeters. Type in 70 and press enter. You'll see that update on the screen. So what we've got now is all of our forces added to the pedal. Now I'm going to come down to some settings now for our results. I'm going to click on the mesh value here, 7.8. That's a default, by the way. I'm going to change that to 5, like so. And that's all in place. And now what we need to do is we need to place that mesh. So I'm going to click on the mesh button like so, and it adds the mesh, as you can see, to our pedal. Now I'm going to do a little bit of zooming and panning and put that over there like that. I'm just going to press enter once. That takes me back to the dialog box. So now we've got to start thinking about our results. Now there's lots of different buttons here for your results. Now I'm going to click on this one first. And what that will do is it will give me the ISO lines, and I'm going to use the von Mises stress diagram. So I'm going to go for the line diagram rather than the full color. So line diagram, click on it on the left like that, and just click on OK. Now the thickness must be greater than 0. Hang on a minute, we've missed something. Yes, we have. I'll just close that for the moment. We cannot calculate anything because our thickness in the calculation is 0. Now we need to make sure that we've got a thickness there. Now I'm going to use a 7mm thickness. Now what will happen is when I click on the results and click on the graphic representation again and click on OK, I now get some results, you'll notice. Now, it's put them on top of the original. What I can do is click over here and then drag and just make sure that's horizontal. You'll see there that's horizontal, like so, because the polar tracking's on. I'm going to just drag it and line it into about there and click. And there's my table, like so, for those results there for the von Mises stress calcs. So you can see the major stress on the pedal is around that circular rod when the pedal is either depressed or released. So I'm going to click. I could line that in if I wanted to. I'm just going to place it there like that. So that's all set up. I now press enter again to go back to the dialog. I'm now going to go to this one here, which is a different set of calculations. So I click there, like so. These are my stress calcs. I'm going to leave it at automatic and click on OK. Now again, can you see it's placed them over the original? So what we're going to do, we're going to pick a base point down here, like that, and just move it down a bit. So zoom out and pan up a bit because you're going to need to add some more here. And I'm going to click that about there and pop my little table of calcs just there, which gives me the little legend of what all those elements mean. So if you zoom in on any of these, can you see the colors represent different parts of the stresses and yield points there? In this case, can you see the stresses there with all the colors and the arrows and so on? Now I'm just going to roll back on the wheel and zoom out a little bit more and press enter one more time. And this time I'm going to calculate this one here. Can you see the little blue mesh? Click there. That's our displacement. How is it going to displace with the forces on it? I'll leave that as automatic and click on OK. Again, it places it over the original, you'll notice. So you come down here, click, and just pick a point so that you can place it. And I'm going to pan up and pop it sort of there. I might even need to zoom out a bit to get this one to work. So zoom out a bit and pan up a little bit. I'm going to click there like that and put my table there like that. Now, what I'm going to do is press enter one more time and now click on close. And when I do that, you'll notice that I've got various elements there. You can see them all sort of showing up, and they're not neatly placed, but you can easily move all of these around, no problem at all. So what I can do is I can select all of my deflection here like this. And what I'll do now is I'll just simply right click and use move. And make sure you use the regular move, none of the move copy rotates. And I'll pick a point, let's say just there, bring that down a little bit to about there. And then I can do the same with the table. So I'm zooming out a little bit there. Let's just kind of get that to about there. Click on the grip and just pop it underneath to tidy it up. Hit escape to deselect and double click on the wheel to zoom extents. You've now created an entire finite element analysis of that pedal with those loadings. And that's been done in a few minutes. That doesn't take long at all in your AutoCAD mechanical toolset. Now, if you'd done that with third-party software or even just manually calculated it, it would have taken a lot longer. And that's where these productivity tools with the design calculations are incredibly useful in the AutoCAD mechanical toolset. We're starting a new chapter now, and we're going to be taking a look at how we can leverage existing mechanical drawing data. Now, we're going to take a look at how we can demonstrate our mechanical data in the AutoCAD mechanical toolset. In this case, AutoCAD Mechanical 2023. We've got a drawing for that. It's driveassembly_custom.dwg. So you want to go to the library, open that up, and then you can use it to follow along with this particular video. Now you'll notice when you open up the drawing, it'll be in the Drive System Assembly Layout tab. Now what we want is we want the mechanical browser up as well. So what I'm going to do, I'm going to go to the Model tab, like so, go to the View tab on the ribbon, and pop over here and bring up the mechanical browser. It's in the Palettes panel, like so. Now, the good thing about this is now I can look at the mechanical structure of my mechanical drawing. And I'm in the AutoCAD mechanical toolset. So the benefit I've got here now is if I expand out this drive system here, there's all the drive system structure. So if I click on drive system, there you can see it highlights everything. I can look at the top view, the side view, there's the frame, the drive motor, the shaft drive, etc. So all of that is linked by way of the mechanical structure in the mechanical browser, regular parts from the content libraries, part references that we've talked about previously as well. Now, all of this is easily demonstrated as AutoCAD mechanical information in a drawing when you're using the AutoCAD mechanical toolset. Now, the problem we have is what happens if one of your colleagues isn't using the AutoCAD mechanical toolset? What happens if this drawing gets saved out as a regular AutoCAD drawing? What will happen to all of these like content library elements? So if I zoom in here, I've got things like my chain. So if I hover over that, can you see it's a content library item there? If I hover over this sprocket here, you can see it is another sprocket to a particular standard, and so on and so forth. Now, all of these standard parts from the content library will display as what they call proxy items in a regular AutoCAD environment. Now, obviously, I'm not going to be able to edit them. I'm not going to be able to work on them in regular AutoCAD, but people will still be able to see them when they open up the drawing in regular AutoCAD. So I'm just going to double click on the wheel now to zoom extents. And what I'm going to do, I'm going to save the drawing out as a regular AutoCAD drawing. Now to do that, it's a simple trip up here to the quick access toolbar and click on Save As. Now you'll notice in this particular drawing, can you see there, I've got drive assembly custom.dwg, but when I'm saving out, I can save it out as drive assembly custom acad.dwg. Now I've already put that drawing in the library for you. You can download it if you want to, but I'd like you to save the drive assembly custom.dwg file as drive assembly custom underscore acad. ACAD meaning just regular AutoCAD. Now I'm using the AutoCAD Mechanical 2023 version. So what that means at the moment, if I save it out at the moment, it's going to save it out as a mechanical drawing. I need to click on that down arrow there, and I need to select just a regular AutoCAD 2013 DWG, that one there. So I could use that one, or if I want to be a bit more current, I could use AutoCAD 2018 drawing. I'm going to use the AutoCAD 2013 drawing there because that means now that anybody with a version of AutoCAD 2013 and upwards can open the DWG file. So you can see it's drive assembly custom underscore acad.dwg, and we're saving it out as an AutoCAD 2013 drawing file. Just click on save, and that will save that out. It's obviously asking me to replace it, so I'll just say yes. And that's now saved that out as a DWG file, just a regular DWG file. And you can see up here, I've got drive assembly custom acad.dwg. Now, what we're going to do in the next video is we're just going to work with regular AutoCAD and see what the differences are when we try to leverage that mechanical data just in our regular AutoCAD environment. So what you might want to do now is make sure this drawing's saved, close down your AutoCAD mechanical toolset and open up your regular AutoCAD, because the next video we're going to be working in regular AutoCAD. If you look at the top of the screen, you can see now that I am in the regular AutoCAD 2023, the latest version of AutoCAD. And the drawing I have open is the drawing we previously saved in the previous video, drive assembly custom underscore acad.dwg. Now, if you haven't saved it out, don't worry, you can download it from the library and open it up in regular AutoCAD if you want to follow along with this particular video. Now, you'll notice when I'm in regular AutoCAD, things like the model tab and the layout tabs are still the same. I've still got the model tab, there's the model tab, there's the drive system assembly tab, there's the shaft drive assembly tab. So they're all the same as if they would be used in the AutoCAD mechanical toolset. Jump down to the model tab now, and we're going to zoom in on this side view here like so. Now you'll remember in the previous video, I selected some of these items, didn't I? Because they were from the content library and they had things like part references applied to them in the AutoCAD mechanical toolset. Now, what I'm going to do is I'm going to select this sprocket here, like that. If I hover over it now, can you see it's just a block reference on the layer AM0N? If I click on it like so, and then do a right click and go to properties, you'll see that it is simply a block with the name asterisk U65, and it's unitless. There's nothing there. It's just on a layer. So this is where leveraging that mechanical information is really important, because at the moment that's just basically an anonymous block in your AutoCAD drawing. There's no information associated with that. So for example, if I close the properties palette and I just hit escape to deselect that sprocket, if I go back to my drive system assembly here, all of this parts list is meaningless because there's no part references. There's nothing that links to this information. If I click on this, like so, you can see it's on layer AM_5. That's great. But if I now right click and go to the properties of that balloon, again, it's an anonymous block, asterisk S13 on layer AM_5. So the issue you have is when you're working in regular AutoCAD, you cannot leverage all of that mechanical information. So if I click here like that, that is just a regular table now. If I double click on it, you see there, it's just a block definition. That's all it is. It's just a block. And I don't even know which block it is. You can see there, I've got title block and so on. So the information that is all linked, all the part references, the balloons and so on, they're pretty meaningless in regular AutoCAD. Now, something as well that's really important is when you're working in a mechanical environment with the AutoCAD mechanical toolset, if you hand this drawing over to somebody, they could potentially start exploding blocks and exploding things like your sprockets and your balloons and your parts list here on the drawing. You don't want that to happen. So what you want to do is if you're going to make that transition to the AutoCAD mechanical toolset, you want to make sure that everybody is using that AutoCAD mechanical toolset. You want to make sure that anybody that is working on mechanical design uses the toolset and not the regular AutoCAD. The regular AutoCAD is great for things like updating this. So if I double click there, that'll bring up the enhanced attribute editor. I can edit title block information, no problem, because it's just a block with attributes. So you can see there's the information there. There's the tags, there's the prompts and so on. And I can change the values accordingly. That's great. So somebody using regular AutoCAD or possibly AutoCAD LT can edit what I call the general transmittal information, things like the title blocks and so on. But you don't want people editing things like your parts list, your balloons, or in the model, messing around with elements like this, because these elements come from the content library, and the only way they make any sense is when you leverage that mechanical information in the AutoCAD mechanical toolset. We're starting from scratch in the AutoCAD mechanical toolset this time around in this particular video. You can see that I've got AutoCAD Mechanical 2023 open, which is the latest version, and I'm currently in the Start tab, you'll notice. I want to create a new blank DWG file in the AutoCAD Mechanical toolset. I can use New up here on the Quick Access toolbar, or I can click on New here, click on the flyout, and browse the templates to find a template to open up a new blank drawing, a DWG file. I'm going to use the ACAD ISO.dwt template, that one there, which is just a default blank metric DWG file when it's opened up. So when I click on open, you can see now that I've got drawing 5. There you go, there's drawing 5 there, .dwg. It's just a blank metric drawing file. Now, I'm going to go to the Layout 1 tab. It opens up in the Model tab. There's Layout 1, bottom left. Click on Layout 1 and make sure that Layout 1 is your current tab. You need to be in a Layout tab for what we're going to do next. Now, there's no actual drawings, DWG files for this particular video, but there are some files that you need to use, and I'll explain those in a moment. We're going to go up to the blue Contextual Layout tab on the ribbon. And you can see there's various tools available in the ribbon to create viewports and views in our AutoCAD mechanical toolset. Now, what we're going to do, we're going to generate some views from a separate Autodesk application. We're going to bring some views in using an Inventor part. Inventor is another Autodesk application used in design and manufacturing for 3D design. So we're going to bring in some views of a 3D Inventor part assembly. Now this is really clever because I don't have to think about this too hard, because AutoCAD Mechanical, the mechanical tool set, develops the views for me as I go. So I'm going to go to this Create View panel here, click on the flyout underneath Base, and I can select from a 3D model in the AutoCAD model space in the Model tab, or I can go from an Inventor file. So if I click on From Inventor, it'll open up this dialog box like this. Now it's really important that you have these files downloaded. So you need the spacerwedge.iam file, and you need the parts folder downloaded as well. There's a whole load of Inventor parts in that parts folder. So the parts folder needs to be in the same folder as the spacer wedge IAM. An IAM file is an assembly file in Autodesk Inventor. So IAM spacer wedge needs to be in the same folder as the parts subfolder. You can see it's all in my folder 11 there. So the parts subfolder and the spacer wedge IAM, download them from the library, make sure they're in the same folder. Now, we're not going to change much here at all. We just need to make sure that we're using files of type Autodesk Inventor, IAM, IPT, IPN. So an IAM is an assembly file, an IPT is a parts file. If you went and looked in the parts folder, there'd be loads of IPTs, and those IPTs form the IAM, the spacer wedge. So you need to make sure that everything's in the right place. So like I said, parts subfolder, spacer wedge IAM in the same folder, in the same format that you can see here. The file that we're going to be using is the spacer wedge IAM file. So now I just click on Open. Now it goes a bit weird. Look at the ribbon. We are now in the Drawing View Creation tab. So you'll notice now that I can set all of this the way I want it to be in my Layout 1 tab. So you'll notice it's using a visual style at the moment, hidden lines. I'm going to change that to shaded with visible lines, like so. And what I'm going to do now is I'm going to place this base view top left and left click. Now, as soon as I do that, I've got lots of information going on here. Representation, orientation, hidden lines, scaling, visibility, or do I want to move it? I'm just going to click on Exit. And then it allows me to create another view. There's the side view. So I'll click there. And then I'm coming down here, and I'm coming down vertically downwards, creating a top view. Click there. And if I go diagonally there and click there, I've got an isometric view as well. All of this has come from those 3D parts in Autodesk Inventor. I'm now just going to press Enter. As soon as I do that, can you see it updates the entire drawing? Now, based on the settings, I went for shaded so that I could see my hidden detail and so on as well. And what I want you to do now is just zoom in on this isometric view, which shows a whole load of detail. Look at that detail there. Can you see it's all shaded and so on? Now you'll notice it's all a bit pixelated in places. That's because it's only a representation of what's in that Inventor model. So I'm going to zoom out now. I'm just going to double click on the wheel and zoom extents. Each of these views can be selected and just deleted like so. So I can just click on each one and delete them accordingly. So like so. I'm just going to delete each one. And let's say I'm not happy with that particular representation of the views. I'll double click on the wheel to zoom extents. I go back up to base here and go from Inventor again, like so. There's my spacer wedge IAM. There's my Inventor files. There's my parts folder, like we discussed previously. I'm going to click on Open again. And as you can see, there's my view there. What I'm going to do this time is I'm going to just click here, and I just want visible lines, like so. So I just want visible lines. Can you see that? I want that visible lines option there. And I'm going to click here like so. And again, click on Exit, place a side view, click, place down there a top view, and then diagonally isometric view, like so. I can carry on placing views to my heart's content. I'm just going to press Enter. And you see this time, it's done what is called a visible lines representation. There's no colors involved, no shading, no visual styles. So it's a line drawing. But this is where you get to see the degree of accuracy. If you zoom in real close, you can see there, look at the accuracy. You've got the bolt there, you've got all of the wedges and the bolts holding the wedges together. And this is all taken from parts in Autodesk Inventor. And you can start adding some annotation to that. You could even dimension it if you want to. There's nothing to stop you adding information to those views that you've brought in from a separate 3D design application. So it's really clever stuff. Now, I'm not going to worry about saving this, but if you wanted to save this as a file name and start playing around with some text and some annotation to develop the views, you are more than welcome to do so. But basically, all you've done here is create some views from a separate type of application. And it's really clever in the AutoCAD Mechanical toolset because you might need just some visual representations of that particular part just purely as details so that you can relate them back to what you're designing in the AutoCAD Mechanical toolset. We're starting a new chapter now where we're going to take a look at some of the mechanical options in the AutoCAD Mechanical toolset that you might use as a CAD manager. Things like setting up standards and templates and so on. Now, in this particular video, I'm going to show you how to set up a new standard and set it up as a template in your AutoCAD Mechanical toolset. All the way through this course so far, I've been talking about how CAD standards within the AutoCAD Mechanical toolset can be set up and allow you to automate your processes and your methodologies, thus saving you a lot of time and allowing you to be more productive. So I'm going to show you how to set that up and save it as a template in this particular video. So you'll notice I've got AutoCAD Mechanical 2023 open. I haven't got any drawings open at the moment. I'm going to start a new drawing up by going up to the new icon here on the quick access toolbar. Now, as soon as I do that, it will take me to the usual template location, the DWT files. I'm going to use the ACAD DWT file there and click on open. That'll open up a blank drawing in my AutoCAD Mechanical toolset. Now, here's where it gets a bit interesting. All I'm going to do now is right click and go to options. Now, in the options, if I go to the AM Standards tab, you'll notice there's lots of these AM tabs in the AutoCAD Mechanical toolset, but you want AM Standards, that one there. Now, you'll notice we're using the ANSI standard at the moment, the American National Standards Institute standard. And that's a preset standard with all of these settings here on the right-hand side. So what I can do is I can click in here, and I'm going to create one just called Company Standard. Now, obviously, that's not very imaginative, but you get the idea. So that will be my company standard. Now, the measurement there, I want to set that to ANSI, like so, but I also want to OK that and make sure it's metric, like so. So I'll click on metric there. And it's based on ANSI, and I'm going to apply new settings to layers when the standard is created or changed. I'm going to change the model scale, that's that scale area that we discussed previously, to 1 to 10. So in the model tab, that will be 1 to 10, like so, but I will use the 1-to-1 scale in the layouts. Now, I don't have any default standards template. If there was one, I could go and find the DWT file and load that up. I could browse to it there, like so, and go and find it if I needed to. Now, I'm going to click on Apply. Now, I'm going to apply this company standard. Now, as soon as I do that, it lets me know that the scale has changed. And it's asking me a really important question. Do I want to start the AutoCAD Mechanical Rescale command, the AM Rescale command, to adjust symbol sizes according to the new overall scale? So this could affect existing drawings. Now, I'm not going to say yes. I'm actually going to click on no. But I want to make sure that you don't ever tick this box here. Don't ever tick this box because it won't ever show you this little dialog box again. And you need this little dialog box, trust me, to pop up and say, hey, do you want to start the AM Rescale command? Because sometimes you might not do it when you need to do it, and sometimes you might do it when you don't need to do it. So just allow that little dialog to pop up every time by not ticking that box. I'm going to click on no, like so, and then I'm just going to click on OK. So that has updated the standard in this particular DWG file. Now, at the moment, it's a DWG file. I need to make it into a template so the DWT file has the standard in it. So I'm going to pop up to Save As here, like so. So there's my Save As. Now I'm going to save this in a particular file location, but I need to make sure it's a DWT file first. So I come down to Files of Type here, and I'm going to look for an AutoCAD Mechanical Drawing Template, DWT, there, like so. Now that'll default to the regular template location, where I found the ACAD DWT to create this drawing in the first place. What I'm going to do is I'm going to go in here, there's my exercise files folder, and there's my mechanical options CAD manager folder. I'm going to save it in there. And you'll notice there's already a company ANSI metric.dwt in there. Now, I've already put that in there. You can download it from the library if you wish as well. I'm just going to save it there like that, and I'm going to overwrite the one that's already there. So I'm just going to hit save, like so. It will say, do I want to replace it? Simple answer, yes, please. Now, I'm going to get rid of this description here, like so. I'm just going to zap that. I don't need that. And I'm going to make sure that that is metric, like so. And then all I've got to do is click on OK, like so. And that will save that as a DWT file. Notice the file name change at the top of the screen. If you just hit the save icon quickly, you'll see there that it's now company ANSI metric.dwt. So you can use this DWT file and browse to it to open up new mechanical drawings that are using your company standard DWT file. Now, I've only gone into the basics there, but there's a lot of settings that you can go into in that standard and set it all up and make it work exactly the way you want it to as a company standard, as a national standard, as a localized standard. It's up to you. But you can have as many of these standards as you like and as many templates as you like for each individual standard as well. We're going to take a look now at configuring your mechanical layers and the layer properties associated with them. For that, we've got a new drawing for you. It's called conveyor_acad.dwg. At the moment, it's a regular AutoCAD drawing with regular AutoCAD layers. What I'd like you to do in the Model tab is zoom into this particular part of this view here. Now, you'll notice we've got lots of regular lines, so hover over that one and click on it. You can see that that's on the layer visible. If I hit escape, these magenta dash lines are on the layer hidden. Now, if I go to the layer drop down, you can see I've just got some regular AutoCAD layers. Now, if I go to the manager here, the mechanical layer manager, and open it up, you'll notice that it's only those layers that are available. Can you see that? I've got none of my AM, AutoCAD mechanical layers. Now, the issue I have is I want to make sure that these layers go onto those AM mechanical layers. How do I do that? Well, one thing I could do is I want to make sure that all of these hidden detail lines, the magenta ones, go onto an AM layer. Now, obviously, what I could do is switch off the layers I don't need to see, like so. Visible is the current layer, so I'll turn that current layer off anyway, like so. And when I come into the drawing now and apply that, and click on OK, there's all the lines and objects on that particular layer, right? So if I select all of those now and go to the layer drop down, I should be able to find those AM layers, but they're not there. So what I'm going to do, I'll switch all these layers back on again using the layer drop down, make sure everything comes back and hit escape to deselect the lines. I'm going to go back to the mechanical layer manager. Now you'll notice that there's various icons available here. Now, you'll notice this one here, and it says Show Hide Layer Definitions. Now, layer definitions are your AM layers. So if I click on that, there they all are. And there's all the associated objects and all the line types, colors, etc. Now, if I look at AM3 here, there you go. It's magenta, and it's using a dashed line type, an AM dash line type. And it's used for hidden line, you'll notice, in the associated objects. Now, I want to make sure that that is the layer that these dashed lines go onto. So what I'll do is I'll just OK that for the moment. Now, all those layers have appeared in that list, the AM layers. But if I go to the layer drop down, they're not available. So how do I get this to work? How do I get those hidden objects on the hidden layer onto that AM3 layer? Well, there's a certain way of doing it. So if I hit escape just to lose that menu, and open up the mechanical layer manager again, I'm going to scroll up my list here, and there's AM3 up near the top. There it is there. So if I select that layer there and make it the current layer by clicking on this little green tick, do you notice everything is now available? On, off, freeze and thaw, etc. for that layer. So I'll apply that and I'll OK that. And notice now in my layer dropdown, AM3 is available and it's the current drafting layer. So I've made it the current layer and it's come into the drawing. So what I can do now is I can go back to that layer dropdown. AM3 is the current layer. So I'll freeze or turn off, doesn't matter which one. I'll turn off layer 0. I'll turn off center lines. I'll turn off the threads and I'll turn off the visible like so. So now all I've got left is those objects on that hidden layer. So I can now click in the drawing area, click and drag, select them all like that, go to the AM3 layer, click on it, and now all those objects are on the AM3 layer where I want them to go. So if I now hit escape a couple of times just to deselect, and then go back to the layer drop down, switch these layers back on again, make sure everything's visible like so, and just hit escape a couple of times. Now if I select one of those hidden detail lines, it's on that AM3 layer where I want it to be. So that's one way of doing it, making the AM layer, the layer definition, current, and then using it in the drawing itself. I'm going to zoom in a little bit closer now, and I'm going to go back to the layer manager again, like so. Now, there's another tool that I've got where I can bring a layer into the drawing. Now, you'll notice I've got different icons. So I've got show hide layer definitions that we used earlier. I've got things like highlight. I've got this one here, move into. So that's the third one in from the right. Now, if I click on move into, like so, it prompts me to select an object. So I'm going to select that white line there. Click on it and press enter to confirm. Now it takes me back to the mechanical layer manager. So if I now click on AM0, for example, and move that into the drawing, notice it puts it on the AM3 layer, like so, and it's updated it accordingly. Now, what I can do is do something else as well. I'm just going to hit escape there a couple of times and close the mechanical layer manager, and you'll notice it cancels what I did as well, thank goodness. So what I can do is I can bring other layers into this list very quickly and easily by going to the layer manager. So I'll open up the manager again. There's AM0. So what I'll do is I'll make that the current layer, and that brings it in like so. You can see that AM3 is now in use with the little gear cog. Now I can select the AM0 layer, move it into the drawing, and select the object there like so. So I'll select that object there. Press enter to confirm. Takes me back to the mechanical layer manager. I'll apply that and I'll OK it. Watch what happens when I click on this now. It's now on the layer AM0, like so. It was on the visible layer, but I've converted it to the AM0 layer by moving that layer into the drawing after making it current as well. So there's various ways and means of configuring your layers and your layer definitions and working on them in your AutoCAD mechanical drawings when you're using the AutoCAD mechanical toolset. We're going to take a look now at configuring your annotation and configuring your annotation standards as well. Now for this, we've got a new drawing for you. Make sure you open up configure_annotation.dwg from the library and make sure you're in layout 1. And what we're going to do, we're going to take a look at how you can configure your annotation as per the particular CAD standard that you're using in your AutoCAD mechanical toolset for a specific project, for example. Now we've got the drawing open. You can see in layout 1 there, we've got a valve plate, we've got a list of coordinates for the holes, we've got a hole table, and you can see the title block is all set up as well. Now all of this dimension annotation, all of your hole numbering, everything else, that's all been set up because you've got your hole chart here, for example. Now, what you also need to think about is how this is all configured, how this is all set up. If we jump back to the model tab, you'll notice all we've got there is the plate with the holes in it. If I go to layout 1, that's where all the annotation kicks in. Now you can set all of this up in the CAD standard that you're using in the AutoCAD mechanical toolset. But how do you do that? Well, it's actually incredibly easy, and you can do it for any particular project, any particular sort of national standard, internal standard, etc. It's just a case of right-clicking and going down to Options. And in the options, you need to go to the AM Standards tab. Notice there's lots of different AM tabs, you'll notice. You want AM Standards. Now, at the moment, this particular drawing has been using this standard here, the company XYZ standard, which has a measurement of metric and the layout scale is 1:1, which is previously defined here using 1:1 scale in layout. Now, if you want to work with your annotation settings, you just double click on anything in this list. Now, I could run an entire course just on setting up CAD standards in the AutoCAD Mechanical Toolset. In fact, it might be a good idea. Maybe I should set up one in the library. But I'm going to double click on dimension here like so. Now, as soon as you double click on these, you start disappearing down the configure annotation rabbit hole. That's the only way I can describe it. So there's your base dimension style. You can edit that there, but you can look at all these default representations. So if I jump into chamfer, there's the default representation for chamfer dimensions. If I click there, I've got loads of different types to choose from. Now, I'm not going to make any changes there. I'll just click on cancel, but I can do the same for radius. And I can set up different settings for my radius. Again, I'll just click on cancel. I'm clicking on cancel each time because I don't want to make any changes to this particular standard. But if I go to diameter, I can set up different settings for my diameter dimensions as well. You'll notice I can ignore the AutoCAD scale factor for linear dimension measurements. So I can put in predefined text, for example. There's all the different text settings. I can add and remove different symbols in the dimension text. It goes on and on. So for example, if I've got a fits list, there's the default representation. I can pick whatever I want for that particular default representation. It goes on and on and on. Now that's just for dimension settings. If I click on cancel there, and I perhaps jump into whole charts, of which we've got one in the drawing, if I double click there, there's my whole chart settings, loads of annotation settings, things like text style, line spacing, heading text heights, where do I position the labels, and so on. If I jump into drawing sheet, there's all different settings for what drawing sheet I'm using. There's the revision there. I'm using the ISO 5457 standard, and there's the default paper format. It's an A3. I'm using a particular title block style, a particular revision list style. It goes on and on and on. You can use views created from limits. You can have views where the limits are set to corners. Honestly, you could disappear down a rabbit hole here so quickly. You'll notice you've got other parts here as well to the elements in the standard. What about a parts list? If I go to parts list, there's all the settings for the parts list. We're almost moving into kind of database territory here with property, caption, data type, and that all relates to a particular ISO standard as well. So I'll click on cancel there because I don't want to make any changes. But you'll notice that all of these settings are in this AM standards tab. And I can create a whole new standard just by clicking here. I can give it a name, and then that name will appear in the list. There's all my different standards there. There's my company XYZ, which is the one I'm using at the moment. And I can go in and create any number of standards, like I said, for any number of projects. Could be a national standard, could be a company standard, could even just be an internal standard that you apply to third-party drawings that come into your company, for example. Now, all of that is in your options. And like I said, you can have as many standards as you like, but these standards pretty much automate all of these particular standard elements when you're working in your mechanical drawings in your AutoCAD Mechanical Toolset. I will just click on cancel there because I don't want to make any changes, and I'm back now into my mechanical drawing. In the previous video, we talked about how we could configure our annotation in our AutoCAD Mechanical Toolset, and we went into things like the standards and what we could edit in the standards and so on. Now, we're in a new drawing and we're going to talk about how we can configure our bill of materials, our BOM. And the drawing is called configure_BOM.dwg. You know the drill by now. Download it from the library to follow along with the video. Again, like we did in the previous drawing in the previous video, make sure you're in the Layout 1 tab for the moment. Now, when you're in the Layout 1 tab, you can see that all the balloons have been placed. We've got our parts list here, which comes off of our bill of materials in our drawing. Now, in order to manage our bill of materials, if I go up to Annotate here on the ribbon, there's our BOM panel, and I can place a bill of materials. I can add part references. I can also add a parts list. Now, what I'm going to do is click on BOM, like so. And there's our bill of materials for this particular drawing. Now, if I click here, like so, there's the parts list, click on it, and there's all the information there. If I click on OK now, can you see that that parts list is the same shape that the one is already on the drawing? Because I've already placed the parts list. I'm just going to hit escape once, and that will take me back to our bill of materials here. And also, if I click here, I can click on balloons and I can add a balloon. I can select a part or an assembly and add a balloon. Now, you'll notice that the objects have already got balloons associated with them. So there's not a lot I can do there. Everything's been done. Now, what I can do there is just hit escape a couple of times, like so, and come out of the bill of materials command, the BOM command. And you would have noticed a little flash there where the bill of materials closed as well. Now, again, all of this is set up in your options. So things like your parts list, your balloons, and your bill of materials are set up in your options. So again, it's a right click and we go down to options and we go to that good old AM standards tab again that we used in the previous video. We're still using the company XYZ standard, and there's BOM, parts list, and balloon. I'm going to double click on BOM first. Now, there's a lot of information in here. Now, don't get sort of daunted by it or anything like that, because a lot of it can be set to default values. But you can see there, for this particular company XYZ standard, based on ISO, International Standards Organization, which means it's obviously metric, I'm using this particular revision. I'm using the ISO 7573 standard 2008E. And these are the available component properties in the AutoCAD mechanical toolset. They're all the ones I can use there, like so. Now, those properties are added here to either the bill of materials, the component properties, such as name, description, standard. I've got bill of materials there. There's all the ones I can use in the bill of materials. There's all the ones I can use in the parts list. There's all the ones I can use for the balloon. So you'll notice with the balloon, I've got component properties, drawing properties or functions I can apply there. I've got bill of material units, description, item, etc. I can add those and I can have an expression, use a one or quantity, and I can use a default style of balloon here. I can have a custom style. I might set up a particular block as a style, for example, for my balloons, but the custom style or the standard style, it's up to you. If I click on this little button here, you can see there that, again, I'm disappearing down that standards rabbit hole again, where we've got the balloon settings for company XYZ based on ISO. There's all the different balloon types, size factors, horizontal spacing, vertical spacing. The list goes on and on. I'm going to click on cancel there, and I'm going to click on cancel again just for the BOM settings. If I go to the parts list settings in the standard, surprise, surprise, it's the same dialog box. All it's done is it's opened up the parts list tab here, like so. If I cancel that and I double click on balloon, you'll see again, I'm in the balloon tab. So literally it's BOM, parts list, balloon. Those three tabs there, and those are what are controlled here by BOM, parts list, balloon. But that's how you set up and configure your bill of materials, your parts list, and your balloons. And again, it's all based on that preset standard in your AutoCAD mechanical toolset that your drawing is using at that given time. So you can see there, we're using the company XYZ standard. If I used a different standard from the list, these settings for BOM, parts list, and balloon would obviously be different because I'm using a different standard. So again, I'm going to leave you with this and let you explore this on your own. Because like I said, I could literally probably create a 2-day course in the classroom on AutoCAD mechanical standards and just go through how to set up a standard and make it all work with all these standard elements working through the list to get a standard that creates a readable AutoCAD mechanical drawing in the AutoCAD mechanical toolset. We're starting a new chapter now, and we're going to take a little look at some of the new features that are available in AutoCAD Mechanical 2023. So that's the 2023 version of the AutoCAD Mechanical toolset. Now, we're going to take a look at the new additions to the trace function in AutoCAD and also AutoCAD Mechanical, because this applies to both of them, the regular AutoCAD and the AutoCAD Mechanical toolset. We've got a drawing for you. It's called pump001_subassembly.dwg, and you will recognize it from previous videos in the course. Just make sure that you download this particular subassembly drawing for this particular chapter. Now, at the moment, I'm in the AutoCAD Mechanical Toolset 2023 version, and you'll notice up here that I am signed in to my Autodesk account. So that means that I can, up here in the Quick Access toolbar, open files from the web and mobile folders and save to the web and mobile folders. I can also use other cloud-based storage providers such as OneDrive, Google Drive, Box, Dropbox, etc. I can also link to things like Autodesk Docs, BIM 360, all that kind of stuff as well, using these connections here, using the web and mobile folders. Now, this particular drawing that I've got open at the moment is a completely clean, pristine drawing with no traces in it at all. Now, if I go to the Collaborate tab here and click on the Traces palette, you'll see that there are no traces in this particular drawing. Now, what I might do is, I'll close the Traces palette for the moment, is I might go back to the Home tab on the ribbon, and I'm going to go up here, and what I might do is save this particular drawing to the web and mobile folders, or maybe my OneDrive folder, something like that. What I can do then is work with AutoCAD Web or AutoCAD Mobile. AutoCAD Web is a web-based version of AutoCAD. AutoCAD Mobile is a mobile version of AutoCAD that you can use on a phone or a tablet. And I can use a simplified version of AutoCAD to add new traces to my existing drawing. So what you've got to think about here is that this drawing here, the pristine one, has been saved to that cloud-based storage area. What I'm going to do now is I'm going to close this pristine drawing. And you can see it's on the C drive. Look, C is the start of the path there. It's a big long path, just ignore the path, but it's on my C drive. So I'm going to close that drawing. It will prompt me to save the changes. I'll just say yes to that, like so. So that particular drawing didn't have any traces in it. But if I now go up here and open from Web and Mobile, where I've got a cloud-based version of the drawing that somebody's been working on site perhaps, if I come all the way down the list, you can see I need to tidy up my folders in the cloud. I've got lots of them. But if I come all the way down, there's my Pump 001 subassembly drawing there. So if I open that up in AutoCAD, bear in mind it's been edited in AutoCAD Web. Now you'll notice I do get a little warning here. This drawing was last saved outside of AutoCAD Mechanical. All structured objects modified or deleted since the drawing was last saved in AutoCAD Mechanical will revert to their previously defined state. Objects added to the drawing will not be affected. I'm just going to say yes to that. That's absolutely fine at the moment because I'm not too worried about the mechanical aspect of the drawing. What I'm worried about is the traces on the drawing. Now, this drawing that I've got open now is in the cloud. If I go up to the Collaborate tab and click on the Traces palette, you'll see that there was a Shaft Calcs 001 trace added today by myself. When I click on it, there's the trace there. So I've added that trace just to say, can you check the Shaft Calcs on this particular drawing? And what I can do there is I can then close that particular trace there like so. And what I've done is I've closed the trace. It still exists in the drawing like so. Now, what I wanted to show you that's new in the 2023 version of the AutoCAD Mechanical Toolset is the ability to add traces from the desktop version of the AutoCAD Mechanical Toolset. So what I can do now is I can add a trace all of my own, like so, create trace, and I'm in the trace area like this. So I can now go to the Home tab, into something like the Draw panel. There's the revision cloud. I'll go there and I want a rectangular revision cloud. Now I'm going to right click, check my arc length. I'm going to set that to say 5. And I'll pop a revision cloud just around this area here like so. There you go. Click again. There's my revision cloud. I then might pop into something like the multi-line text or single line text here. I'll just do some single line text for now. And I'm going to do some text that is M5. So there's some multi-line text object there of 5mm height. I could do that. And I'm just going to pop that sort of above there and click and drag. There we go, like that. And what I'll do there is I'll do something like check threaded hole. So I'll pop that in there. Check threaded hole. And then I'll just click away. There's the text, check threaded hole, and there's my trace there. There's my trace 2. I can rename that, and I'll call that something like thread check 001. press enter to confirm. So I've added another thread check there in that particular trace. So if I click on the tick there, that closes the trace environment. I've got two traces now, one that was created using the AutoCAD web app. I'll close that one. I've now got one that was created using my AutoCAD Mechanical toolset on my desktop as well. So that's one of the newer features with the trace command, is I can now add traces using the desktop app as well as the mobile app and the web app. I'll just close the trace environment like so, and then what I'll also do is close the traces palette. Now what I'm going to do here is I'm just going to zoom out a little bit, and I'm going to save this drawing in here like so. So if I click on there, I'm going to save it to web and mobile, come down the list, I'm going to overwrite it like so. So I've got that new trace as well, save that, and I'll replace it. So it's got both traces now saved to the cloud-based drawing. And then something else I might do is I might do another save as now and save it in my exercise files. There's the new features there, like so. Save it over that sub-assembly drawing that I've already got that hasn't got any traces. So when I click on save now, I'll overwrite that one as well. I'll just say yes to that. That's been overwritten. So now the drawing that you will find in the library will have those traces in it. So when you open up the trace function, when you go to collaborate and the traces palette, you'll see those two traces applied to this particular drawing. We're staying in our pump 001 subassembly.dwg file. And I'm not too worried about anything mechanical in the drawing. What I want to show you is the new functionality available in the count command in AutoCAD, where you can count the number of blocks in your AutoCAD drawings. Now, this new functionality in the count command is available in regular AutoCAD and any other AutoCAD toolset. You'll find the count command on the View tab on the ribbon, and there's the count palette there. So when I click on count, it'll open up the count palette. Now I'm just going to close that for the minute. I'm going to zoom out slightly because what I want to show you is very, very simple. I'm going to go to the count palette like so again and open it up. And you can see there that there's two blocks in this particular drawing. There's the DIN A3 title block, and there's the DIN title, the title details, this little block here. Now, I want to create a table that lets me know how many of these A3 title blocks and the title block itself are used in this particular drawing. So I'm going to click on Create Table. And as soon as I do that, I can just tick the box and select all of them to go in the table, click on Insert, and there's my little table just there. I'll pop it there in the drawing. So if I zoom in now, it's telling me that DIN A3, I've got one of them, DIN title, I've got one of them. And the nice thing is, this table will update based on the number of blocks in the drawing. Now, I'm just using some very simple blocks. It's literally a title block and a sheet size, an A3 sheet size. So if I select that block there and the title block there, like so, I'm then going to go to the Home tab, and I'm going to go to the Modify panel, click on the flyout, and just use the regular copy command, not the power copy. Click on Copy, and it duplicates the objects. So I'm going to click here, use that endpoint snap as the base point. I'm going to copy that over there like that. And I might even copy and pop another one down there like that and press enter to finish. I've now got 3 of each. So if I zoom in now, you'll notice that hasn't updated yet. But if I do save the drawing, can you see the table updates with the number of blocks? Now that's the regular count functionality. Now what I'm going to do this time is I'm going to select a certain area of the drawing to do a count. So up here now, can you see here, I can count in a specified area. So if I now click there and I specify the first corner point of the count area, if I click there and drag there and click there, that'll allow me to count what's in that specified area. Notice I've only got 1 of each. So if I close that again and then go, see I've got 3 of each there, like so. If I go back to my area now and go in here, there's my area there, like so. So I've got an area and I can select it wherever I go. So if I just hit escape a moment and go area, I'm just going to zoom out slightly and do a new count area. So I'm going to go like that. There's my new count area, and I've got 3 of each, like so. Close that, go back to my count area, new area here, like so, and I've got one of each. So I can count the number of blocks in any area in my drawing. Now, I know I'm only using title blocks here. It's a very, very simplistic example, but if you've got any blocks in your drawing, obviously it's quick and easy to count them like so. I'm going to close the count environment like that. I'll just delete those. I don't need those anymore. So I'll erase those, double click on the wheel to zoom extents, and close the count palette as well. Now I don't actually need that little table there anymore, so that can be obviously erased as well. That was just to show you the number of blocks in the drawing. But that's how the count functionality has been updated in the 2023 version of the AutoCAD Mechanical Toolset. You can now count in areas and obviously work in specific areas and count specific objects. Once again, we're staying in our Pump 001 subassembly drawing. And I just want to show you the floating drawing windows capability that AutoCAD and any AutoCAD toolset has. So right now we've got our Pump 001 subassembly drawing open. You can see the File tab up here, top left. Now if I click on this little plus sign here and create a new drawing, there's my new drawing there. So what I'm going to do, I'm just going to do a Save As. And I'm going to save this in the same folder as my Pump 001 subassembly. So I'm just going to call this something like, I don't know, Test DWG, for example. Now you can call it what you want. It's just a new drawing. I'm just going to click on Save like so. Bear in mind this Test DWG will not be in the library. It's just a blank drawing. So now I can click on that tab of Test DWG and drag it. And can you see I've now got a floating drawing window. Now, the good thing about this is I can maneuver this around and I can make it a bit smaller if I want to. Click and drag. Let's make it a bit smaller like that. And you can see there that I could potentially just pin that in that position there. Now, it obviously is pinned and I can move it around. I can pin it in a particular location. Now, that pin doesn't seem to be doing much right now. Well, it won't because I'm on the same screen. The whole idea of these floating drawing windows is I could drag this Test DWG across to another screen and pin it on a second screen. That would work great if I have my two monitors connected while I'm recording. Now, the problem I've got is I can't record on two monitors. Very difficult to do that. So I could move my test drawing over to my other screen and pin it on my other screen. The benefit is that you've got various drawings open at any given time, and you can have any number of tabs pinned in any location on any number of screens. Now, I run a dual monitor setup, so I might have some drawings on one monitor, some drawings on another monitor, working in a dual monitor environment. Now, at the moment, what I could do is I can just click and drag, and if I hover over that, can you see the Test DWG kind of goes a bit blue and release, and it pops it back up into the File tabs here along the top. Now I can do the same with the Pump 001 subassembly. Click and drag. There you go. That's now floating around on top of the Test DWG. And I can just click and drag. When it goes blue, release the mouse button, and there we go. It's back there like so. Now, this is great if you're working in a dual monitor environment or even possibly a triple monitor environment. I have actually seen a quadruple monitor environment as well, which is pretty amazing. But the whole idea is you've got those floating drawing windows now to allow you to distinguish one drawing from the other in the AutoCAD Mechanical Toolset 2023 version. Once again, we're staying in the Pump 001 subassembly.dwg file. I just want to show you the share drawing functionality in the AutoCAD Mechanical Toolset. Now, this has been there in this version, the 2023 version, and also the 2022 version. And it's always being improved as we go. So things like the AutoCAD web app, for example, that's always updated with each version that comes out of the AutoCAD Mechanical Toolset and the regular AutoCAD. Now, the share functionality is here. It's up on the quick access toolbar. There's share there. And also you can go to the collaborate tab and you've got share drawing here as well. Now, what it does is it creates a link that you can send to somebody to share this particular drawing. So if I click on share drawing, you'll notice it now comes up with a dialog box. It takes a few seconds because what it's doing is it's uploading the information to the web while it goes around with that little circle. Now, I can share a link to this drawing and it will include things like external reference files. The link is valid for 7 days and I can send a view only link or an edit and save a copy link. The important bit is look at the link. Can you see it says web.autocad.com? So this particular shared drawing, if somebody clicks on that link, it will open up the drawing in the AutoCAD web app in a browser. Now, the benefit you've got there is it means that people don't need the full AutoCAD desktop app or the full AutoCAD Mechanical Toolset app on their desktop. They can have a look at the drawing in the AutoCAD web app. Now, that's really useful because it's a browser-based simplified version of AutoCAD, and it means people can just view the drawing, perhaps add some traces to the drawing, like I mentioned earlier in the chapter. So you've got a choice. You can send a drawing that is view only, which means they can view the drawing, but they can't modify or save it. Or you can go to the edit and save a copy version, and people can edit and save a new version of the drawing and perhaps add traces to it, edit dimension annotation, edit geometry, etc. You can preview what you're going to send. You can copy the link directly and drop it into an email that you might be sending to somebody as well. Now, I'll leave this for you to explore and mess around with, but it's a very useful feature, allowing you to obviously share drawings with colleagues, stakeholders, other people that might be working on projects with you. So it's a useful tool. Get into that share functionality and also, more importantly, get into applications such as the AutoCAD web app and the AutoCAD mobile app. We've now come to the end of this AutoCAD Mechanical Toolset course. I really do hope you've enjoyed the course and it's been a pleasure to be in your company while you've been learning. I really do hope that you've taken on board all of the knowledge about the AutoCAD Mechanical Toolset and can apply it in your place of employment and also in your just general knowledge of the AutoCAD mechanical environment. The AutoCAD Mechanical Toolset provides a fantastic range of standards, automation, parametric capabilities, and various other tools that will make sure that you are so much more productive when you're working with your AutoCAD mechanical drawings. It allows you to work smarter, not harder. And also, more importantly, it allows you to standardize everything in your mechanical designs and tie everything down to the appropriate standards that you need to work to when you're creating your AutoCAD mechanical drawings. Like I said, I really do hope you've enjoyed this particular course in the library, and I hope you go on to use other AutoCAD toolsets and take the courses in the library that relate to those other AutoCAD toolsets as well. As I said, it's been a pleasure, and I hope to see you on another course in the library soon.